competition brief. It's too much to take in, but let me just clear it out for you. So the prizes over here were VR sets that were to be given out to the school. 10 VR sets were to be given out to the school which won this. And the shortlisting entries were very interesting, coming from the level students that were involved, and all of the entries were judged by judges in the industry, who are leaders of the industry, which are from these organizations like London Bridge Associates, Jacobs, Align JV itself, who are executing a tunneling project in London. And what came of it is this. So finally, we have the award ceremony where one of the schools from Hillingdon won it. Uh, as you can see, the award winners are very young, just GCSE students, but the level of their ideas and uh, thinking was quite engineering level there. So this is done. And after this, to give them a further path, we also organized a lecture where we told about apprenticeships, what are some of the misconceptions many young people have with apprenticeships, and how on the job training really helps people and gives a easier path into the industry where you have to pay less and get more on the job training, as well as learn new skills using latest technologies of that are available to our industry. Thank you for listening and being part of this. Hopefully, if you want to connect to us, please scan the QR code, and see you soon. Thank you.
Hi everyone, I'm Marabel Vilas, Vice Chair for 2 more weeks until I become the Chair of the BTS members for the term 24-25. Asil has presented the team, and part of our efforts go to boost professional development among our young members, and I'll go through who we are and what we are doing. And at the end of the presentation, I will share with you our email address in case you want to present something with us next year, maybe doing a joint webinar, or if you are in London, happy to do a lecture together. Also, as I mentioned, I will be the chair next term, starting this month, so feel free to contact me. Starting with the professional development subcommittee, I'm supporting Aya on this, and the subcommittee members are Aya Hassan as the chair, with Thiago Diaz, Emily Phillips, Christian, and Adam. This year, we organized a series of workshops and lectures covering diverse topics such as tunnel design, construction techniques, and project management. These events offer valuable learning opportunities and share knowledge among young members. All there are opportunities to connect with industry professionals. So this year we had some lectures and workshops, and you can still join those in green. Workshops are in person at the IC for those in the UK. Also, for the workshops, we had Benoit Jones this year for a workshop in tunneling soft ground, and Dr. Jiang Su on composite lining for SCL tunnels, and the attendance was incredibly good. We had also site visits like the one we did for the high speed 2 and the hyper tunnel, which were both very interesting, and a lot of people came. Just to invite you to present a joint webinar, lecture, or workshop with us, feel free to contact us on our email address, and you can contact me on LinkedIn, and we can maybe connect that way. And I wanted to show the committee term for 24-25. As I said, I will be the chair starting in a couple of weeks, and I will need help and support to make the BTS new members grow. So this year, I would love to see people with fresh ideas to make the group grow, and more women in tunneling also in our committees, people from other parts of the UK more engaged, trying to not to focus everything in London, and maybe try to do joint events with other young members from other parts of the world will be perfect. So follow us on LinkedIn, contact us, and we will try to organize that. This is how the committee will look like. You will find news soon about the new chairs. So follow us. And yes, just to finish, thank you all, and yeah, let's keep in touch.
Hello, everyone. I'm Asil Zaidi, and I
Good morning. My name is Leila Santos. I'm a civil engineer working at TIPSA as panel design lead in the geotechnical department. And currently I'm the chair of the Young Members Group of the Spanish Tunneling Association and part of the steering committee of the Young Members Group of the International Tunneling Society. I would like to thank the organizers for inviting me to participate in this event. I'm sure that the symposium will be of great interest to many of us and highlights the importance of encouraging young people to take part in this type of events. I was thrilled when I was contacted to share my insights into the fascinating world of tunnels, and I'm grateful to have the opportunity to encourage more women to get involved in this industry, where with effort and dedication they can achieve all their goals. As we all know, engineering has traditionally been a male dominated field. When we think of famous engineers, male names often comes to our mind, which is not surprising given that very few women work in the industry back then. However, luckily for us, this is changing, and more women are becoming interested in engineering. Even so, the few women who venture into engineering and undoubtedly have to find to be recognized, demonstrate their talent, and pave the way for future generations, challenging the standards of their time. A notable example is Rachel Parson, one of the first mechanical engineers in the UK and founding president of the Women Engineering Society, who actively promote women participation in all areas of engineering. Another example is Emily Warren, known for her crucial role in completing the Brooklyn Bridge, demonstrating her capability and leadership in this major project. These women not only made significant contribution in their respective fields, but also opened doors for future generations of female engineers to follow in their footsteps and continue advancing in engineering. Today, I want to share my experience in the world of tunnel design. Throughout my career, I have realized that every tunnel we design and build is much more than just a simple passage underground. It's a structure that connects people, reduces distance, and opens opportunities. Each project is unique due to the variability of the geology. This geological diversity forces us to constantly innovate and adapt to each environment. facing constant challenge and complex settings. The geology of each science presents us with a new set of challenges that we must overcome with creativity and precision. This variability is what makes our work so exciting and rewarding. We face the unknown, and through research and technology, we find solutions that allow us to move forward. Moreover, designing a tunnel involves coordinating multiple disciplines and working with diverse teams, from civil and geotechnical engineers to environmental and safety experts, each of us bringing our knowledge and experience to achieve a common goal. This interdisciplinary collaboration is essential for the success of our projects. We work together, sharing our ideas and overcoming obstacles to create infrastructures that are safe, efficient, and sustainable. These projects have a significant people around them. We always think about how to improve their quality of life, how to make each tunnel not only functional, but also contribute to the well-being of its user and make a positive impact on society. It is true that in this industry, we are often few women in the room, but we should see this as an advantage. If we prove our worth within the industry, we not only stand out, but also inspire other women. I would also like to highlight the crucial role that national associations play in giving visibility to young people. When we start our professional lives, the lack of experience can make the idea of giving presentations seem distant. However, young member groups encourage this initiation through conferences like the one that we are attending today, where young people share their expertise. Additionally, I believe it's essential to promote the organization of awards, such as the Young Tunnelier of the Year, to recognize those who are beginning to stand out in the sector. My experience as part of the young members group of the Spanish Tunneling Association has been extremely positive. I joined the association 5 years ago with the goal of founding a group of young professionals with a common interest for tunnels. Since then, we have grown exponentially and have promoted activities that allow young people to gain visibility within the sector, such as attending events, giving technical lectures, on-site visits to underground works, complementary training activities, and creating a wide network contest. If anyone is hesitant to join such association, I will encourage them to do so and participate actively, as it will undoubtedly be time and effort well invested in your professional future. Finally, I want to highlight something important. Each of us, as we make our way in this field, serve as an inspiration to those who are just starting. We inspire new generation, break stereotypes, and so that this is a space where, with effort and dedication, we can live and shine. Thank you very much for your attention.
Thank you very much, Laila, for such a beautiful message. I believe that many of the young female engineers and young professionals in Pakistan will uh, get a good insight from this message of yours, and they will definitely pursue their career in the field of tunneling and contribute to the betterment of the world. With that, we will move to our first keynote lecture, a wonderful presentation on novel reflections for tunneling by Dr. Joseph. All of our foreign experts and speakers, they will be joining us through the recorded message because of the different time zones. So the first keynote lecture is also a recorded message by Dr. Joseph.
Hello, everybody.
Hello,
My name
everybody.
is
My name
Joseph
is
H.
Joseph H.
Mendes. I
Mendes.
am a
I am
physical
the physical
engineer,
engineer,
and
and
it's
this
a
is a
big
big
pleasure to
pleasure
make
to
this
make this
recording for
recording
you
for
guys
you
in
guys
this
in the
symposium of
symposium of
Young
Young
Families of
Tunnels
Asia
of Asia
2024.
2024.
I want
I
to
want to
thank the
thank the
Pakistani
Pakistani
Tunneling and
Tunneling and
Trenchless
Trenchless
Society
Society
for
for
this
this
invitation.
invitation.
I hope
I
in the
hope in
future
the
I will
future I
be
will be
together with
together
you
with you
guys
guys
personally.
personally.
I like to
I
start this
like to start
presentation
this
with
presentation
basic
with
questions.
basic
I
questions.
found this
I
in
found
LinkedIn.
this in
I was
LinkedIn.
a
There was a
safety
student
officer,
safety officer. He
posted this,
posted
and
this,
he
and
was
he
looking
was
for a
looking for a
legal
legal
definition of
definition of
tunnel.
tunnel.
Okay, he was doing some job. He was looking for it. He didn't find it, so they put this to the tunneling society. There were 7 comments done. Okay, you see it here. I will not show all of them. I will show only 2 of them. The first one from some specialist, he mentioned here the guideline for equipment operating road tunnels. Consider everything to be a tunnel that is longer than 80 meters and somehow engages the roadway. You can imagine the other comments were pretty similar from this guideline or from this normative. However, the one I really liked, and I want to show you, was this one. A long cylindrical hole through the ground with a geologist in the middle and a group of lawyers at each end. Of course, this has a very broken statement. However, if you consider, we see the key for this statement is quite true. Geological uncertainty plays a big role in tunneling excavation, and it causes serious troubles between all parties involved, so owner of the project, contractors, and the supervision. Of course, I put my like to this definition. As a geologist in tunnel geophysicist, I know that this is not far away from the truth. So what may happen? So we are in tunneling. We are in a tunnel, so we have exposed to this geological uncertainty, and we don't know exactly what is ahead. And in many cases, these situations are happening. While tunnel collapse from the face, we have collapse in some areas of the tunnel, even after installing the rock support. Keep in mind rock parts phenomena. Water ingress, one of the most difficult situations to handle and also to detect in advance. We have some flowing material here. There is some belief, I got this from a colleague of mine that said so many people they want to take the risk as a challenge and not managing this risk as a threat. I know we are engineers, you are young engineers, and of course we will overcome all challenges. But it is better to manage things, manage this risk as a threat. So we know it may happen. We could use tools, we could use methods in order to avoid the occurrence of these situations as much as possible. So, what are the possible geological investigation during tunneling? Okay, we have phase mapping, not actually an investigation, it's a documentation. However, the geologists after doing all this phase mapping, having this initial geological model, they can really make predictions about how is the rock condition, the few meters, because they have this three-dimensional context of the geological structures around the tunnel. Top drill, the classical methods. So I've summarized here just percussive or extraction, and it's the most used method. And there are some shortcomings. One is the execution time. If you want to make a long short drill, you need to stop the phase for production for many days. I know for 100 meters, you need like 5 days downtime. This costs money, of course. And the other thing is that you get punctual information, okay? And sometimes correlating this punctual information with these three-dimensional structures is cumbersome. Another techniques nowadays are the field parameters analysis. So you have all these jumbo, even TBMs, they are collecting parameters like penetration rates, core, whatever of the drills. This can be analyzed. Of course, it's correlated to the rock mass condition. For instance, if I take a high penetration rate, meaning I'm drilling in that moment through a softer ground, for instance. So all this can be analyzed. We can apply artificial intelligence method. Other things we analyze only, let's say, the depth that we have, for instance, 10 meters, 50 meters ahead of the face. The other big group then will be the geophysical methods. You have seismic, electrical, magnetics, georadar. In tunneling, I would say seismic and georadar as the most used one. And in this case, we can really get three-dimensional information, not only ahead of the face, but also around the tunnel. For today, I'm going to talk about the Amber Tunnel Seismic Prediction System, the TSP system. In this method, so you can imagine this is the tunnel. We need some sources. These are boreholes in the tunnel wall. In this borehole, we are going to use small explosive charges, and it will generate a signal, a wave that is traveling through the rock mass, and it will be reflected in those areas where we have a change in the physical property of the rock. Okay, this is reflected, and then we can record this using some receivers. So basically, what we do is to estimate the velocity of the P and S wave. P are the primary waves, so they travel fastest through the ground. The S wave are the secondary or shear wave, they travel a little bit slower through the ground. But we record all both, and we can evaluate both. So basically, then we can detect geological changes, not only ahead of the face, also around the tunnel, in the place where we have this layout, but we focus, of course, ahead of the face for tunnel purposes. And if we have the P and S wave velocity and we have a representative density, then we can estimate the geomechanical parameters. So which one? Young modulus, here modulus, bulk modulus. In this sense, we change from the geophysical word to a most engineering word, so language. The system is very easy to use on the field. You need to prepare these 24 shot holes. We have 4 boreholes for the receivers. We do the data acquisition between 15 to 90 minutes only. We can get up to 150 meters expedition range ahead of the phase, and the results are delivered 4 to 5 hours after excavation. You can imagine if we go in the morning in the tunnel, we made our data acquisition, we go out, we have some lunch because we're hungry, and after that we start to work and process it. At the end of the day, at the afternoon, we have the results. So for the next shift, they already know what is coming. I want to show you now fast one case study from a water transfer tunnel in Peru. And it was in northern Peru, Trujillo. There were 5 tunnels. In total, 4 kilometers, conventional method, drill and blast, and they performed about 18 campaigns. I was there for the training, and after for a follow-up, we were working this restitution tunnel of 2.6 kilometers. This is the geological forecast. That was the position of the head of the face at the moment we went there. So they were excavating from left to right. We see here we are in the Andean mountain range. Basically, we have in this area volcanic intrusive rock and volcanic sedimentary rocks. Okay, so we were a little bit far away from this tunnel here, but yeah, that was the position. The methodology, okay, typical data acquisition. We made single shot recording, so one shot after the other recording. You can see that in this looping video. This is the geometry input in the software, so we represent the layout in the software, and then we do some numerical modeling for getting the results. Here, I will explain this. This x-axis is tunnel meter. Then here we have different lines changing color. This is the velocity of the P wave, velocity of the S wave, the ratio of these two velocities, the young modulus and the shear modulus. The lower figures, here is the longitudinal view. This is the excavated tunnel. You see it here with the 25 shot holes on the 4 receivers, and this is a plan view. Okay, so let's focus first on the reference area. Okay, we have values. This constant chart line here are values for each parameters. EP is here about 5,700, so very nice parameters start to change. This is due to these reflectors you see here. This is an area where we got reflections back from those areas to the receivers. Okay, we interpret this. Now we cluster all this. We can easy this analysis. I create in this case 3 sections just to make it clear for you guys. You see here, we know the rock mass condition in this area, so these values I get in the reference area are automatically representative for that. In this case, it was a moderate volcanic rock mass, so I know these values are representative. But we move to the first sections ahead of the phase. Now it's prediction. They increase, meaning that is the rock stiffness of the rock will increase. Now, in the section 2, all parameters go down, medium modulus goes down, so this is really correlated to the rock stiffness. So in this area, we probably have some fracture fault zone. And what's the most reflective area? You see all the reflectors are correlated here. After this area, then the values stabilize, they go against up, so even a little bit better than the reference area. Now we can see with the logs of the geologists. You see here we have alternating sedimentary and volcanic fracture and moderately altered. Okay, the rock mass strength is moderate, so not a bad rock. Here start the problem. So there are some occurrence of various geological structures, sedimentary rocks with low angle stratification, so the risk of fall down material is high. There were some contacts and a minor fault system crossing the face subvertically, showing a high weakening of the rock mass. After that, and the rock increases, so pretty similar to what we have before. So now we know this is the critical area. They use also another type of tools to measure the rock strength. We're using televiewers as well. And in their analysis with this another tool, they also identified these three sections, section 1, section 2, and section 3. So the trends of these two different methodologies are quite similar. The three, now the RMR mass rating classification, we can see then that they were using they had parameter 3 or type 3 for this area where we have this increasing, and exactly for the area where we have this problem, we've got this problematic area, they have a RMR of type 4, and after that again we have the 3. So very nice example how this match everything. This is the 3D model simplified with planes, where we see clearly this minor fault, and we see this sedimentary less competent rockworks. So the conclusions from the case study, 3 major seismic zones were defined, which are in good agreement with the other method they were applying. Also, the geological findings corroborate the seismic results in almost entire prediction range. And I have a couple of final comments for you guys. Geological exploration during excavation stage as part of root risk management. So we need to keep the geological exploration, not only face mapping, we need to keep the geological exploration during the excavation phase. Please remember there is this uncertainty of the initial geological forecast. Seismic methods are a really good complementary tool, okay, for doing that complementary. So we need to combine it with other methods, and also we need to validate it with prop drills. But we don't have to do these long prop drills. We know the areas where there may be problems, and then we can do short prop drills at these areas. PSP, this tool for number technologies, it has decades of development. It's really reliable, fast, and a safe tool. And please keep in mind, no tool or method eliminate the uncertainty, but it helps to minimize. So let's manage the risk and not take it as a challenge. This is all I wanted to show you. So tunnel is really should not be necessarily a risky job. Enjoy doing tunnels, enjoy getting data for making geological exploration, and enjoy the rest of your symposium. Thank you for your attention, and take care.
Thank you very much, Dr. Joseph. It was really an insightful presentation, estimating the geological formation with the great velocity of the blast. That must be some mumble jumble of plenty of algorithms that you guys have come up with. But anyway, the online participants and the physical participants, if you will carry any question on that presentation for Dr. Joseph, please record it with us. We will forward your questions to him, and of course, we will come back with the questions and answers to you. You must be observing that we are not going as per our schedule. Don't worry about that. We will make some small adjustment as we as we move forward. Last in the opening session, we have the first live physical presentation. Next keynote lecture by Dr. Mohammed Ishaq on pioneering the future of tunneling in Pakistan. Dr. Saab, the stage is yours. Assalamu alaikum, good morning, good evening, and everything because there are so many people from the United States who are online. There are a couple of people from Australia, a couple are from UK, so I don't know what this small conversation is going on. So, is it really so? It's pioneering and that in Pakistan? No, I don't think so. I'll tell you a little bit. This is not that much technical. I'm 100% sure that you will not get a single question after this. But still, I want to just let you know what is happening in Pakistan in terms of tech. So, what I'll talk about, a little bit about myself, who I am, what I'm doing now, what is my aim, what I want to do in the future too. But at the same time, I want to inspire my young elders. I want them to follow me at the same time. Definitely, I will be a resource person for all academia because I'm working in industry now. At the same time, I'm a person who can be, who can be asked to have some good interactions with academia too. Because the academia, from academia, I want students to come and see what is happening in the ground. At the end, I will just close with a small future perspectives for coming in Pakistan itself. So, who I am? I'm Dr. Saab, one of my teachers is sitting here. For him, I'm just Ishaq. From my education point of view, I studied my undergrad and then in National University of Science and Technology, Southwood campus. I moved to Columbia University for my master's in civil engineering. At the same time, I did this civil engineering focus with engineering mechanics.
Rajat, are you there? We
We
cannot.
cannot. Yeah, I can hear you, but now can you hear me? Can you hear me? Yes, sir, they are audible. Okay. So then I moved to Coral Mines for my PhD.
Hello,
I
sir.
Hello, sir. Yeah, yeah. Can you hear me now?
Hello.
Hello. Yeah. I'm hearing you.
You,
It's loud
can
and
you,
clear.
sir, your voice
Your
is
voice
voice
is
is
voice. Okay, I'll keep mic in my hand so that you can hear me clearly. Is that so? Is that okay? Now it's okay? Yeah, I think technical glitch always happen in advanced world. Don't worry about it. So and then I completed my education. I came back from US, joining directly German Varsity. So I'm very happy that I'm part of Mr. Asif's team, who is working in underground construction. I'm leading a project for all the components which are being done by Frontier Works Organization. So there are a couple of tunnels which are there, and I'd love to see some
Assalamu alaikum,
pictures
sir.
from university.
It's me,
And
Zafar
I'm really
Alam,
very happy about
and
it.
I can't hear you.
So
Your mic is off.
you can see my swords in the ground. This is my jumbo. If I can show you, yeah, I can show you. So this jumbo, there are two swords in the ground. These are doing the rock bolting, and at the bottom you can see a couple of people working on the wire mesh.
Couple
And
of
then
people working on the
there's a
wire
jumbo
mesh,
also working.
and then there's a jump also working simultaneously in
Mr.
the
Asif was
tunnel
online.
where Mr. Asif was in line.
So this is there's a small video. I'll skip this because there's very little time with me. I'm between you and your coffee break. I'll not waste your time more. Next. Next please. Oh. Oh, okay. So what I did is, can you turn on this video because I'm not be able to push the button here. Yeah, center one and the bottom one. These right two, those are videos. So my research was on rock cutting. You can see this is a linear cutting machine
Assalamualaikum, sir.
which is cutting the
My name
rock.
is Usman Tanveer. I can't
And
hear you. Please open the mic.
you're the only one I think who's not hearing. Other than there are a couple of participants who can hear me clearly. So might there is a problem with you there online or some kind of a problem in your computer. So what is happening here is I'm cutting potash rock here. This is a linear cutting machine. This is a full scale cutting which we are doing. And this was particularly to optimize this machine, which is on the top. There's a YouTube video of that machine itself. I was working on optimization of this cutting tool, and this is the cutter head you can see there, the 3D model of that. And what is my goal? My goal is to give a base knowledge, whatever I have, and I want to get the knowledge which you have, so that we can get together and we can take our country forward. Because tunnels are much more important than sustainable population. Next. So, are we really finding? We are really pioneering the thing. Uh, it is. This is a very interesting thing that since 1888 we are actually constructing the tunnels here. So from 88 till 91, this tunnel was being constructed. Was a tunnel in Pakistan, and there is a
Hello.
significant
Please,
portion
we are
of
not able
road
to hear you.
infrastructure now on
Open the
KVH,
mic,
which is
please.
underground. And these tunnels which we did is mostly on the conventional method, drill and blast, but we were not sure like how how much we are
Hello,
old
please
in
open
this
your
engineering. So might be this is an interesting
mic. We
fact
can't
that
hear
maybe
you.
some of people might know and
Can you
some
please check
might
your mic?
not. We actually used TBM in Bangladesh in the 60s. And it's
Hello.
interesting that this TBM was used with a conveyor from the coal mine to transport the mud from cutting face to the cutting site. And this was the
Hello.
first time used here in Pakistan. So this is what happens. And you see this is on the Robbins Excel page. This note written there. But I think a couple of people we are not seeing this because there is written demonetization. That's why might be there is some kind of confusion for us that might there is other monitoring somewhere else. But this is actually here in us. And then we used TBM in Nilam Jalam project. So we are not actually
Hello,
doing
everyone.
drill
This
blast
is Young
and
Member Chair of
whatever
Pakistan
is
Tunneling and Trenchless Society. Sorry for a little glitch. Our technical team is
so
working to reset the
what is
mic.
the
Please stay
goal
with us.
of
Thank you.
young tunnelers? We want fresh perspective from you. We are industry. We are contractors. We want some fresh minds from this room and might be from universities. It might be from the classes of some faculty
It might be
members.
from the classes of some faculty members who are sitting here.
We want skilled people.
We want skilled
We don't
people.
want just civil
We don't
engineers.
want
We
just
want
civil
tunneling
engineers.
engineers.
We want tunneling engineers
Because
in the
I'm
tunnels.
now teaching civil
Because
engineers.
I'm now teaching civil
It is very
engineers in the
difficult.
tunneling.
I want tunneling engineers to
It is a very difficult thing.
That's what
I
I
want
want.
tunneling engineers to tunnel. That's what I
I
want.
want everybody in
I
this
want
room to accept the
everybody in this
adaptation
room
of advancements, what
to
is
accept the
happening,
adaptation
why
of
it is happening,
advancements, what is happening in
what
the
we can
world,
do,
why
how
it
we
is
can
happening,
proceed further.
what we can
This is
do, how we can proceed
I
further.
want in this industry
This is
itself.
what
And
I
that
want
is
in this
what my
industry
goal is.
itself.
I
And
want
that
to
is
push
what my goal is.
myself
I want to
to
push
help you out in any aspect because I'm in the industry, I can be a resource. And there are a couple of other my colleagues are in the industry. They can help you in all aspects you want. So
myself.
we might be some kind of source, but
We
I
might be some
cannot
kind
myself
of
be a mentor.
source, but
There
I
are
cannot
people
myself can be a
in this
mentor
room also.
because there are so many mentors in this room also
So I can be a
in
resource.
Pakistan too.
I can help you
So
out
I
to
can be a
reach that
resource.
place
I can help you
where I
out to
want,
reach that place
some
where I
young
want,
people to come in
some
and
young people to work in the tunneling itself.
We need to educate the sustainable
We need to
infrastructure.
educate the
We
sustainable
still don't
infrastructure.
know
We
the
still
tunnel
don't
is the
know
only
the
sustainable
tunnel is
infrastructure
the only sustainable infrastructure we need here
we
in
need this
Boston.
not in
We need
mountains,
this
we
not
need
in
this in cities,
mountains, we need this in
but
cities,
we don't know.
but we don't know what is happening all around.
We need to engage
We need to engage
my students.
in a
I want
networking.
every
My
student
students, I
to be
want
networking
every
each other,
student to be
and I
networking
want that
each
I
other.
can be a
And I
person
want
to
them,
help you out
I can
to
be
reach to the
a
people in the
person to
world.
help you out
I
to reach to
know
the
a
people
couple
in the
of
world.
people who are
I
working
know
in
a
other
couple of people
fields
who are working in
in the
other
world.
fields
So
in the world.
I can
So
be a person,
I can be a
I can be a
person,
resource
I
for
can be
you
a
guys.
resource
And there
for
are
you
so many
guys. And
other,
there are so
like
many other,
Ashrafi
like
himself came
Ashraf
to
P
Colorado
himself
School
came to
Mines,
Colorado School Mines,
and he spent I think
and he spent I think
4 days there
4 days
in
there in
one of the short course. It
one
was
of the
very
short
interesting to
course.
see him
It was
there,
very interesting to
and
see
it
him
was
there, and
surprising
it
for me to
was
see him there
surprising for me to see him there
because
too.
never
Because
happened
never happened
before me.
before me.
Or a
Or
colleague of mine,
a
Awais,
colleague of mine,
he
always
might be listening.
he might be listening.
So, what are the
So
challenges?
what are the
Challenges
challenges?
are
Challenges
literally
are literally
more of
more
what we
of
think
what
that it
we
is a
think
challenge.
that it is a challenge.
It is access to
It
the
is
modern
access to the
technology,
modern
but it is
technology.
not
But it is not
it should not be a
it
challenge.
should not be a
Still,
challenge.
it is a
Still,
challenge here.
it's a challenge here.
Limited funding and
Limited
resources.
funding and
It's a challenge
resources.
here. We
It's
feel
a
that it is
challenge
a
here. We
challenge.
feel
It
that
is
it is
not
a
a challenge
challenge. It
actually.
is not a challenge
It
actually.
is not a challenge actually if
It is
you
not a
are
challenge actually if you
linking
are
yourself, networking
linking
in
yourself,
between yourself.
networking in
That
between
is not a
yourself.
challenge. You can
There is
reach to
not
that
a
point.
challenge. You can reach to that point.
So opportunities.
So
As I told
opportunities.
you that there
As
are
I told you
engineers
that
in our site,
there are
not only
engineers
in
in our site,
part
not
of
only in
project, but also with our
part of the
lead partner.
project, but also with our lead partner.
Civil engineers are there.
Civil engineers are there working in the company.
So might be
So
there are a couple of civil
might be
engineers
there are a
here.
couple of
They
civil
will say
engineers
like, hey,
here.
why did
They
you
will
not
say
tell
like,
me?
why
You
did you
can
not
do
tell
that.
me? You can
But a
tell me.
person with a little bit
But a
more knowledge of the
person
ground,
with a little bit more knowledge
he
of the
will
ground,
be,
he will
a fast
be,
learner there.
a fast
He
learner
will have
there.
a better kind of
He will have a better
anticipation
kind
for
of
his future there.
anticipation for his future
And
there.
that's what we
And
need to
that's
push
what
our
we need to
academia
push
to.
our academia to.
So emerging trends
So
are
emerging trends
more
are more
in our sense it is
in our
sustainability.
sense, it is
It is the automation
sustainability,
and what
it
is
is the
AI.
automation and what is
Nowadays AI is
AI.
the one
Nowadays
which
AI
is
is the
leading
one
us in
which is leading
underground
us
also.
in underground also.
So we need to push our
So we need
boundaries
to
in AI
push our
and
boundaries in
then
AI and then
within
to
our own domain of talent.
within our
Then
own
the
domain of
smart
talent.
tunnels integrating
Then the smart tunnels
our
integrating
system.
our
Our
system.
system needs
Our system
integration
needs integration
altogether, not only in urban,
altogether, not only in urban, in
it should
rural,
be in every
it
component
should
of infrastructure.
be in every component of infrastructure.
So careers in tunneling is
So careers in tunneling
what I say is
what I
very
say
diverse, starting
is
from
very
geotechnical
diverse, starting
engineers
from the geotechnical engineer, civil engineer,
and
and
go to the mine
go
component of
to the mining
ventilation,
component
where we
of
need a
ventilation,
tunnel
where we need
ventilation
a
engineer.
tunnel ventilation
And
engineer.
then there
And
is
then
much more
there
scope
is
in
much
Pakistan
more
for
scope in
the construction
Pakistan
manager
for
of the tunnel.
construction management
There's
of the
none.
tunnel. There's none.
Then we need a risk manager
There
of
we need
tunneling.
a risk
There's
manager
none.
of tunneling.
There
There's
we
none.
need urban
There we
infrastructure
need
planner,
urban infrastructure planner,
particularly underground.
particularly
There's none.
underground. There's none.
So we need to push
So we need to push
these areas
these
in our
areas
part,
in
like
our
how we can
part,
push
like how we
these
can push
all areas.
these all carriers.
So the
So
strategy should
the
be
strategy should be
not
not
only
only just
as a
me
contractor
as a
working on the
contractor
ground,
working on the ground,
but
but
you
you as a academician.
and there are
And
industry
there
partners
are
of
industry
ours
partners of ours.
there
There
we
we
need
need a government to put in,
and government to make
and
some
government to
policies.
make some
The
policies.
policies
Those
should
policies
push us
should
to
push
make
us
these
to make these
student organizations
student
within the
organizations within
institution.
the institution.
And I'm very
And
proud.
I'm very proud.
You can see on my
You can
back there's a
see on my
TBL,
back there's a
ground
TBL and
support
ground
system.
support
On my
system.
front there
On my
is
front there
UCA
is
from
UCA
SME.
from SME.
I spent 2 years.
I spent 2 years as president there in Colorado School of
And
Mines.
I saw these
And I
organizations,
saw these organizations actually,
these student organizations
these
working
student
tirelessly
organizations working
to make their
tirelessly
industry
to make
sustainable.
their industry
So
sustainable.
why
So
not us?
why not us?
We need this.
We need
And
this.
I hope
And I
some of
hope
our
that some
friends,
of our
my
friends
students,
and my students and
will get
colleagues,
together.
we will get
Make this
together.
happen to
We will
have
make this
this
happen to
student
have this
organization
student
in our
organization in our
institutions.
our institutions so that we can get the person requisite with requisite skills in the ground. So that's it from my side. I thank you. If you have any kind of question from me, I'll send you my email. So you can send me the email also. But at the same time, I'm very happy to have people in person visits to the field. Thank you very much. Krishna, I have a question for you. Of course, you can come, we'll send it to your cause. I'll be there, I'll be doing this, will be doing this. But for those who have little knowledge of how to get engaged in these activities, what would you tell them how to become member of this cause or the drive that you have taken an initiative for? That is very awesome. Like the PTTS, I got this email because I it's interesting that I have been part of the team of Mr. Asif since 2015. And a couple of my friends, they are very close to him, and that's why we had a very good association there. So he sent me the PTTS labs. What do you mean by this? What they want to do? So this PTTS itself, I feel like this is actually a body which we need to push forward to make this kind of initiatives for us. Like in United States, in North America, this is a underground construction association. That is the industrial body actually. And then that body is pushing SME to include every component, not only the emission, not only the manufacturers, not only the industry contractors, everybody there, everybody. And within that, like there are a couple of shows which I went, and that was with the grace of Almighty, like I got the chance. There was Mine Expo in United States, which is biggest for the North America. I'm not sure about China or in Europe, but in North America, I went there and continuously for 3 days. I walked 10 hours a day. I could not finish that. So imagine like how much effort those guys have put in to just get together those all things. And this is very much possible here because we are a small country. We know that who is manufacturing what. Why we can't do that? Why this initiative has not been taken yet? That's why I named this as the pioneering. So PTTS got this good initiative that they are getting at least 4 to 5 our partners down there in downstairs. So why not all? Why not all? So there is one. I followed one of the industrial expo in Lahore. That is from today onwards, I think, for 3 days, manufacturing ones. So why not? Why not us to engage them? Why not us to have that kind of a perspective to them? So for engaging, as Ashraf already mentioned, like I can be a good source to take your students to UCA. That's what my reach is. So I can help you out to that one. And there, so many scholarships are coming for just to participate in the conferences. And there's a free of cost conference you are going there, just you are enjoying some time, and you are seeing so many people working together. So that's where we need some kind of a push. But at the same time, Ashraf is very much right. For every organization, every exhibition industry, we will definitely provide you the platform. As a contractor, I can provide you the platform to have field visits for your students. But at the same time, Ashraf is the one who is well known for the PTTS to take you to that place where he can tell us, like, okay, these are the students, I want them to be in the tunnel. Why not? Thank you very much for this organic discussion. Yeah. We are running short of time, so please make your question quick, and I'm gonna go for the coffee break. Production करना है चाहे bright side तटंली का या dark side पाकिस्तान में तारबेला कब बना था और वो जो कंपनी उसके बाद एक ही बना है वो क्या बोलते हैं I absolutely right. This is basically we are very optimistic. We know that there are problems. So what we will do is what I want to tell you is that I want to show the positive side. So there are some things happening behind the scene. There are things happening, but should we stop? No. We need to push forward our limits continuously. And we need to identify our problems. Like, what is the problem that happened? So if we identify them, I must say, like, I'm 100% sure that we will push the boundaries.
Okay, great. We have another one. That's going to be the last question for the session.
This is John. I want to ask from the PTTS people. Want to know that is there any degree of tunnel engineering in Pakistan? If yes, then okay. If not, then what is there an effort from the PTTS side to have that degree?
Also, sir, your question is whether we're doing any technical or affiliated technical or educational program within Pakistan or from the platform of Pakistan Tunneling and Trenchless Society. Yes, we do have a kind of course, but that is run by the Tunneling Institute of Pakistan. Pakistan Tunneling and Trenchless Society is actually the representative body of Pakistan in the International Tunneling Association. Whereas this facility is actually the place where we conduct our technical courses, not only in the field of tunneling, but advanced surveying, building information modeling, tunnel information modeling, and the rest of the thing.
I must be the fact that the tunnel engineering degree.
क्योंकि और वाले प्लेयर मास्टर करा रहे हैं टनलिंग
Gentlemen, we are trying to we do have that course with the duty law, but we have a 3-month certification program. We can have that prospect with the management of the institute. With that, I would request to please let's go for a coffee break, a quick coffee break, and come back maybe in 7 or 8 minutes as we are already too late on our schedule. There are online presenter who has been waiting in the online meeting lobby to present their technical presentation. So let's adhere to the time, enjoy our coffee break, and get back to the conference room in perhaps like 7 or 8 minutes or 10 minutes. Will that be okay? Yeah. And the coffee break is people from here can go downstairs in the exhibition area and enjoy your coffee break. Thank you so much.
Today we march. Let's march to success. Let's march to the free land. Let's march across its length and width to the future builders of Pakistan. Together we win.
Can become the next certified PMP. Register now and we'll make sure in next 6 weeks you become PM. You see, we have helped 1500 plus PMP for customized roadmap, daily follow-up, coaching call, best simulator in the market. And the most important thing, I work with you till you become PM. So this can be something very important if you join right now. You get the pre-training, and most importantly coaching. And you don't even have to read books. Register now and let me help you to become PMP in the minimum possible time. 99% success record.
Only because of the and request to last for you. Are you ready for it? Let's start.
150. Let's start.
Yeah, yes, सबसे बड़ी फिल्म। साथ में गाड़ी है कंपाइल है इसमें सारी वो पहले सीक्वेंस लिया था ना बाकी वैसे रख दिया जैसे था सीक्वेंस था वो सब एंड पे वो मैंने अगले पर नहीं इधर इधर नहीं किया लेकिन तो पहले वाली तो आई चली है ना सबसे पहले आपको भाई इंपॉर्टेंट कौन सा वो तो कनेक्टेड नहीं है बस ये सीजन केस है ये नाम फोल्डर है अभी तो पाकिस्तान में you want how to get over
Yeah,
yeah
no tension.
no tension
What tension?
what अभी इसके बाद उसके बाद आप नहीं हम कंटिन्यू कर बेटर ट्रेन करा इसके बाद आप इसमें सामान लेकिन चलाना शायद नहीं ये कौन सा नंबर है इसके बाद तो वो चाइना से है ना यार हमारी टर्न साथ आएंगे गलती है सही आई मुझे बैठ सकते हैं ये जो वीडियो आने देख के सारे कुछ में यार ये सब ठीक बात भी नहीं है ना अभी तक कंप्लीट नहीं है सारी ये देखिए 10 मिनट में चल रही है एक मिनट
अभी ये चल रही है 10
मिनट तो आज और जो लोग ने देखी ना वो सब बिल्कुल एक्टिव मर्जी वीडियोस something second उसके बाद ही होंगे
Trenchless Machine Company.
सही
Trenchless Machine Company. As a leading company in the field of designing and manufacturing of TBM machines, by identifying water shortage challenges in the recent years, decided to design and construct a mechanized micro gripper TBM machine with excavation diameter of 2,265 millimeters to provide possibility of using this technology in relevant projects. Functions of this micro gripper machine is
एकदम से ऐसा कुछ हुआ ना मुझे समझ यार अच्छा हुआ क्या अच्छा हो गया बट अभी ऑनलाइन स्विमिंग सही चल रही है आपके माइक पे म्यूजिक कैसे फिर जब मीटिंग में डिस्टर्बेंस आई फिर मैंने वो सेटिंग चेंज की शायद इधर से कुछ डिस्टर्बेंस आ रहा है बड़ा लंबी चीज़ें इंशाल्लाह समझ जाएंगे शायद को बताएं लोगों को लेकर रहना शायद शायद ऐसा को रिक्वेस्ट करें यार ऊपर से चलाना नहीं नहीं उस पे पीएस सिस्टम पे जो डालना भी है वो एक सर्टिफिकेशन आपको पता है 11:40 की कॉपी रिलीज है वो शॉर्ट का टाइम आता है ये मशहूर है You are requested to come to conference room as we are short of time. Attention please. You are requested to come to conference room as we are already short of time. Thank you very much. सर आपका लेक्चर भी थोड़ा सा आगे स्लाइड हो गया है क्योंकि पूरा प्रोग्राम का स्लाइड हो गया है लंच ब्रेक के बाद आपका पहला लेक्चर है ना और लंच टाइम तो वो दैट्स व्हाई लंच ब्रेक पूरा कोशिश करें सबको लेट्स सी यू रेट हो गया देखिए हम ये अगर हम टाइम से सर प्लीज बहुत से इसका रेट में जल्दी आप इनको दे देंगे तो सर अगर आप पॉइंटर दे देंगे तो सर साउंड नहीं आ रहा है यार जी और एक मौसम मुझे माइक दे ये देंगे सर मौसम मुझे माइक देंगे सर जस्ट रेट क्या जी सर इससे पहले भी आपने किया जी जी सर सर जस्ट ये एक मिनट यार सर उधर से मैं वही चेक करने लगा था नहीं नहीं जी सर श्योर सर श्योर As we move forward to our technical session, yes, sir. Our very first presentation is from China. Presentation will be presented by Shi Hao Lin from London University, and his topic is very interesting, which is actually research on the application of smart disaster prevention monitoring and pre-control technology in the underground loops. Shihao, if you are with us, please, the stage is yours and you can play your presentation now.
Okay, okay.
Shihao, are you with us? Okay,
Here.
perfect. You're here. Yeah, perfect.
Okay, okay. I'll report. Rashid?
We can hear you. We can hear you, Xiao.
Okay, okay. Hello everyone. My name is Xi Hao. I'm from Tongji University. Today, I would like to report to you on a research on the application of smart disaster prevention, monitoring, and pre-control technology in underground loops. This study focused on an underground loop project in China and explores how to improve the fire emergency response capability and operational safety of underground loops through intelligence technologies. This presentation will be presented in 5 sessions. With the rapid development of the underground roads in cities, underground roads are gradually becoming longer and more complex. And this not only improves transportation efficiency, but also increases potential safety hazards, such as fires that are difficult to detect and respond to quickly. And problems such as complex contractors, multiple points of access and smoke accumulation pose great challenges to fire evacuation, and therefore the development of intelligent disaster prevention and monitoring technology is important to ensure the safety of underground loops.
Underground loops generate a large amount of critical data in the event of a fire, including information such as temperature, carbon monoxide concentration, and the wind speed. However, there are currently deficiency in how to deeply analyze this data and apply it to real-time decision making, especially in terms of dynamic feedback and evacuation gestures. And therefore, it's important to improve the accuracy of fire monitoring and warming technologies. Relying on just, hello?
Can you hear me? Please forgive me to interrupt. The slide is not changing. Could you please look into that? Actually, we're still on the first slide, and I think you have moved to like third or fourth one. Could you please look into that?
What?
The slide is not changing. On our screen, it is still the first slide.
What's changing?
Okay, you can turn off the presenter mode, and yeah.
Okay.
Okay, go ahead, please.
Relying on disaster prevention guidelines and real-time data, a smart disaster prevention technology relies on fire-warming, automatic ignition, imaging, ignition, assisted evacuation, and other functions through supervised learning, unsupervised learning, and reinforcement learning algorithms. This technology system can also solve the problems of firewalling and seeing in construction that are difficult to scope with by traditional methods, providing a strong guarantee for safe operation. And therefore, we built an intelligent disaster prevention system for underground loops based on 4 AI technologies. And I will report on these 4 technologies one by one in this session. In firewalling, deep neural network accurate accurately predict fire risk by integrating multi-source data such as infrared wavelengths, carbon monoxide concentration, and other key indicators. The technology optimizes model parameters through training datasets and validation datasets to provide a full-level analysis system, including severe analysis to help control centers make quick emergency decisions. Conventional ventilation systems are usually difficult to cope with the complex traffic flow and air change in tunnels. By using the current neural network for times and series analysis, the system is able to predict the traffic volume and pollution concentration, and combined with 5G control technology, it's intelligently adjust the fan setup schedule, which improves the ventilation efficiency and ensure the evacuation safety of personnel in emergency situations. Image illumination technology provides new methods for fire detection and evacuation guidance, and deep learning-based models can analysis information about people, vehicle, ignition source, and smoke at the fire scene. Tools help the control center understanding the fire situation in real time. With this technology, the system can visualize the fire scene environment in real time and assist in the development of evacuation plans. Fire scene reconstruction involve fire source localization, temperature, flood contribution, and smoke dispersion using data collected by sensors combined with fire theory models. The local the location of fire source can be accurately determined by and dynamic visualization of temperature and smoke can be achieved. This technique can provide timely and accurate support for firefighting decisions. And training this deep learning algorithm requires building a corresponding dataset first in order to study the fire safety of underground loops. We use an underground loops tunnel in China as an engineering background and employed the computational fluid dynamics to simulate some fire scenes and constructed a disaster prevention database containing the temperature field, smoke field, and evacuation results. And this database supports the training and testing of subsequent deep learning models and provides a database for an intelligent disaster preventing system. Among them, the simulation and analysis of zone A shoots nets under national ventilation conditions. The fire temperature can reach 920 degrees, which makes evacuation challenge. However, 5 meters per second ventilation conditions, and the temperature inside the loop tunnel can be reduced to 470 degrees, effectively con controlling the spread of smoke and improving the safety of evacuation. This data demonstrates the importance of enhanced ventilation measures. Uh, a smart a smart disaster prevention system for an underground loop project in China integrates the four and technology described in section 2, realizing functions such as fire warming, ventilation control, personnel evacuation, and scene reconstruction. The system aims to improve the intelligent survival level of the underground loop and ensure operational safety. The system consists of a master control system and a web display platform. The main control system is responsible for real-time data access and processing, and the web displays platform supports post-terminal access and real-time visualization display. And the whole system realizes data exchange and information display through TCP or UDP protocol and SQL interface. In addition, the system is equipped with four core functions: environment, environment, environment science, and fire warming, fire scene reconstruction, and dynamic evacuation planning. Through this function, the system is able to monitor temperature and carbon monoxide concentration, wind speed, and other parameters in the tunnel in real time to provide emergency decision support and ensure personnel safety. This study explores the application of smart disaster prevention technology in underground transportation using an underground loop in China as an example. Through the combination of multi-source data fusion and machine learning models, the study realized fire warming, ventilation control, and evacuation guidance functions, and improves of operational safety of the underground loop. In the future, we will continue to explore new technological tools to improve the particularly of the system in complex environment and to promote the innovative development of urban safety management. We will focus on the optimization of deep learning models, multi-sensor fusion, and the development of automatic emergency response system, and the application of real-time 3D visualization and virtual reality technologies to improve the intelligence and the automation of the disaster prevention system and enhance the robustness and the adaptability of the system. This concludes my report. Thank you all the experts for listening.
Thank you so much, Shihao, for this wonderful presentation, and we look forward to seeing your research work in practical application in the Italy around the globe very soon. Do we have any questions from the participants online or physically? No, sir. Do we have any questions from
No,
the
sir. No
online
one.
participants?
No, sir.
Okay. Thank you very much, Shihab. Thank you so much for your time and this wonderful presentation. Next on our schedule is a presentation by Mubashir Hanif Abbasi, which is an exciting presentation uh, entailing the details of design and stability analysis of tunnels along uh, River Jhelum in AJK. Mubashir, stage is yours.
Assalamualaikum and good morning, everyone. My name is Bushu Anif Abbasi, and I'm a tunnel geologist. And mostly, I work as a consultant on the projects of National Highway Authority. So today, I'm going to represent about the detailed design, stability analysis, and safety measurement of 11 number of tunnels along River Jhelum, Azad, Jammu and Kashmir. These are the main features of the project, where you can see the total length of the project is around 150 kilometer, and the client is the central design office, Azad Jammu and Kashmir, and the design consultant is EMS Prime BK, and the project design cost is around 150 million, and we have done this project recently, and the completion date of this project is July 2023. So this is the location of the project, where you can see the starting point. It starts from Kohala along the river Jhelum, and it's ended. The end point is Mirpur, that is very close to the Mangla reservoir. So these are the 11 tunnel locations that are defined on a plan profile. So the main objective of the tunnel is to reduce the distance and travel time between the two major districts, which are Mirpur and Muzaffarabad. So the improved transport link will not only benefit the trade activities, but better transport opportunities to the locals, and will help the evaluating the poverty stricken areas along the project road. And it is essential that a transport infrastructure should be up to date of the standard for the timely deliver of the trade shipments. So these are the basic main objective of our project. So this is the flowchart of the project, where you can see, first of all, we have to plan the tunnel project. We have to decide its alignment, its geology. Then we have to decide the functional capacity of the tunnel. Then we have to specify code standard that is used or outlined by the client. So after that, we have to compute the load condition, and also the assumption of the lining condition, that is a shortcut. And then we have to compute the models of your design. And if the safety factor is if you get the factor of safety and it is safe and economical, then we will move for the execution of the construction project. So the design principle is based on the safety, environmental protection, comfort, and the harmony. And the primary guidance is taken from the geometric design of the highways and street, published by the American Association of State Highways and Transportation officials, and also some specification outlined by the client. So this is the geological map of the area where you can see the different ethological formation, and this project specifically lies in the Murray and Kuldana formation. And the formation of the Murray formation is almost is shale sandstone and claystone. So this is a plan profile view of the geological map of a mountain where you can see the start RD. Here is a tunnel portal and the end RD, and this is the surface file of that mountain. So these are the 11 tunnels we have designed recently. The smallest tunnel is around 93 meters, which includes sandstone mudstone of the Nagri formation, and the longest tunnel is 1.28 kilometers. So basically, this is the scale line survey where you can see where you can see the nature orientation of these continuities, where you can find the type, joints, its depth direction, persistence, aperture, infilling nature, joint roughness coefficient, water seepage, wall strength, weathering, most importantly UCS and RQD, and that will we can get from the geotechnical investigation report. Basically, these are the parameters we use to model the tunnel stability analysis. So next phase is geophysical surveys along the tunnels. So these are the 12 ERT points, electric resistivity points, so that we can get the underground information. And if there is any lithological or shear zone, we can easily get it from this profile. So electric resistivity topography and tomography is a surface geological map data where we can acquire and integrate a meaningful result for the tunnel stability analysis. And the other method is seismic refraction, where you can see the uh, velocity of the P waves, primary waves, where you can see that there is a less compacted overburden, there is a more compacted overburden, and there is a hard rock, which is a sandstone, and its primary velocity is around 3000 per meter square. So this is the basic tunnel structure where you can see the carriageway width is 7.3 meters. Its vertical clearance is around 5.3 meter. And the tunnel excavation method is NATM or TVM, and the tunnel construction technique drill blast method. So we also need to design the drainage, ventilation, lighting, and plus ITS system as well. So tunnel design. The project development stages are the primarily design, tender design, and the construction design. So at the beginning of the project, you have to decide the proposed alignment, standardize the cross sections, topographic, hydrological investigation, meteorological investigation, site visits. Uh, After that, you can research and publish your data and turn into documentations. So this is a typical cross section of a highway where you can see there is a primary and secondary sports as well. So this is the typical cross section where you can see the vertical clearance is around 5.3 and a horizontal clearance is around 11.3 meter, which include the sideways inspection galleries as well. And this is the support system design where you can define a typical cross section of the tunnel lining, which includes sport as well. In primary sport, you can see these rock bolts. So these are all the primary support and the secondary support of a tunnel section. So here it comes the tunnel stability analysis. We use the finite element method, and we use these softwares to analyze the stability of the tunnels. Next you will see the exact geometry and the coordinate system that are taken actual CAD drawings through DXF to import in these models to calculate the total deformation and strength factor of the tunnel. So these are the systematic diagrams of the tunnel stability analysis of rock science of a phase 2, where you can see the existing condition during excavation and with model of support design. And further I will explain the results of these analyses. Here you can see the strength factor. Okay, at the crown of the tunnel you can see there is a strength factor is 1.2, which is greater than 1. So it's quite good to get the stability analysis. This is the sigma 1, which is a compressional stresses. What these are the compression stresses, and this value is 2.1 at the crown of the tunnel. So these are the different cross section. This is a total displacement section where you can see the primary support is not. There are only 1, 2, 3, 4, 5, 6 rows of the rock bolts, and and its total deformation is 10.5. Here you can see the sigma 1, which is a compressional stresses on the tunnel cross section. So this is the main way you can see the tunnel portal analysis for the safety of the end users. At the tunnel portal analysis, you can see the rock bolts, load, seismic load, as well, where you can see that this formation is a sandstone and we have the overburden over here. So this is the tunnel entrance. So how we can find the factor of safety of this section? So when we calculate this model, compute on a software, you can get the factor of safety of this structure is around 1.4, which is quite good, which is greater than 1. So the support is here. It's a rock ball anchor. It's an active method. Anchor capacity is around 200, and out of plane spaces 1.5 meters. And these are the calculation that you can get from the software as well, which include the stress analysis, groundwater, field stresses, which include sigma 1, sigma 3, sigma z as well. So these are the all the primary support design, where you can see the liner, shotcrete, bolt properties.
Thank you so much, Mubashir, for a wonderful presentation. Do we have any questions from the physical participants? As I believe you probably along with using the information. Sir, the information you are made, yes, is the level for frequency of calculation. Sir, it depends on the
It depends on the surrounding rocks. If it's a hard rock, then we will go through the generalized open rock. If there is strong, the surrounding areas is composed of the soil, then we will move to the analysis of a Mohr column. So the basic criteria is Mohr column and generalized cooking rock for the soil and rock mechanics.
normally it's 30
Normally, it's a 30-meter interval for
Total, no sir.
we have the
We have the we have cut the section around 5 meters. So we have to analyze every 5 meter of the channel section. Yes, we
Thank you very much. And with that, we will move forward. And with that, we will move forward. But before that, I would just add on one thing. It was really nice seeing that you guys been doing things for the in situ and overburden stress analysis. But we're talking about AJK. You must take care of the water. You know, we are in a tropical region and we have a lot of water in AJK region. So, I mean, I hope you guys have must done a lot of things about the water control and water drainage on a permanent basis as well. Perfect, fantastic. So with that, we will move forward to our next presentation. Reda Arif, she will be talking about mastery on the strength and abrasion properties of metamorphic rocks. Reda, if you are in the team, please come forward and the stage is yours. And please, I personally request, try to make it quick. Rida,
Sir, we
are
are
you with
coordinating
us?
that. She
Rida
is facing
Arif?
some technical
Yes,
Okay.
I'm here.
Okay.
Okay, give me 1 minute.
Okay. She is with us. You have lost 1 minute of your presentation, Rida. You have lost 1 minute of your presentation.
includes Assalamualaikum. हेलो नहीं आप स्क्रीन शेयर पे जाएं फिर उस पर विंडोज़ पे क्लिक करें और आपकी जो पावर पॉइंट है ना उस पर क्लिक करें जी जी आवाज़ आ रही है आपको हेलो आवाज़ आ रही है आपको जी जी आवाज़ आ रही है आपको आपको आवाज़ आ रही है आपको हेलो
Rida? Rida, can we move forward? Okay. So your screen is up. Okay. So your screen is up.
Assalamualaikum. My name is Reza Arif, and I'm from the Department of Geological Engineering from UET Lahore. And my final year project is about the impact of anisotropy on the strength and abrasibility of along the Karakoram highways. The Karakoram Highway is a strategic international highway linkage between China and Pakistan. It holds exceptional geostrategic importance for Pakistan, particularly in the context of the China-Pakistan economic corridor. It is also a popular tourist destination and a major route for the new infrastructure projects construction, such as Subikanari Hydropower Project, Dasu Hydropower Project, and Balakot. Here is the map of the northern Pakistan. The red line shows the route of highway of which starts from the Abbottabad and ends at the Pak-China border. Our final year project objectives are to characterize the mechanical properties of selected metamorphic rocks along the Karakoram Highway, determine the degree and orientation of anisotropy of the selected rock samples, investigate the effect of anisotropy on the strength of metamorphic rocks, investigate the effect of anisotropy on the abrasion, and develop the correlation between strength and abrasion properties of these metamorphic rocks. The Kiki traverses the Hazara Kashmir syntaxis. There is a variety of rock types in the highway zones. Some major rock types include granites, phyllites, gneiss, etc. Some formations along the route includes Kishore Formation, Tanawat Formation, Aptabad Formation, Hazara Formation, etc. Here is the geologic map of the Karakoram Highway route, which starts from the Abbottabad and ends at the Pak-China border.
Anisotropy. Anisotropy refers to the property of materials by which its physical and mechanical characteristics vary in different directions. These directions are called foliations. In case of mechanical excavation, anisotropy impacts penetration rate, power consumption, and tool life of TBM and road headers. Whereas drilling and blasting techniques, it affects the drilling efficiency, energy consumption, and fragmentation size of rocks. The main focus of our study is on the KKH from Abbottabad to Bisham. So, four different rock types from four different formations were collected from Abbottabad, Batal, Thakur as listed in the table. This slide is related to the geological road log along the Karakaram highway which we use during our sampling, and the locations of our samples are marked here. Here is the outcrop of Hazara Formation or Abbottabad Formation. The next is the outcrop of Tanawal Formation and Karora Formation, from where we calculated our samples. That is granite of size 1 to 4 mm present in garnet schist of the Naval Formation collected from Chenarpot. Sample preparation. All the collected rock boulders were cored at 0, 30, 45, 60 and 90° along the angle to foliation. Three wooden wedges of 30, 40 and 60 were made to core the boulder at particular angle as shown in figure, so 5 cores at each angle were prepared for strength and abrasion testing. We can see the prepared samples of graphitic schist at each angle to the foliation plane. Here is the shear marks of 200 tons universal testing machines which we used for the UCS and BTS testing. The field sample of garnet schist at angle of 0°, it is placed between the platons of UTM. Here we can see the failure of sample along the foliation plane. UCS tests were performed on 5 samples of each angle according to ASTM standards. You can see the graphitic schist sample of each angle after failure. UCS results shows that the compressive strength of an isotropic rock is minimum at 30°, while it is maximum at 90°. It forms a U-shaped trend, and this trend is consistent for all the rock types. Similarly, for the BTS testing, we also followed the ASTM standard. We prepared 5 rocks at each angle, 5 discs at each angle. The disc placed between the platons of UTM with respect to the angle of foliation. In this figure shows disc samples after failure at different angles. The graph of BTS Brazilian tensile strength shows the comparison between tensile strength at each angles. Here you can see the anisotropic rock gives minimum value at 0°, while maximum at 90°, and this trend is consistent in all the rock types tested. Next, for aggressivity testing, we use a short test while performed according to ASTM and ISRM suggested methods. We use third generation chart test apparatus made by West 1989. We also used a tool grinder to shop the Sarchar stylus uh, having hardness 55 HRC. After testing, the diameter of tip wear was measured using the microscope. 5 stylus were scratched for each angle perpendicular to the foliation. Then the mean value of 5 scratches is taken as the Sarshar abrasivity index. The bar chart shows the CAI value of all the rock types at each angle. The trend in this graph shows the increase in the CAI value from 0 to 45 degree and then decrease towards 90. Here is the regression and here is the linear regression analysis of all the 5 scratches at each angle of a light. Here is the regression analysis of quartzite at each angle. The regression analysis of garnishes shows that the CAI maximum at 0 degree due to the presence of garnet that has Mohs hardness of 7 while the rest of the trend is similar to the rock types. Graphitic schist also shows the similar result as the other rock types. Here is the comparison between the CAI and UCS of all the rock types at each angle. It shows the direct relationships from 0 to 45 degree and the inverse relationship from 45 towards 90. Here is the linear regression between all the UCS and the CAI values at each angle. It is the comparison which between the CAI and tensile strength at each angle. The strength is mostly similar to the UCS strength that is directly related to 0 to 45 and inverse from 45 to 90 degree. Here we can also see the linear regression between all the BTS and CAI values at each angle. The conclusion, lastly, it is concluded that the compressive strength is strongly dependent on the anisotropy of metamorphic rocks that is minimum at 30 degree and maximum at 90 degree. Angle to foliation plane showing a difference of up to 50% depending on orientation. Similarly, tensile strength also shows a high degree of anisotropy with the minimum value at 0 degree and maximum value at 90 degree, having variation up to 60% depending on orientation. Furthermore, CAI test also shows the abrasivity is dependent on the plane orientation of foliation, having maximum values when scratched perpendicular and minimum value when we scratched parallel to the scratcher. It shows the actual impact of anisotropy on the cutter of TBM or road headers, etc. These findings have important implications in optimizing excavation techniques and toolware management. Mixed phase tunneling machines should be designed using abrasivity and strength database on predictive models that predict the behavior of rocks in different orientations during cutting and optimize operations according to it. These are the references that we quoted in our presentation. Thank you so much for providing us an opportunity to showcase our final year project at that symposium. Hope you like it.
Thank you so much, Lily, for this wonderful presentation. You can imagine round of applause here in the conference room. It was a wonderful presentation covering all the aspects of rock mountain leakage. Do we have any questions from any of the participants? Eda, we have a question for you from the participants. If I could please Dr. Hassan.
Thank you, Rizal, for this wonderful presentation. Can we have the conclusion slide here? So it is very interesting to see that tensile strength is high, Is it that was not disking at that direction at 90 degree? Are you with us now? He's having a little okay, no worries. Yeah. Anyway, we'll pass on this question to Leila. Yeah, it is. Next week, it is. No, the figure down there is showing like the 90 degrees around the steps there.
Okay.
So next
So
we move
next we
to
move to.
should be high. It should be high.
Okay. Thank you very much for this
Uh,
wonderful insight.
Next we move
Uh,
forward to the
Next we move
presentation
forward
by
to the
Professor Raj,
presentation by.
written application of engineering geology in tunneling projects. Purab is here with us now, and he will be presenting about the topic now. Purab, the stage is yours. First of all, thank you, Mr. Kaushal, and all PTSS team for inviting me as guest speaker to promote the role of engineering geology tunneling project. By profession, I'm currently working as assistant manager, mining and geology advisor at National Cement Factory, and apart from the mine and quarry, and also working as STEM engineering geologist in the National Association for Engineering Geology in Pakistan as a national representative Association for Engineering Geology in Pakistan. My professional membership as professional member, national group representative at the Association for Engineering Geology, national group of International Association for Engineering Geology Environment, professional membership at BTS, professional membership from Pakistan Tunneling and Trenchless Society currently recently got. Professional membership at Association of Environmental and Engineering Geologists, International Society of Environmental Technology, and National Geological Society of Pakistan. The Central Area Engineering Geology, Mineral and Mining Geology. I would like to introduce my association because I am the secretary of National Association, Associate for Engineering Geology of Pakistan. We have recently got recognition from International Association of Engineering Geology from IAEG, which is the National International Group of Engineering Geology and Environment. My number of slides in introduction to engineering geology science, engineering geology and tunneling, role of engineering geologists and investigation stages, tunneling methods in Pakistan, summary and conclusion references. Basically, introduction to engineering geology as science. The application of geology to civil engineering project is known as engineering geology. Engineering geology may be defined as that of applied sciences which deal with the application of geology for safe, stable, and economic design and construction for civil engineering projects. This is essential for proper location, planning, design, construction, operation, maintenance of engineering structure. Engineering geology complements environmental geology. Importance: why these fields are crucial for tunneling projects. Recent advancement in site investigation techniques and engineering geological classification system has enhanced our understanding of geological materials and their impact on tunnel design.
Impact on tunnel
However,
design. However, it is important to note that single rock mass classification values cannot fully capture the significance of engineering geological data in tunneling. Tunnel engineer must evaluate all key geological features and relevant failures, failure modes early on, considering specific tunneling influence factor. Before relying on rock mass classification,
at present, the comprehension of geological materials and the significance in engineering geology enhanced by improvement in site investigation techniques, the establishment of geotechnical classification system, and the resulting
classification system and the resulting quantification of rock masses like rock mass rating RMR and Q system were developed to provide tunnel code estimate through rating of rock masses. regardless the geological condition or region, where tunnel necessary expertise in tunneling in essential for ensuring the safe storage, communication, and transportation of goods and individuals. Prior to the establishment of Pakistan, several underground passage and tunnels were constructed for railway systems, along with a limited number of road tunnels. Since 1950, tunneling activities have been undertaken primarily for the development of dams and hydropower projects. Pakistan, more than 50 years of tunneling experience, had equipped professionals with essential skills for global tunnel projects. By sharing this expertise with related field, we can enhance tunnel and underground construction in our nation. It is a vital to secure comprehensive tunneling knowledge to design and build secure underground passage that can withstand earthquake, landslide, and avalanches. Engineering journey in tunneling. For tunnels, planning, understanding the geomaterials, including soil and rock, is crucial for excavation process. Generally, there are three categories of rocks. We know that: igneous, sedimentary, and metamorphic. A thorough study of these is essential based because on my limited experience during the exploration of Neelam Jhelum hydropower project and design phase of Mohammed Dam, I have observed that tunneling operation can be both hazardous and costly. Consequently, meticulous planning and the investigation are imperative, along with adherence to established procedure during the pre-excavation phase. About 3 to 4% of project budget is set aside for investigation, which may include core drilling at a tunnel site. Various observations are made, such as examining rock formation, identifying faults, assessing water courses, analyzing meteorological data, and planning access routes. The findings from engineering geology are crucial as the investigations depends on the suitability of rock and their characteristics. Key factors are evaluated to determine the actual rock condition. Someone detail of maps and aerial photograph of the sites, reconnaissance and detailed geological mapping. Core drilling being the most exploration method provides underground engineering, geological information of the relevant site area. In case of larger tunneling, exploratory audits, horizontal or inclined or vertical test pits are also excavate how the rocks shall behave at the time of excavation and what lies below the surface, the condition of the rock or soil. Lab tests are also very necessary. Rock samples are carried out to determine the petrography, density, compressive strengths, and the presence of detritus material. At the time of investigation for tunnel location, it must be seen that there is no active fault in the area. Inactive faults sometimes become active. It may cause many types of displacement, horizontal or vertical, along these faults damage the tunnels. Despite the facts described, it has also been observed the tunnel excavated is competent rock and properly supported, just show resistance to even strong earthquake. Incompetent of poor rock, but incompetent of poor rocks in close vicinity of fault damage has been seen. The geotechnical properties of rocks, especially most important, is exposed in the area determined. Engineering, surface geological mapping, and reconnaissance studies are made. The feature of the rock, like joints, features, shear zones, and other weakness are noted. For larger tunnel, core drilling is planned to get the rock samples for geotechnical studies. Hence, the contribution of engineering geological information for safe and economical tunneling can be simply presented solely by the raw mass classification like RMR with the basic geomechanics classification, Q and GSI or other. A classification rating, if used, must be compliant by the underlying of the actual rock mass material as reference in given below. A flow chart in figure 1 based on the
Decisions present the design methodology as shown in the flowchart, the fundamental name below, the rock mass model, and the excavation scores in the definition of tunnel behavior type. Hence, the contribution of engineering geological information for safe, economical, and tunneling cannot be simply presented solely by rock
not
mass
be simply
classification.
present solely by rock mass
Values of
classification.
RMRQ,
Values RMRQ, GSI, or other classification rating, if used, must be combined by the understanding of the actual rock mass behavior in tunneling.
Here's a
Here's a basically geological model, principal information like
basic information lithology, tourism, structure, weathering, and hydrogeology, the most important. Identification of basic principal geoengineering keys that characterize the rock mass behavior and tunneling. Defining definition of rock mass type, like the rock mass discontinuity characteristics, what type of characteristics, in situ stress and hydrogeological regimes, tunnel geometry, definition of rock mass behavior, types in tunneling, selection of the appropriate design or parameter according to the tunnel failure mechanisms, stress control, gravity, even driven failures. Likewise, provide the principles, the temporary sports, Bayer, the sport, detailed numerical analysis based on the behavior type and the appropriate selected design parameters, determination, excavations, and sports classes. Contract documents in the last part. Role of engineering geologists. But here is the most important questions. Role of engineering geology and investigation stages. Engineering geologists involved in tunneling project design typically works on behalf of project owner. Contributing to the various aspects such as project planning, subsurface investigation, the preparation of contract document and field observation during the construction phase. In case of design, build, and other alternative procurement methods, they may also be offer similar insight to contractor. Notable, there are two main primary categories of professional qualified for this role: engineering geologist with extensive knowledge of tunnel design and construction, and tunnel designer who possess a deep understanding of geology, particularly the specific types and characteristics of host engineering geology relevant to the project at hand. In this presentation, the term engineering geologist will be used to refer to the board categories of individuals, although geological engineer is also a suitable designation. Regardless of terminology, these professions are anticipated to assist in addressing the following four key questions. What geological and hydrogeological condition in the tunnel and the shaft face along the proposed alignment? How will the ground and groundwater react to the excavation plan support techniques? What design specifications are needed for excavation, ground sports, and the final facility? In order to provide answer of these four questions, the remainder of this section is divided into the following section. Most important, first, the subsurface investigations, engineering, geological, and geotechnical interpretations, the contract documents, field observation, and monitoring. Here is below two pictures showing the engineering, geologists, and tunnel constructions. Surface investigations. Simply, if we find the surface reservoir tunneling project is commonly divided into three phases: the planning, effort, project design, and project constructions. For phase one, subsurface investigation. The primary objective of phase one subsurface investigations is established to reliable understanding of subsurface geological model that establishes the characteristic present in the ground along the overall alignment through which the tunnel and associated shaft will be constructed. It is during the phase one surface investigations that the surface of skilled and experienced engineering geologists become important. Upon the completion of the phase one investigations, and the project planner and the designer should be able to establish informed project layout for the finished facility. Phase two investigation also very important opportunity to confirm the engineering geological assumptions based on the result of phase one investigation and promote a detailed geological model and subsurface provide along the proposed tunnel alignment. Phase two is very important. Larger tunneling, it may be necessary to perform phase two investigation, specifically provide additional information to help prospect contractor bid for the project. For instance, phase two investigations might be include as a boring down the center of the each shaft once the location have been finalized. During investigation, major geological features such as fault zone or to provide additional information. Engineering, geological, and geotechnical interpretation is very important. Underground openings created for tunneling project must be both safe for the workers and stable with respect to adjacent third parties. In order to achieve that, the tunnel designer and the contract can choose from a variety of tunneling methods and ground improvement techniques, technology that can be used for this purpose. Hence, the primary objective of interpretive the effort is to aid the selection of those learning method and ground improvement likewise. Contract document is also important. Having completed subsurface surface C part of my presentation is showing the contract document, which is subsurface investigation, the geological, geotechnical interpretation, efforts, project, engineering, and engineering geologists then turn attention to the contract document especially. Field observation as during my supervision at Nilamjalam hydropower project as a key responsibility engineering geologist is to monitor the field observation as it's shown in pictures during in 2018. Tunneling method mostly common, usually traditional drilling and blast and tunnel boring machines commonly used now in today's Pakistan. Engineering geology, now conclude, I'm going to conclude my presentation. Engineering geology aims to support engineering project by examining rock types, especially and structures. Key responsibility for tunneling project include creating a detailed engineering geological report, assessing ground and groundwater dynamics, conducting subsurface exploration, and oversee construction process by geotechnical expert like engineering geologists. The main cost and risk for tunneling project arise from excavation and supporting underground opening for the final facility. Successful planning and construction depend on understanding existing ground and groundwater condition. Tunnel are linear structure requiring accurate prediction of soil and groundwater behavior to stay on the schedule within budget. Geological and geotechnical expertise, particularly for engineering geologists, is essential for the project success. Here below reference, which I have taken some data. Last my slide is I think so it's okay. Finish. Any question? My
which one which one is the most necessary, the most important test in situ test while having a mega project like dam, up- like dam, for example, dam.
There are two type of investigation basically. One feasibility study are very necessary, in which investigation of borehole are very necessary. For them to be designed better, you need to first need design RDD edits and exploratory edits. And during conception phase, some investigations requires like hydro remediation, mapping, mapping like engineering geology mapping, seismometry vulnerability test to check the hydrological condition or disturbance in the road surface. Yeah, so I'm finished with you. Yes, just I want to also know what is the role of engineering geologists in planning as you said, the proper role of engineering geologists in planning. Okay. So you're asking about role actually, what is the role of engineering geologists in planning aspect? Why, how you, it's related to during planning, engineering basic engineering geologist's role is to study the rock, soil, and hydrogeological condition of the area. Where the geological structures you have to investigate that area during the feasibility. In every engineering structure like dam axes, spillways, and tunneling, you first have to design engineering geological consideration. And implication of engineering geology is very important to study the subgroups of engineering geology, likewise rock mechanics or rock engineering properties of soil and rock of that area specifically. Hydrological condition is very important, especially we have faced a lot of problems during the time we have more than 5,600 trains in especially C1 tunneling in our side, say at 6 kilometer tunneling.
almost. My main is that this school is planning section. If it is in the construction. Before feasibility study, that after during construction, both role are important. That is the part engineering. This is the part of the construction section. Yes.
It is the part of the
It is the part of the construction section. Yes, and the yes, it is. Yes, during the stage, during the construction stage, even after the construction stage, during the operation stage. Yes, it is important. Yes, yes.
Dr. Saab, forgive me for intervening. That will be the last question for this session. Let us respect the time as the most expensive commodity because it never runs back and goes straight in a straight line forward and forward. Thank you for highlighting the importance of geological knowledge while going for the underground space construction projects. With that, we will move forward to a next presentation, which is exciting one. We're making a slight adjustment to our program. We are bringing up
before the other presentation because she is in her university and she's going to be taking the next class. So we're going to take her on board for the next presentation. And yet, if you're with us, the stage is yours.
Daniel, are you with us?
Or have you started your
Or
class?
have you started your class? Ajay, can we have some response?
There's a link I can see there too that she's talking about. Is she mute?
Is she mute?
No, sir.
What? Okay.
Tanya,
Please let us know if you are with us. Um, Looks like we have some technical or internet glitch at your end. Uh, if we are audible to you, we cannot hear you. Okay. We can save your presentation for later on when you're done with your class. Let's move forward to the next presentation. Forgive me, Tanya, because we're having some technical glitch and we have to move forward. The next presentation is a recorded presentation by the one of the nominee of this year's Young Tunnelers of the Year award by International Tunneling Association, Hanan Samadi from Iran, and she will be talking about application of smart technologies in underground space construction projects. Mohsin, could you please play the recorded presentation of Hanan? Thank you.
Dear all, greetings and I hope you are well. I am more than willing to give a presentation about smart underground construction at the Symposium of Young Commerce of Asia. Let me please introduce myself. My name is Hannah Samadi from Iran. I graduated from the University of Tehran with master's degree in engineering geology, specializing in tunneling and underground construction. Recently, I was selected as a finalist for Young Commerce of the Year by the IT Award 2024 and also awarded the Best Research Award from the Wealth of Scientists Award. I am a member of the Iranian Tunneling Association, IRTA, and so IT, and today I am very happy for this opportunity to attend this amazing event and give a presentation. As smart technologies in construction have increased trend in recent decades, so I decided to present the application of smart technologies in underground space construction with a vision of current development and future trends in this field. This topic is almost important to be considered as we are in the technology-driven era, and smart construction should be considered in underground space and tunneling to increase the efficiency of projects and save the lives of workers. In this presentation, an introduction to the topic, types of smart technology technologies, their application in tunneling, and a summarized conclusion of the topic were presented. Different types of smart technologies can be applied in the pre-construction, construction, and post-construction phases of tunneling projects. One of them is the application of artificial intelligence algorithms in the prediction and calculation of the main parameters of tunneling projects. For example, algorithms such as machine learning and deep learning algorithms, which are based on artificial intelligence theories, can be used to predict machine performance in mechanized excavation in TBMs. The algorithm types are classified into different categories based on their structure, architectural network, and mathematical function. By using this algorithm, the model can be introduced and developed to predict the main parameters of tunneling projects, and then these models can be used in future projects which will be excavated and constructed in the same machine specification, engineering geological units and lithological units. The global trend towards urbanization emphasizes the importance of using underground space for creating new services and transportation systems in densely populated areas. Trenchless technology in underground infrastructure construction is becoming more popular due to its cost effectiveness and environmental advantage compared to traditional excavation methods. It is crucial to optimize tunneling operations in these underground spaces to ensure safe and efficient construction process while minimizing harm to existing infrastructures above and below ground. The Internet of Things and 5G network technology have been utilized in construction, but not in underground space construction. There are limited documents that consider these two types of technologies in tunneling and underground construction, even from a theoretical view. These technologies enhance safety in underground construction, enhanced monitoring, augmented reality (AR), and virtual reality (VR), drones and autonomous vehicles, variable technology, site surveillance, emergency response coordination, and data analytics. Let me please present these technologies in more detail. In the case of learning algorithms, we have different learning models that can be considered in tunnel construction to develop new models. Most of them are empirical investigations. The simplest types of learning algorithms is a linear regression function that, due to its simplicity, has been increased in all types of tunneling projects. The other types of algorithms like machine learning or deep learning algorithms have more advanced mathematical function and so give us more accuracy in prediction and calculation. Generally, the learning algorithm can be classified into different classes such as supervised learning algorithm, unsupervised learning, semi-supervised learning, and reinforcement learning algorithm. Each of these classes has a lot of address for prediction based on their types of learning. Supervised learning algorithms are the most widely used algorithms that have been used for prediction in tunneling fields. It should be noted that introducing and developing new models that are a combination of several machine learning or deep learning algorithms is necessary rather than using some simple and traditional machine learning algorithms. I have developed such algorithms and documented them in papers with my professors. If you are interested in the structure and function of these models and their application in tunneling, you can check our papers. The practical use of the Internet of Things in mechanics excavation, hard rock tunnel boring machines, and earth pressure balance machines or slurry machines in sub-ground and urban environments has a significant impact on the efficiency and safety on tunnel construction projects. By integration IoT, Internet of Things sensors, and connectivity into TVMs, operators can leverage real-time data to achieve performance, reduce downtime, and improve overall project outcomes and utilization factor. Some practical applications of IoT in the TBM industry are real-time monitoring, predictive maintenance, remote control and automation, and data analytics and optimization. 5G technologies can be integrated with various technologies for underground operations, enhancing communication safety and efficiency. Some key technologies include Internet of Things devices, drones, and unmanned aerial vehicles, UAVs, and augmented reality, AR, and virtual reality, also VR, advanced robotics, real-time data analytics, enhanced communication systems, and geolocation technologies. Well, tunneling contractors have traditionally relied on empirical methods and simplified design calculations. Optimizing tunneling operation remains complex and challenging. Despite significant research progress in understanding the physical and mechanical factors of tunnel boring machines, TBM operating and performance parameters, and geometry of the tunnel, there are cases where standard design methods may not accurately predict field behavior. The advancement of technology, especially the data gathered by modern TVMs, offers an opportunity to use artificial intelligence algorithms, the Internet of Things, 5G networks, and computer vision to aid decision making at construction sites with real-time and valuable information, autonomous tunneling construction process, and equip TVMs with advanced technologies that can help also for remote investigation instead of being on-site. Previously, some simple neural networks and machine learning methods were utilized for the prediction of the main parameters in tunnel construction, but nowadays more advanced algorithms are used to introduce and develop new models that have more accuracy and also reliability in calculation. The input and output parameters within the database need to be identified, following which the dataset should be divided into two subsets, a training set and also a testing set. The allocation of 75%, 80%, 85%, or 90% of the total dataset to the training set and the remaining percentage of the dataset for testing dataset for validation is a commonly employed approach. Deviations from these percentage may occur due to errors encountered during model training, leading to lower accuracy. Normalization of the data set using a standardized formula is essential to scale R variables to a common range of 0 to 1. So the normalization process becomes crucial when the parameters exhibit variations in units or ranges. When selecting the most suitable model for a particular dataset, several factors must be taken into consideration. Firstly, the size of the dataset plays a crucial.
So give me a minute.
Role in determining which model will yield the best results. Furthermore, the type of the data being used also influences the choice of the model. Another important consideration is the number of features present in the dataset. Additionally, the nature of the data points themselves is an important factor that should be considered. Following the training and testing of neural networks to obtain predictive results, the accuracy of these outcomes is typically assessed using various metric and statistical measurements. One commonly employed approach involves the utilization of loss functions and evaluation metrics to analyze the accuracy of prediction. IoT-enabled tunnel sensor without IP-compatible sensors, direct access to the hardware is lost, meaning it is not possible to implement modern technologies like remote maintenance or condition monitoring to improve reliability and reduce costs. So introducing the concepts of industry number four, like the Internet of Things IoT in underground infrastructure environments will unlock these potentials. Technologies are proven. Now, sensor manufacturers, system integrators, and road operators need to work together to ensure that IoT-enabled sensors easily integrated into tunnel control systems and corporate IP network. Other devices can remotely access sensors within the same network. Some operators feel cautious about cybersecurity, worrying that the sensor could be hacked. But in fact, IP-connected sensors do not add any major new challenges to cybersecurity. Firstly, most sensors connect only to corporate networks of road operators or tunnel operators and not to the internet. Furthermore, the sensors use standard internet technology that IT security specialists know how to deal with. In today's urbanization and space constrained environment, tunnels play a crucial role in infrastructure development. Tunnel boring machine stadiums are increasingly being used worldwide for various projects, including transportation, water convenience, mining, and defense facilities. So the evaluation of tunnel excavation tools from traditional metal to mechanized stadiums has revolutionized the construction industry. Different types of TBMs are utilized for varying geological conditions in projects like subway, railway, and mining. TBMs offer a fast, safe, and cost-effective way to construct long tunnels, making them widely popular in the industry. In the initial phase of the study, it is imperative to compile a comprehensive database consisting of information gathered from tunnel project. This dataset should encompass the geometrical properties of intact rocks such as the uniaxial compressive strength UCF as well as the geomechanical properties of the rock mass such as RQD, rock quality designation. Additionally, it should incorporate TDM operational factors including cutter head torque and thrust force, cutter rotation speed, and cutter head power, as well as the physical and mechanical characteristics of the TDM, such as the number and diameter of these cutters and the cutter head diameter. Also, moreover, TDM performance indicators like penetration rate and advance rate should be included. Multiple models have been put forth to forecast TBM operating and performance parameters, and other factors show the application of, for example, support vector regression SVR. Building on a dataset compiled from different tunnel projects, subsequent research endeavors have focused on enhancing prediction accuracy using approaches like SVR, artificial neural networks, ANN. Other effective methodologies documented in earlier study encompasses ANN physiology and, for example, particle swarm optimization (PSO). Hybrid models integrating for example, the IC networks ANN and, for example, the PSO ANN network have been devised to estimate TDM penetration rate and TDM performance. Other cases utilizing, for example, regression technologies like fuzzy logic, random forest, and classification, and regression tree class has been conducted for various tunneling projects. These diverse methodologies shows the evolving landscape of predictive modeling in TBM performance assessment. Additional machine learning algorithms applied in the field of TBM performance encompasses the adaptive nor fuzzy inference system, ANN, external learning machine, support vector machine, decision tree, group method of data handling, and also deep neural network. Other words utilizing the hybrid neuron Higgs Markov model to generate a precise probabilistic geological description. Researchers combined SVM and other networks to formulate a model for prediction ground condition in tunnel projects and employ the random forest method to anticipate the penetration rate of the TBM in hard rock formation or maybe in urban environment and soil environment condition. Deep learning software estimates knowledge via autonomous training of extensive database to facilitate decision-making processes. Early instances of AI-based assessment of PBM performance have been documented by researchers, as you can see in this table. However, the application of IoT, 5G network, and AI is almost important in tunnel construction, and using some simple traditional machine learning is not the appropriate way in TBM and tunneling industry in practical way. So we should combine all of the technologies and computer vision in tunneling industry. These such studies have not previously documented also in academic, so it should be considered in both academic and industry in near future. Thanks for your consideration. Please contact me if you require additional description and are interested in this field.
Thank you, Hanan, for this wonderful presentation and leaving your email for all the audiences. If they will be having their questions, they can directly contact you or,
Presented so far. These are the common people you can find them on LinkedIn, get connected to them and keep talking about it. So, I just heard that Tahir is back again with us and she has resolved the technical glitch. So, we will again do the
presenters that have been sent for these are very sorry, Mohsin. We'll come back after that. Tanyat will be talking about health, safety, and environment in tunneling projects. So, Tanyat, if you're with us, please crack it in a little, in a very quick manner.
Tahir, are you with us?
Tanyat, are you with us?
Assalamu alaikum.
Walaikum Assalam. Tanyat, we are hearing you.
Is
Please
my
go on.
is my screen sharing with you all?
Yeah, we can see it. We can see it.
Okay. Assalamu alaikum. Good afternoon, ladies and gentlemen. The topic I am going to discuss today is very important in its own name, the role of health and safety in tunneling. So, as you all have learned from the morning that what is tunneling, what it has importance, now we directly come to the importance of health and safety. So, health and safety is very essential not only to protect the workers, to minimize incidents, but it is also important to ensure the project success. We can only consider a project successful in the construction perspective I am talking, only when there will be as minimum incidents can happen, or the project in which health and safety is prioritized. So first we come to know what are tunneling hazards. So main hazards are caves in, unstable ground can lead to collapsing, trapping workers, hazardous gases, gases like methane and carbon dioxide can accumulate, posing serious risk of explosion or asphyxiation. Then next come equipment
Forgive me for the
accidents.
intrusion, Tanyat. Tanyat, uh, pardon me for interrupting you. Your slides are not moving. We're still at the first slide. If you could please, switch to the current slide. Yep. Thank you.
Okay. Now, is
Go
it
on.
visible?
Yep. 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 Yep.
Okay, so now we discuss the tunneling hazards. So the most important hazards are the three ones: caves in which the collapse happen and traps and it traps many of the workers, which is very hazardous in its own. Next is hazardous gases, as tunneling is related to construction and all. So in many areas there are many hazardous gases like methane and carbon dioxide which can accumulate and can affect the health of the workers. The third one is equipment accident, which happen most in the construction projects where we get to know that the heavy machinery fall on someone, and injury causes and fatality also causes, or even cause malfunctions in many cases. So according to the statistics, we get to know about that 30% of the construction fatalities are linked to excavation and tunneling. So this is a very great proportion. We have to work on this. And for this, we know that the most important thing is awareness. So in any perspective, when we talk about, we need to know this, that awareness is very important. When you are aware about the risk, only then you can do something. So in this context of health and safety in tunneling, we will first discuss the regulatory framework. So this is the framework which is designed by OSHA, which sets the specific standards for tunneling under this section, which includes the guidelines on protective systems and training requirements. The second one is local regulations may enhance OSHA baseline requirements reflecting regional hazards and industry practices. So we must know that what is the regulatory framework in tunneling according to the basic standards are. When we know the standards, then only we can make it applicable to our project. Next is, first we have to analyze the what is the risk. If we get to know the risk assessment, only then we can work on its mitigation or its emergency preparedness, or how we can get ourselves prepared for it. So how we identify the risk. So a systematic approach to identify hazards involve regular site inspections. So first important thing is that we need to visit the sites regularly. Next is workers feedback is very important, that what workers are thinking, that is the environment safe for them, is the equipment they are using are all according to health and safety standards or not. If we do this assessment regularly, only then we can calculate the risk. Second is the evaluation method. This is actually a technique which do the job of the person. This is job safety analysis, which is also this, that risk matrices can quantify and prioritize risk, ensuring the most critical hazards are addressed first. After the risk is evaluated, then we come to safety management system, that how we can incorporate that risk in the safety management system to reduce the hazard as much as possible we can. So what is the safety management system? It is to manage the safety, including make some policies, protocols, practices, procedures, which can prevent the incidents and accidents on the site, on the construction site during the tunneling. We need to incorporate it. So what importance it holds? The safety management system is very important. Firstly, to track safety performance. Secondly, it encourages the improvement in safety practices, which creates a structural framework for identifying hazards and mitigating risks. Next, after we set up a safety management system, then we have to make our workers, the people working there, also capable enough so that if any natural hazard or any hazard related to tunneling occur there, they must be competent enough to cope it. So what is that? In that context, training is very important. So there are 3 training programs which should be incorporated in any project for the safety of the co-workers, and to reduce the hazard causes. So first is safety orientation. This is very basic, that every employee, every new employee even should know about the safety measures, its own protection, and site specific hazards, that which hazards can occur and how they can cope with. Second one is specialized training should be given to the workers, that how they can do the first aid, the equipment operation, emergency response training. And the third one, that regular fresher courses should be incorporated in the project to incorporate the eh, knowledge, current safety knowledge, and reinforces best practices. Next is
personal protective equipment, that how the workers should protect themselves. They know first. Safety comes first. We always says that what is the safety? That first you need to know that how you can protect yourself. Only then you can help others or cope up with the hazard. So it includes the helmets to not cause any head injuries from falling debris, then respirators, then hearing protection, high visibility clothing. Then we come to the system of monitoring and surveillance. When we know the protection, safety management system, risk assessment, then we come to the monitoring. That there should be a proper system of monitoring, that how we are vulnerable to the hazard. There should be a system that tells us that now this is the time we may be more vulnerable to the hazard. We should be more uh, work on it. We should be more protective about it. So we have to work on monitoring and surveillance. Next is emergency preparedness, that we must know that if a hazard occur, what we can do. We should know about the evacuation routes and procedures, regular emergency drillers to practice responses and identify potential issues. Designated roles and responsibilities for team members during emergencies should be designed so that everyone should know that how they can cope up with any tunneling hazard. This will not only minimize the injury but also the damage, the fatalities that can cause by a hazard can also be reduced. Final lesson, that what all this meant to be. We know that, as I talked about in the start, that health and safety is not only a regulatory requirement, but it is essential component of every project success. So what could be the future prospects for health and safety? I guess we are lacking in the monitoring and surveillance perspective. We need to work on that. Also, continuous improvement and vigilance in safety practices are very important. If we not make it a continuous practice, then there will be no worth of it. So that's all from my side. Thank you so much. If any question, do tell me.
Questions from the participants, online or physical?
There is no question from online.
Okay. Okay, so we will move forward. Tanya, thank you so much for coming back and making this wonderful aspect of health, safety, and environment in tunneling as a part of this symposium. It was really interesting, insightful, and of course, one of the most important aspect to consider, whether it's an underground space construction project or on the surface. So health, safety, environment regulation comes up above all. So thank you so much for being with us. Okay, now we move forward, and again we are making a quick adjustment to our schedule because our friend from Malaysia, he is also about to go to attend his meeting. So we're bringing forward him. Uh, Karthikeyan Al Ramanathan is joining us from Malaysia, and he will be talking about ground settlement characterization induced by tunneling under non-green conditions. Karthikeyan, if you're with us, please share your screen and let us know about your work that you've been doing.
Hi, am I audible?
Am I audible? Yes, you are audible. Crystal clear. Can you please share your screen?
Can you please share your screen?
Hi, am I audible?
Am I audible? Yes, you are.
Yes, you are. You are.
Okay,
Okay.
can you see my
Can you
slides?
see my slides? Not at the
Not
moment.
at the moment.
Can you try
Can
again
you
sharing
try
your
again
screen?
sharing your screen, please?
Okay.
Okay.
Yeah.
Yep. All right, you're
Yep.
up.
All right,
Go
you're up.
on.
Go on.
Okay.
Okay.
So audible, right?
So audible, right?
We do have your screen and you're audible, Katiyan.
Hi. Okay. Okay. Thank you for the opportunity to present in this conference. My name is Karthikeyan. I'm from Malaysia. So my topic for today is ground settlement characterization induced by tunneling under non-greenfield condition. Okay. So my overview, I would say in Malaysia, the current word that I would say is up, down, sideways, and underground. Where because Malaysia is also considered a populated country, especially in the urban area. So for transportation wise, there is a lot of jam. So in order to reduce the traffic jams, we are in terms of going into tunneling for transportation sake. So introduction. So like what I have mentioned is the study of my 2020, as shown in the second graph. And then the third, various initiatives has been provided by the government of Malaysia to reduce the road traffic, such as MRT, mass rapid transit, LRT, light railway transit, and so on. However, there is a lot of after effects during the tunneling works. Not so major, but it's minor. Like for example, sinkholes on the road on the bottom left photo. And there's also damage to the infrastructures due to sinkholes, ground settlement, and water influx, and so on. So, from our ministers in Malaysia, they have advised us for a further enhancement requirement for the tunneling design in order to have a safe tunneling works to be carried out in Malaysia. So, my problem statement for this research would be in terms of to provide a settlement prediction model and a most influential parameter influencing the ground settlement in tunneling works at the studied project sites, which has a similar geological background, which is named as Scanny Hill Formation, made up from sandstone, siltstone, mixture of silt, sandy silt, and sandy clay. So various methods has been used, so which is using predicted settlement empirical formulation. Then we will compare it to actual settlement data, numerical modeling data, validated via SPSS, machine learning, and then we establish the prediction settlement model. So research aim and objective, basically to predict and establish a settlement prediction model. How is this done? Using three objectives, which is identify SI parameters, determine the settlement magnitude predicted, and comparing it to actual settlement during excavation period, and also to establish ground settlement prediction model of Kenny Hill Formation. So literature review, there's a lot of aspects that has caused in order to come out with these project sites, which are damaged buildings during the Kerala Metro Corridor project in India, and also in Australia. There has been cases where tunnel goes through weak earth materials, and there's been causes of ground settlement. So from these case histories, few parameters of SI has been identified as the most critical in terms of ground settlement prediction, which is young modulus, bulk density, Poisson ratio, and all the one that highlighted in yellow. So continuation. So in this topic that I'm presenting now, there'll be a comparison between predicted settlement using Maya 993 formula, comparing it to numerical, where in this research we have done using the flag modeling, and then comparing it to the actual instrumentation monitoring, which is ground settlement marker that is being installed on the site, tunneling site. So when you compare, we will get a settlement value, and that settlement value has a threshold limit, which we follow is less than 15 mm, according to the MRT Corp of Malaysia Development Building Control. And also at finally, the objective three is to use the SPSS to identify, machine learning also to identify which is the most influential parameter that affects the ground settlement value. So a research methodology, like what has been mentioned, we compare three settlement values using the threshold value to come out with a settlement prediction model. So the research methodology, first thing we have to know is the studied project sites. So there's two project sites that has been compared in this research or topic, which is one is in the heart of the capital of Malaysia, Kuala Lumpur, in this red box. And then one more is in adjacent to the town of Kuala Lumpur, which is in Shah Alam. So these two areas are very populated areas. So that's why the tunneling stations are located in this area. And the photos of this are shown in the right-hand side. So the Kuala Lumpur station has been, which is called the museum station because it's located nearby the museum building of Malaysia, has been already developed, built. And the Shah Alam station is still in the final process to be completed by end of this year and to commence commissioning early next year. So, like what I mentioned, the research methodology, there are many parameters that has been studied, which is the geotechnical properties, TBM mechanism, tunnel geometry, and the loadings. These loadings are basically the loadings of building at beside to the tunneling alignment to know the effect of a non-greenfield condition. Yeah, so the distance of the buildings are located about 150 to 100 meter from the tunneling alignment. So this is a very detailed flow on the flag from step to step. So I will skip on this, but in this research, we use a flag 2D model. This is the continuation of it. So from the flag, we have already done four cases, which is case one, case two, case 3A, case 3B, in order to model the exact condition that is occurring at site. Meaning, first you have a prior tunneling and greenfield without any building. Then you have buildings that come up first. Then tunneling alignment at non-greenfield, and then is finally would be zero rise it. On the top is actually the parameters that has been used for the flag 2D modeling, which is shown in blue and which is shown in green, light green color. Final results output will be shown in the right-hand side. So objective three is the back to SPSS, like what has been mentioned initially. SPSS, which is the statistical package of social science, machine learning by 5 sub-parameters, which are linear regression, decision tree model, support vector machine, random forest, and neural network. So data analysis and discussion. So for part of this, based on parameters that has been studied, this is the values that has been obtained for each project sites. One is at Museum Station and one more at Shah Alam Station. Yeah, so basically, even though we are having the similar geological background, which is Canny Hill Formation, there are some differences in terms of the geotechnical properties, in terms of cohesion, angle of friction, and everything. So that's why we would get two different prediction model for each project sites. Yeah, so this is all the graphs. So this graph I would summarize in terms of, if you see in this figure, the tunnel goes through various of color. This color is actually the subsurface profiles. So red color meaning SPTN less than 50 centisil. Yellow color is SPTN 50 centisil. Orange color is sandstone. Pink color is no recovery area. So whenever the tunnel alignment goes through a no recovery area, meaning no recovery, meaning there's no soil or the soil is very weak, the torque and the force of the cutter head and the thrust cylinder reduces significantly. So this has been shown in the TBM parameter. There is a drop in terms of ring 10, where ring 10, it has a no recovery area. So a similar pattern has been observed in this talk against total force. So data discussion for this is just a summary of all the parameters that has been studied. So now we go into flag, which is our objective two, flag 2D modeling. So if you can see, is by case, so which is prior tunneling, greenfield. You don't have any contour heat maps, but when you have non-greenfield at the loading of the building, you have contour heat of settlement. Then you have tunneling and non-greenfield is when you have a tunnel and you can see the differences of the deformation of the soil. And at case 3B, you have tunneling and non-greenfield, which is zero rise. And this also show a V contour settlement curve, which is tally to the on-site actual condition. So flag. So there is a comparison between three predicted settlement, flag 2D, and actual instrumentation monitoring. So if you see the comparison between predicted to flag 2D and actual instrumentation, there is high difference. But when you compare between flag 2D settlement against actual instrumentation, the difference is very less. For example, here is 0 to 0, negative 0.5 to negative 1.12. So in this case, where we can conclude that predicted settlement is based on previous researchers like Maye 993, which has used a generalized formula for the project site study based on his condition. However, we are doing on a more localized scale for Kenny Hill Formation, especially in Malaysia. So we have to compare between our flag 2D settlement modeling based on the parameters achieved from the SI of the site and compare it to the actual instrumentation monitoring. Yeah, so this is also a further study to know that how does it affect if you increase the loading or increase the eccentricity of the loading. So based on Rebello 2014, if there is a structure loading from the structural building, it will reduce the surface settlement due to the uh, ground condition which has stiffened, the soil has stiffened. So then we go into SPSS, and from the SPSS, with all the data that is obtained, without TBM mechanism and with TBM mechanism has come out with all the formulation. And this formulation has been increased the accuracy with additional parameter. So thus, extra parameter will have an extra accuracy and reduction of standard error estimate. So, and one more finally would be the modeling to show which is the most influential parameter. So in this case, the DTM has scored a lowest root mean square error. So meaning we use decision tree model, and using that, we have come out that geotechnical properties and TBM mechanism plays a very important and most influential role in terms of ground settlement values for the study project sites. So in conclusion, four parameters has been chosen, which is tunnel geometry, geotechnical properties, TBM mechanism, and external loadings. The ground settlement values has been divided into empirical, numerical, actual, compared, and based on the threshold value. And data validation of SPSS has been carried out to know which is the most influential parameter based on the selected four parameters. Yeah, so that's end of my presentation. Thank you. Any questions?
Thank you so much, Karthikeyan. Do we have any questions from the online participants? Mohsin, do we have any
No, sir. No
raised
queries.
hands? Uh, okay, thank you so much, Karthikeyan. We're
Thank
really
you.
grateful that you joined from Malaysia with this tight schedule that you have been running to your meeting as well. But anyway, it was really an interesting insight. I hope that people, when we'll be sharing the symposium proceedings with all the participants, they will definitely approach you. Maybe they'll be having so many questions about this non-green field conditions, where to observe the settlement and tunnelings. So yeah,
Yeah.
thank you so much.
Thank you. Thank you. All the best.
So with that, ladies and gentlemen, let's call it a lunch break. And all the online participants, please stay tuned with us. You can go through the schedule of the event. We have some exciting presentations as the technical session will continues after the lunch. And stay tuned with us for those wonderful presentation by some great, tunneling practitioners in the industry. So gather back in the conference room at 2:15. And in the meantime, all the online participants, you can have your lunch as well. And while watching the screen, you can have the promos of our sponsors. Thank you so much, and see you after the lunch break at 2:15.
Four, three, two, one.
Ah, no, no, no. कोई ना मंगाई 100 मंगाया था
Today we mark.
ये आपने निकाला आपको मालूम बड़ा मन कर
Let's
बैठे हो
march to success. Let's march to the free land. Let's march across its length and width to the future builders of Pakistan. Together we win.
Can become the certified. Make sure in next 6 weeks you become PMP. You see, we have helped 1500 plus PMP for customized roadmap, daily follow-up, coaching call, best simulator in the market. The most important thing, I work with you till you become PMP. So this can be something very important if you join right now. You get the pre-training, training, and most importantly, coaching. And you don't even have to read books. Register now and let me help you to become PMP in the minimum possible time. 99% success record. 150 PMP only in 2024 and 1500 plus PMP in last 4 years. What are you waiting for? Let's start.
Kreni ga malo lijevo, Nenad. Malo Nenad. Lijevo ga okreni malo, malo. Dobro. Vidiš ga kako ti zatikuje, gore na rondeli ga vidiš.
你们到底说是站着跑还是看着那个哈？哎，我们的项目是，他那个项目是一样的。对的。那这样我们拉长一点，一会儿往上走还有往上走，哎呦，这个是好的好的，这个记住了，这是好的好的，别动别动。 我知道，快让他们马上上去一下，敢看。最高了。
Trenchless Machine Company. Trenchless Machine Company, as a leading company in the field of designing and manufacturing of TBM machines, by identifying water shortage challenges in the recent years, decided to design and construct a mechanized micro gripper TBM machine with excavation diameter of 2,265 millimeter to provide possibility of using this technology in relevant projects. The functions of this micro gripper machine is similar to large diameter machines in terms of how it works and can drill long tunnels from a one-side entrance. The machine is built for drilling in hard ground and has a total length of approximately 60 meters. This machine uses muck car to transport the excavated materials, and by each presence of rolling stock sets in the tunnel, the TBM will be able to advance 1.3 meters forward. The following sections will introduce the general components and performance of micro gripper machine manufactured by TSM. Cutter head with a 2,265 millimeter drilling diameter and 14 pieces of 12-inch single and double-edged disc cutters for cutting and crushing materials, as well as 4 buckets for collecting the excavated materials. The main drive unit consists of 4 hydraulic motors and a planetary gearbox with a total power of 110 kilowatt and a capacity to generate rotation torque equivalent to 350 kilonewton-meter for cutter head rotation. TBM shields include front shield, telescopic and rear shields. 4 thrust cylinders in order to apply the required thrust force, gripper and stabilizer cylinders to provide the necessary support for drilling. Material transfer conveyor with a width of 40 centimeters and a transfer capacity of 20 tons per hour. Hydraulic power pack system with 250 kilowatt total power, along with lubrication system. The electrical and PLC system consists of a 20 kilovolt cable drum, transformer, main electrical panel, and control cabin where the PLC and monitoring system are located. The ventilation system includes dust collectors and ventilation ducts. The shotcrete spraying system includes the pump and pipes for spraying in the rear shield area. The watering pumps and compressed air system. The micro gripper machine performance sequence as following. After the presence of complete set of rolling stock system on the machine, which includes muck cars for carrying drilling materials, flat cars for carrying rails and other materials required for drilling, the machine will be ready for advancing. Before starting the drilling operation, the TBM machine's rear shield will grip to the tunnel wall using gripper shoes and the pressure of the associated hydraulic cylinders to convert it as a fixed support for 4 thrust hydraulic cylinders. By applying thrust force to these cylinders, the front shield with the rotating cutter head is pushed to the tunnel face. By applying stress to the rock with cutting tools, the drilling operation and advanced process begins. The control cabin is where the system of control and monitoring are located in. TBM operator applies the necessary command to operate the machine in optimized condition. These commands are executed through mechanical and electrical actuators in different parts of the TBM machine. As a result of axial force and rotational movement of the disc cutters on the cutter head, the rock chips are broken and separated from the tunnel face. The buckets installed on the cutter head also collect the rock chips and discharge them on the conveyor belt of the machine through the bucket plates. Excavated materials are carried to the end of the machine with a conveyor belt and are discharged into the muck cars. After completing the drilling operation, the muck cars are moved out of the tunnel by the locomotive. After discharging the muck cars by unloading system, they will be ready to be sent back to the tunnel for the next advance. After completing the 1 drilling stroke, the excavation operation is stopped and the gripper cylinders are retracted and ready to move forward. At this stage, and with extension of stabilizer cylinders, their shoes grip onto the tunnel wall and the front shield will become a support for the thrust cylinders. With retraction of thrust cylinders, the rear shield and the backup system move forward and the machine will be ready to start drilling of the next stroke. In the excavation of geological formation with low stability by this TBM, the excavated ground is temporarily supported by installing a mesh and then spraying shotcrete in the tail shield area. The guidance system and a laser beam are used to control tunnel path during excavation, and the coordinates of the TBM machine are analyzed in high accuracy by special software and displayed to the operator. Based on these coordinates, the operator applies the necessary commands to the TBM to keep the machine on defined path. While TBM advancing, the rails are installed on the tunnel floor in the backup area of the machine in order to let the locomotive and mock cars moving on it. By repeating the mentioned process, the drilling and advanced operations of TBM will continue until the mechanized tunnel machine researches the exit portal and tunnel accomplishment.
In the Atlas Copco Group, we're innovating for a sustainable future, and we're now launching ambitious targets to reduce carbon emissions. Our targets correspond to the 2015 Paris Agreement and are validated and approved by the Science Based Targets Initiative. Meeting the targets will drastically reduce our absolute CO2 emissions with the aim of slowing down and preventing impacts of climate change. In our own operations, this will mainly be achieved by switching to renewable electricity generated from solar power, wind, or other renewable technologies. We're moving away from using fossil fuels in our operations and are switching to electric vehicles. For our value chain, a majority of emissions comes from the use of our products. By constantly innovating to reduce the climate impact of our products and solutions, we're also supporting our customers' own sustainability ambitions. Combined with the continuous move to greener electricity and fuel, this will have a big impact. We enable the transition to a low-carbon economy through the technology we develop, and we're fully committed to be part of the solution for a better tomorrow.
Power Technique business area is an extremely innovative business. In fact, we have twice the number of R&D engineers as our next two competitors. We supply portable compressors, generators, pumps, light towers, and rental equipment. We're investing in more sustainable products over the next few years, then higher efficiency products, energy storage, and more electrical-driven products in the future. I think one of the areas where we're going to have fantastic growth in the future will be the flow area. The flow segment is very interesting, but we also now entered the industrial pump sector with our range of positive displacement pumps, which is basically for the environmental space. So sustainability creates big business opportunities for the Power Technique business area. I would like the business area to be known as the #1 in each of the segments in which we compete. So if we are #1 in all our sectors, I think that would be a great result for our business area.
ये चीजें बाकी आप जाने दीजिए काफी निपटा वगैरह है ये मतलब आप आवाज चल रही है
चल अशरफ भाई आए ना तो उससे 2 मिनट मतलब वो उधर आके खड़े हो तो फिर वो ला 2 मिनट बाद उसमें अनाउंसमेंट इसलिए नहीं करवा रहा उसके साउंड का मसला है ये 20 मिनट की है जी
शांत है सुबह के 7 बजे चलते हैं
Five, 3, 2, 1.
माइक चार्जिंग कर लो रेड लाइट ही बंद हो गया तो ऑन
Today we march. Let's march to success. Let's march to the free land. Let's march across its length and width to the future builders of Pakistan. Together we win.
Can become the next certified PMP. Register now and we'll make sure in next 6 weeks you become PMP. You see, we have helped 1500 plus PMP for customized roadmap, daily follow-up, coaching call, best simulator in the market. And the most important thing, I will work with you till you become PM. So this can be something very important if you join right now. You get the free training, and most importantly, coaching. And you don't even have to read books. Register now and let me help you to become PMP in the minimum possible time. 99% success record, 150 PMP only in 2024 and 1500 plus PMP in last 4 years. What are you waiting for? Let's start.
Kreni ga malo lijevo, Nenad. Nenad, još lijevo ga okreni malo, Dobro. Vidiš ga kako ti zatekuje, gore na rondeli ga vidiš.
你们到底说是3个口还是3个口哈？哎，我们的枪不是他们的枪不是一样的。那这样我们拉长一点，一会儿往上走，他就往上走，我们这边这个是跑的跑的，
让老汉上去一下。
ग्रुप फोटो बना लो श्योर सर श्योर पंजाब मार्केट पंजाब मार्केट सही साहब
Trenchless Machine Company. Trenchless Machine Company, as a leading company in the field of designing and manufacturing of TBM machines, by identifying water shortage challenges in the recent years, decided to design and construct a mechanized micro gripper TBM machine with excavation diameter of 2,265 millimeter to provide possibility of using this technology in relevant projects. The functions of this micro gripper machine is similar to large diameter machines in terms of how it works and can drill long tunnels from a one-side entrance. The machine is built for drilling in hard ground and has a total length of approximately 60 meters. This machine uses mock car to transport the excavated materials, and by each presence of rolling stock sets in the tunnel, the TBM will be able to advance 1.3 meters forward. The following sections will introduce the general components and performance of micro gripper machine manufactured by TSM. Cutter head with a 2,265 millimeter drilling diameter and 14 pieces of 12-inch single and double-edged disc cutters for cutting and crushing materials, as well as 4 buckets for collecting the excavated materials. The main drive unit consists of 4 hydraulic motors and a planetary gearbox with a total power of 110 kilowatts and a capacity to generate rotation torque equivalent to 350 kilonewton-meter for cutter head rotation. TBM shields include front shield, telescopic and rear shields. 4 thrust cylinders in order to apply
वीडियो चल रही है लगातार कितनी परसेंट हो गया कितनी है इसकी यार मेरे 96 है 96 है जितनी भी है भाई चार्जर जो है ना स्लो 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 वाला स्लो नहीं कर चार्ज
नहीं
कर
फास्ट चार्जर है।
भाई फास्ट फास्ट चार्जिंग मैंने भी किया ना मेरा तकरीबन 98% जब मैंने फ़ोन लिया था
By the required thrust
1.5 साल में ना वो 12 14% वो गिरा गया तो वो
देखिए मेरे
आना
ख्याल में वो
electrical and
सवाल आ
PLC
गया
system consists of a 20
अस्सलाम वालेकुम। अस्सलाम वालेकुम।
The micro gripper machine performance sequence as follows. After the presence of the preset of rolling stock, the machine is used to draw forecast drilling materials, draw forecast materials as the materials required.
डॉक्टर साहब की प्रेजेंटेशन लोड है जिससे डॉक्टर साहब की प्रेजेंटेशन लोड है उनकी सबसे पहली प्रेजेंटेशन है यूएसबी में दी उन्होंने स्टार्ट कर मेरी हाँ अभी ना स्टार्ट
Associated with hydraulic cylinders to convert it as a fixed support forecast hydraulic
वो जो सीनियर क्लासेस वाले ठीक है ठीक है सर वो उन्होंने दे दिया
The front shield with the rotating cutter head is pushed to the tunnel face. By applying stress to the rock with cutting tools, the drilling operation and advanced process begins. The control cabin is where the system of control and monitoring are located. TBM operator applies the necessary command to operate the machine in optimized condition. These commands are executed through mechanical and electrical actuators in different parts of the TBM machine. As a result of axial force and rotational movement of the disc cutters on the cutter head, the rock chips are broken and separated from the tunnel face. The buckets installed on the cutter head also collect the rock chips and discharge them on the conveyor belt of the machine through the bucket plates. The excavated materials are carried to the end of the machine with a conveyor belt and are discharged into the muck cars. After completing the drilling operation, the muck cars are moved out of the tunnel by the locomotive. After discharging the system, they will be ready to be sent back to the tunnel for the next advance. After completing the one drilling stroke, the
सर ये बाकी लोग आ रहे हैं कि वो लोग आएंगे उधर से ठीक है आराम से इधर करा दीजिए मैं ये लव कोई नहीं And the physical participant, hopefully, we have 90% of the attendance back in the
classroom, and we are hopeful that the rest of them will be joining us in a couple of minutes. So yeah, welcome back to the graveyard session. And to make it exciting, we have tried to put some very exciting presentation within this post-lunch technical session. And we will start with the afternoon special lecture to be delivered by Dr. Jazeb Khan on a very particular and important topic, pollutant concentration during the construction and operation stages of Luwari Tunnel. It's based on a case study, one of the longest road tunnel of Pakistan, where Dr. Saab has been working as a tunnel engineer. And today he will be sharing his experience of that project particularly related to pollutants concentration. Dr. Saab, the stage is yours. Sir?
رب اشرح لي صدري ويسر لي امري واحلل عقدة من لساني يفقهوا قولي. Maybe many of you know me. I'm Dr. Janzeb from University of Malacca. And before going into my topic, I would like to introduce Lawari Tunnel. Maybe you have
many of you and maybe many of you have visited. So it's better to introduce Lawari Tunnel. Lawari Tunnel is a mountainous road tunnel in between Dir and Chitral in Khyber Pakhtunkhwa, right? It connects Dir and Chitral, Dir in the south side and Chitral in the north side. It is 8.509 kilometers. Okay. It has a 1.8% slope towards north, towards Chitra. So keep in mind the points 8.509 kilometers, 1.8% slope towards north, zigzag alignment, having shear zones, and the vehicle conditions in that area is not that much good. So it was important to know the stability of laboratory after the construction. Today,
today
I
I will
will discuss
discuss
the
the
pollutants
pollutants
concentration
concentration
during the
during the
construction and
construction and
operation
operation
stages
stages of
along
a
tunnel.
long
It's a
tunnel.
case
It's a
study
case
of
study
Lawari
of
tunnel.
Lawari Tunnel.
Here you can
Here
see
you can see
it's not
it's
working.
not working, sir.
Okay.
Okay.
This is
This
to
is to
2005.
2005.
It's okay. It's okay.
It's okay. It's okay.
Before
Before
construction and
construction,
here in
and here in
2024 its operation
2024, it's
stage.
operation stage.
Can you please
Can you
remove
please
this?
remove this?
Sure, sir. Okay.
Okay.
Why it's not
Why it's
working?
not working? हाँ, हाँ. Maybe the button stop sharing wallet.
Sure, sir. Dr. Saab, please bear with us just while let's go to the next slide. Okay, next slide,
Okay,
please.
next slide, please.
You can see
You
here
can see here
how this
how
idea
this
was
idea was
created
created
in
in
between the
in between
Homestead
the
and Sandy
Homestead and
in the
Sandy
Norway.
in the
There
Norway.
was a tunnel
There was a tunnel
built in
built in
2001. It's
2001. It's
1.8
1.8
kilometer tunnel.
kilometer
And
tunnel.
after
And
5 years,
after five
it was
years, it
collapsed.
was collapsed.
The reason
The
was
reason
the
was
insufficient
the insufficient
supporting
supporting
system.
system.
So, keeping in
So,
view the
keeping in
Lawari
view the
tunnel
Lawari
length,
tunnel
that is
length, that is
8.509 kilometer,
8.509
having
kilometer, having
the
the
slope, the gradient
slope, the
1.8%,
gradient
and the
1.8%,
zigzag
and the
alignment, and
zigzag
the
alignment,
topography,
and the
and the vehicle
topography, and the
conditions.
vehicle
So,
conditions.
it was
So it
important
was
to know
important to
what
know
is
what
the
is the
environmental
environmental
situation in
situation
Lawari tunnel
in Lawari tunnel
during the
during
operation
the
stage.
operation
Next slide,
stage.
please.
Next slide, please.
The aim of
The
this
aim of
study,
this
it
study,
was
it was
actually
actually one of the 6
objectives of my
objectives of my
PhD research
PhD
work.
research work.
That was
That was
included
included
the
the
geomodeling,
geomodeling, characterization of monitor displacements, evaluation of tunnel support system, hydrological model, environmental control, and seismic hazard
So
assessment.
this
So
was
this
one of
was
the
one of the
objectives
objective
of
of
that
that
research.
research.
Next slide.
Next slide, sir.
Okay,
Okay,
there are
there are
two
two
stages.
stages.
In this portion, two stages were covered: the during construction stage and the post-construction stage, the operation stage. During construction stage, the pollutants include gases, NOCO, H2S, carbon dioxide, oxygen, O3, NH3, NO2, and the particulate matter, PM10, PM2.5, and PM1. Because, as I told you frequently, these factors, the length,
and other factors that compels us to find out what is the environmental solution. Because if you have problem with the gases inside the tunnel or with the particulate matter, so you will definitely, some of the people passing the tunnel will definitely have the suffocation problem, or if somebody has the heart problem, that's so those will also be suffocation. It was important to know the condition. And they, as I told you, besides suffocation, you could have the visibility problem in the tunnel if there are cases and there are if there are the particulate matter high concentration over there. Next slide, please. Next slide. Okay. During construction stage, the CO, CO2, O2 was, I don't know what's the problem.
So there are some technical problems. Don't go for the presenter, just keep it moving.
So during construction, 6 gases calculated and were done in these sectors: the carbon monoxide, carbon dioxide, O2, and these gases were calculated through the multi-gas detectors, and 3 gases, the H2S, SO2 and NO, and the airflow velocity was calculated during the construction stage and during the operation stage, along with the gases, the particulate matter, PM10, PM2.5, PM1 has been calculated, the SEM analysis, EDS analysis, and elemental concentration were found, and through different techniques to UV and through the atomic absorption spectroscopy. Next, please. These are the instruments which were used during the analysis and during the work. Next slide, please. These are some of the pictures in the tunnel. The left one in the Lowari tunnel during the work, the right one, and during the analysis in the lab. Next one, please. Okay, you can see the Lowari tunnel profile. And these are the sampling points. Here you can see the alignment. Here is the gradient. This is the gradient. You can feel it, the gradient, and then you can have the idea of the board burden starting from 200 meters up to 1100 meters. Next, and you can see the geological portions, the different geological units in this. Next slide, please. As the results, I have been told that you have 15 minutes for your presentation. So, being very quick and running, I give you the results of the research. The level exceeded during the construction stage. The carbon monoxide and carbon dioxide level were exceeded during the construction stage. We have the tolerance ranges for different gases. For example, we have the 50 ppm for the carbon monoxide, and usually the limit has gone very much high during the construction stage. And same is the case with the carbon dioxide. The range for the normal range for the carbon dioxide is 5,000 ppm, and it exceeded sometimes up to 15,000 ppm. And
the sources are explosives, loaders, and dumpers working over there. And the effects are the disinfection, improved infection by keeping in the doctor's paper on the tunnel side. So, and if you see here, the gases are abruptly, they became high because of the blasting activity. And then after that, when the exhaust system operates and when the ventilation is going also, it becomes normal. And the carbon dioxide position is here. It increases in the normally in the mucking and blasting activity, and after that it normalizes. Next, please. Here, for the pollution, different things are important. One is the ventilation
ventilation
system,
system during the construction,
or
because
you have
you
from
have from
ventilation system
ventilation
from one
system
side,
from one side,
and
and during the operation stage
you have the
you have
exhaust
the
system.
exhaust
So
system.
one is
So
the
one is the
machine-made
machine made
air, and
air,
then
and then
another one is
another
the
one is the
airflow
airflow
velocity, the
velocity,
natural
the
air.
natural air.
You can see
You can see
here the
here
airflow
the
velocity
airflow
was
velocity
taken
was
at
taken at
station 6 at
station 6 at the
change
chainage
2 plus
2 plus
200.
200.
You see
You
from
see
south
from
side it
south side
starts
it
from
starts
0,
from
and
0,
up to
and
the
up to the
north
north
it is
it is 8.509
8.509
kilometer.
kilometer,
8,509 is the
last point in the
last point
north
in the
in the
north
Chitral,
in the
and
Chitral,
the zero
and
is
the
in the
0
south
is in
side.
the south side.
We
And
install
we
one of the
installed one of
portion
the
at
portion at
2200,
2200.
where
The air
we
we used
know
to
the
know
air
the air
velocity,
velocity,
and that
and that
station
station that is
we call
we
it
call it this
station 6,
station 6.
and the blue
And the
color,
blue color,
that is the
that is the
negative sign,
negative
shows
sign,
airflow
shows
direction
airflow
from
direction from
south to north
south to
and
north,
red
and
from
red from
north to south.
north to south.
Usually
Usually
existing of high
existing of
pressure
high
center
pressure center
in
in
Chitral,
Chitral,
because
because
uh, in the
in
Chitral
the
we have the
Chitral we
vacuum
have the
system over
vacuum
there,
system over
so
there,
the air
so
flows
the
normally
air
from
flows
Chitral to
normally from
Deer
Chitral
side,
to Deer side,
and the airflow
and the
velocity
airflow
is
velocity
high
is
in
high in
winter
winter
in
in
that area.
that area.
Next slide, please.
Next slide, please.
These are some
These
of
are some of
the
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 SEM, the
morphological features
morphological
of
features of the
particles,
particles,
and the
and the
EDS,
EDS,
and the angular
and the
particles
angular
dominate the
particles dominate the
micro
micro
morphology with
morphology
broad
with
range of
broad range
particle
of
size,
particle size,
overall
overall
200
200
micron, and the
micron,
EDS shows
and the
that the dust
EDS shows
particles
that the
are
dust
mostly
particles are
composed of
mostly composed of
oxygen, carbon,
oxygen,
silica,
carbon,
iron,
silica,
and
iron,
other,
and other.
and exhaust and
And
non-exhaust
exhaust and
vehicle emissions
non-exhaust
are
vehicle
responsible
emissions are
for
responsible
these
for these
their
the
presence.
their
Next slide,
presence.
please.
Next slide, please.
Here are the
Here
atomic
are
absorption
the atomic absorption
spectroscopy
spectroscopy
results in major
results
elements.
in
The
major
higher
elements. The
concentration
higher
was found
concentration
for
was found
silica,
for
followed
silica,
by
followed
calcium,
by
and
calcium,
sodium,
and
magnesium,
sodium,
iron,
magnesium,
and
iron,
potassium.
and
In trace
potassium.
elements, the
In trace
highest
elements, the highest
concentration was found
concentration was
for
found
zinc, followed
for
by
zinc, followed by
Pb,
Pb,
Ni,
Ni,
Co,
Ag,
and
Co,
Cd.
and
And
Cd.
then the
And
sources
then the
for these
sources for these
elements,
elements,
according
according
to Linnet al.,
to Linnetal, the sources are includes brake, tire wear, and concrete lining and road abrasion. Next.
If we compare, no, the south, we have the south quarter and the north quarter. You can see four spots and their changes. I have told you the station from 0 to
From 0 to
8,509.
8,509,
At
right? So at
1,000, here the
1,000,
gases
here
concentration and the
the gases
particulate matter
concentration
concentration are
and the
given
particulate
on
matter
different
concentration are
changes
given
in
in, on
south
different
portal,
changes in south portal,
and south portal is the
and
zero
south
station, and then 1
portal is the
kilometer
zero
to 4
station, and
kilometer
then
and
1
8 kilometer.
kilometer to 4
Here you
kilometer
can
and 8
see the
kilometer.
particulate
Here you
matter
can
10,
see the particulate matter
it's
10.
high. This is
It's
high. The
high.
red
This
one,
is high.
these
The
are
red one,
the
these are
high
the high
concentration of the particulate
concentration of
matters.
the particulate matters.
Next, please.
Next, please.
If we compare the
If we
Lawari
compare
tunnel
the
with
Lawari tunnel with
other tunnels of
other
the world,
tunnels
you
of
can
the
see
world, you
the
can see the
comparison values.
comparison values.
We have
We
the
have
carbon
the carbon
monoxide
monoxide
5.80
5.80
ppm
ppm as compared to
other tunnels.
other tunnels. The value is high. The PM10 value is high, and the PM2.5 value is high as compared to the other tunnels of the world. It's comparison of the Lowari tunnel with other 8 tunnels of the world. Next, please. Uh, During construction, the gases concentration, including the carbon monoxide and carbon dioxide, was high. During operation, the particulate matter 10 and 2.5 is high. As far as the particulate matter 1 is concerned, there until now there is no unit for the particulate matter 1.
So the
So
carbon
the carbon
dioxide and
dioxide and
carbon
carbon
monoxide
monoxide cross the permissible limits on certain days during construction, while PM10 and PM2.5 during the operation stages. Next slide, please. It is important to install the proper ventilation system in Lowari tunnel. It is very much important. It's 8.509 kilometer tunnel. To improvement in ventilation system and reduction of vehicle emissions is important. Water spray, tunnel washing, access road and portal areas must be washed. So this was the environmental status of Lowari tunnel. Thank you very much. If you have any question, I'm here to answer you. Hope you know something now you can say about the Lowari tunnel. But if you have any question, it will be my extreme pleasure to answer you. Anything about the geological aspect of Lowari tunnel, the environmental aspect, the seismological aspect, besides this presentation too.
I have.
Okay.
Can you share the mic so that all our online participants will also listen to us? Sir, mic, caller. Can you share the mic?
Please.
Dr. Saab, thank you for this wonderful presentation and this historical data. I hope that many of us will be taking from this and moving further with some research, come up with some solutions. My question is, that you have allowed to ask for any other particular aspects of the Luari Tunnel. Luari Tunnel is not only a long tunnel but a deep tunnel as well. Had there been any rock squeezing or bursting, like sort of challenges that we face in deep tunnels? Maybe that you now want to put some spotlight on those occasions. Like what happened and how did you manage those challenges?
This is a very related question. That is there any rock burst or rock squeezing in the Lowari tunnel as it's the length and the overburden? There are some shear zones in Lowari tunnel. In station 1600, exactly, maybe I'm not able to mention that exact point, but in between 1600 and 1700 meter, there is a shear zone. So we were worried when we were excavating Lowari tunnel. I have been there from since 2005 to 2017. So that shear zones, the how was it treated? It was treated that we kept the round length of the excavation very low, very low, very low. Sometimes 0.5 meters, zero point 0.3 meters, 0.2
And then exactly after
meters.
blasting,
And then exactly after blasting, after scaling, it was protected according to the specifications and the support system. We adopted the extra measure for that area. In the same, it was not the only station which was sheared. We faced, and besides this, once there was a sheared zone, and oh, maybe you will not believe it, 133 liter per second water, that's flushing water. We faced 133 liter per second water in that area. So it was challenging. It was challenging, but that was treated very well. And according to the specification, the round was sometimes due to the progress of the tunnel, sometimes the required round length was a little bit more. But the rock condition in that stage, it was fine. So some of the ore breaks were there. Otherwise, the squeezing and that was very wonderfully controlled. The Lawari Tunnel planning was started in 1970s. And it was exactly started before in 1970s. It was excavated from 0 to 295 meters. It was excavated on full phase. Then after the 295 up to 592, it was excavated in benching phase. So and in 2009, it was the breakthrough was done. And in 2017, it was operated. Now, 2009 and 2017, first it was designed on the rail tunnel profile. Then it was changed. And after that, it was designed on the road tunnel. So, like we say in Pashto, Pyada Sara. No, so that was before it was designed in rail tunnel, and then again excavated, re-excavated, and it was operational in 2017. So the support is okay. It was properly supported, and the round length in that area, according to your question, that was minimized. Thank you. Thank you.
And with that, we will move forward. But before that, I will recommend to all the physical and online participants that Dr. Janzeb is like an institutional memory when it comes to Luwari Tunnel. So if anyone is interested in having some research on tunneling projects, you can always contact him and get in touch with him to carry forward your research work. Thank you, Dr. Saab. Our next presentation on the chart is by Mr. Tayyib Zubair, and the topic is deep TBM tunneling and rock busting. Wow, rock busting at 969 megawatt Neelam Jalam hydropower project. The challenges they faced and how they mitigated it.
Assalamualaikum. Welcome everybody. My name is Tayyib Zubair. I am from this institute and a practicing tunneler by profession. And my associations with the industry in the projects have been since 2010 onward. I have worked with NESPARK on Neelam Jalam project and their project monitoring, evaluation, setups, Frontier Works Organization, 2 or 3 tunneling projects and some confidential and open projects sort of. And recently, currently I'm working in TIP, Islamabad as a senior engineer in R&D plus some aspects of institutional courses for the promotion of tunneling and all that. So this presentation is about mechanical excavation, particularly tunneling. That's very rare in Pakistan and being done on one of the projects, Neelam Jalam hydropower project. And previously, Dr. Ishaq was talking about the Mangla and then Neelam Jalam. So this is about a little rock busting phenomenon over there and TBM tunneling in Pakistan in the respect of Neelam Jalam hydropower project. This is an overview of this project. Basically, what we will going to discuss. This project. This is the main hydropower intake structure of the project, and this is a layout, a basic generic layout of intake, the hydropower tunneling, central tunneling powerhouse, and then reservoirs. So tunneling as a part of hydropower projects is very much essential regarding their water diversion, power generation, and reservoirs. And high potential hydropower in MLI regions and northern portion of Pakistan, you know, various tunneling projects are going on, and hydropower generation capacity as well as their diverse application. So advanced tunneling with the fast track excavation. So you must need to incorporate tunneling with TBM operations. This is one of the example being incorporated in this project. Tunneling challenges and opportunities with complex geological and seismic conditions. This point basically refers to the problems encountered during the TBM excavation on the project and so on, their forecasting methods and stabilization measures. Tunnel failures, these were the reasons of the rock busting phenomena over there, the high overburden accumulating stresses, rock busting, and support design proper, their not proper visualization and improvisation needed that was later on adopted. Next, please. This is the project map view. This is the locality. This is 130 kilometer away from Islamabad in Muzaffarabad city. This is the project layout on the right side. Basically, it was a diversion of Neelam River with the headrest tunnels of extensive tunneling over 30 kilometers. This is the central tunneling, including TBM and conventional tunneling method. And then after crossing beneath the Jhelum River, that passed on and some underground powerhouse, and then outflow towards the Jhelum River. Next. Right. This is the project. Little brief about the Neelam Jhelum hydropower project, one of the largest potential hydropower projects in Pakistan. 32.5 kilometer tunneling, including 20 kilometer of TBM tunneling. So this is a massive tunneling with one and only TBM excavation being done over here in Pakistan. So it's unique in its kind in all the aspects. Occurrence of severe rock bursts during the TBM tunneling in the headrest twin tunnels. So this is the focus of the tunnel, basically that the rock busting phenomena occurred during that excavation and how that was handled. This is the aerial view of the tunnel and the terrain. You can see it's quite green and water occupied area, these rivers, and this is a project view, and this is the tunnel, basically hard rock tunneling tunnel being used, TBM used over there. There are basically two single gripper TBM tunnels. So this is the cutter head real time TBM used in this 20 kilometer of TBM tunneling over there. Next. These are areas to focus. First of all, I would discuss the TBM tunneling at Neelam Jhelum, rock busting in address twin tunnels, design approach and rock support systems. Then rock bust prevention, their optimization, and concluding remarks. Next. Basically, TBM tunneling is about the mechanized excavation being done through road headers and their advanced cutting tool methodologies. As you know, this is a very unique kind of tunneling, and it's not being done previously other than Mangla in Pakistan. So it was a new experience with immense complicated geological condition as well as technical aspects. TBM, the 20 kilometer tunneling with these two TBMs, 10 kilometer each, was another phenomena. These two parallel tunnels crossing with the passageways of water inlet structure. Selection of this TBM was done with some renowned international projects. Their comparison like a Gotthard-based tunnel in Switzerland. So this is quite a replica to that project with respect to TBM tunneling and the length of the extensive work of this underground structure, as well as design consideration. These are because this TBM selection is always done with the detailed investigation as per site conditions, recommendations, and their detailed analysis by comparison to all other tunneling projects being executed. So it's a very sophisticated design tool being produced for a project specific needs and requirement. Geology of the area was basically a muddy formation. The geologists from you people must be knowing about marine formation and the rock units over there, sandstone, siltstone, and mudstone. So this was the operating geological units being operated from this mechanical tool. The rock busting basically relates to the high overburden and tectonic stresses. That is very much essential to understand that why it happened over there, the reason behind, and how they improved their design improvisations for the better improved support system with the safe tunneling. Next. First, we should know and what is rock busting. What's the phenomena and how it impacted the project from cost impacts, their various design aspects and delay in the project. So basically, rock busting is, by what the book says, damage to an excavation that occurs in a sudden or violent manner and is associated with a seismic event. It is a excavation disturbance by some certain changes. Either it can be seismic or some mechanical excavation methodologies. Further expansion of this definition with respect to the project specific rock busting phenomena is the release of detectable energy linked with TPM excavation. This energy can be potential accumulated stresses or some seismotectonic activities or some other microseismic activated systems. Stress exceeding the rock mass strength can suddenly fracture. This is a phenomena of rock busting, basically interacting with the rock mass, their strength, integrity, and all the aspects that later on you just come to understand that how the rock mass, their stability, their mechanical properties can lead to a failure or success of a project when we are talking with respect to tunnel excavation. As we know that Murray Formation have three major rock units, with sandstone is a major lithology being excavated. That's why the hard rock TBM being used over there, single gripper, because this was a sandstone ranging up to 100 and above MPa, the average strength ratio of that over there. So the last point is the rock busting phenomenon increased overburden. We'll come to know that how increased overburden can trigger the rock busting mechanism, as well as their implications over the support system. Next. This is another short view over the what is. I think we have come to know that what is rock busting phenomena basically is, and this is the triggering mechanism and their brittle sandstone and increased costs, project delays, repairs, and safety risks. These are the shortcomings that we faced on the project side because of that phenomena of rock busting occurred. Next. This is a cross-sectional diagram of TBM tunneling. This red line replicates to the TBM tunneling of 10 kilometer each tunnel, and the geology across that shear zones crossing across with increased overburden profile of the your mountainous area. So we can see over here that a lot of at feasibility stage, lot of you can say the shear zone that were marked over there, and that crossing on the particular red line of the tunnel cross section that were later, we certainly had some issues of rock busting over this area as described in the feasibility report. So this is a bird eye view of the geology of the cross section of the tunnels. Next. So this is basically the in the previous slide. This is the actual 10-kilometer length of tunnel and the zones of rock busting. First of all, basically the water was flowing from this direction to that, and tunnel drive was there from downstream to upstream in the headrest tunnel. This is the basically affected zone of rock busting, and this is high frequency rock busting phenomena. Here, some mitigation measures later on adopted, and this microseismic monitoring system that evolved with the improved instrumentation for a better safe tunneling. We'll discuss it later that how this phenomena of rock busting was controlled. Next. These are rock busting, post rock busting pictures of some slightly rock busts to major rock bust events being occurred at the site. So you can see over the support system over there with a minor collapse and some visible UPN and L beams and other rock bolt applications. And subsequently, by the increase of intensity of rock bust, the damage is worst. And the extreme major rock bust that occurred that delayed the project about 6 months and so on, because of this severity of the and non-clarity of design implications with respect to the with respect to the ground conditions. Next. So this was the design approach and rock support system adopted initially and modified according to the rock busting over there. Initially, the numerical modeling tool adopted was rock support by rock science program. That is basically related to the preliminary analysis of design tunnels, circular tunnels, deformation analysis in weak rocks, as well as tunnel interaction with various support systems.
that is being
It's
used for
a
empirical
preliminary
approach based design for a
that
tunnel project.
is the
That
empirical
was
approach based
initially
design
used,
for a
but later
tunnel
on
project. That was
it
initially
was
used,
realized
but
after
later
the
on
severe
it was
incidents and
realized after
collapse
these
and
severe
delays
incidents
that
and
it is
collapse
not
and
much
delays
enough for a
that it is
support
not much
design
enough
that
for a
being
support design
executed
that
over
being
there.
executed over there.
Like the drill and bash
Like the drill
techniques,
and bash
conventional
conventional
excavation
excavation
was
was being the method of
adopted
support system
from
adopted from
conventional method to this
conventional method to
mechanized
this
support system,
mechanized
but
support system, but
that was not
that was
up to
not
the mark.
up to
So
the mark.
next,
So next,
they decided
they
to adopt
decided to
phase
adopt
two
phase two stress analysis program
for numerical
for improved numerical modeling approach and better design recommendations for support design.
So detailed
So
and
detailed
numerical analysis
numerical
of the
analysis of
TBM
the TBM
was
was
modeled over
modeled
there,
over there,
then the
then
improved
the improved
and
and
enhanced support
enhanced
system
support system
that worked
that worked
accordingly with the
accordingly with
safe
the safe
passage to
passage to
recover
recover
the
the
collapse zone and
collapse zone and uh,
breakthrough happened
breakthrough
finally.
happened finally.
This is the
This
range
is the
of
range of
rock
rock
burst
burst
values
values
because
because
the
the
overburden
overburden over
was
there
ranging
was
from
ranging from
1000 meter to
1000 meter to
1800 or
1800 or
2000 meters.
2000 meter. The
Overburden over the
overburden over
tunnel.
the
So it's
tunnel. So it's
huge
huge
with
with
respect
respect
when
when
you
you
are
are
talking
talking with respect to
your
your
potential
potential seismic
stresses
stresses
being activated.
being
So when you
activated. So when you
excavate a
excavate a
cavity,
cavity,
there
there
must
must
be
be some
serious damages
serious
if you have
damages
not
if you have
proper
not
damage
proper damage
mitigation measures.
mitigation measures.
Next,
Next, this is
this is
example
example
of
of numerical
numerical
model
modeling
tools
tools
and
and
their
their
previously
previously
support
support unsupported
uh,
uh,
unsupported
unsupported
numerical model
numerical
2D
model
model of
2D
a
model
tunnel.
of a tunnel,
And this is
and
just
this
after
is the
support.
after support
We have
they
control
have
with the
control with the
utilization of
utilization of
advanced
advanced
software tools
software
we were
tools we were
talking in the
talking in the
slide.
previous
This
slide.
is
This is
particularly to a
particularly to a siltstone
rock unit
rock unit
within a
within
100
1850
1850
meter
meter overburden
overburden
with
with
the
the
deformation
deformation
value
value
of
of
249
249
millimeter.
millimeter.
So
So by the improved, as we're talking about the modified design approach and appropriate numerical modeling, the
design criteria
design
being
criteria
adopted
being
after
adopted
that
after that that
supported
supported
TBM
the
tunnel
TBM tunnel.
the result was
The result
displacement
were
was reduced up
displacement
to
were reduced up to
50 mm,
50 mm,
right from
right from
249 mm.
249 mm.
Same as with the
Same as with the
sandstone bed
sandstone bed
with the same
with the same
overburden,
overburden,
their
their
deformation value
deformation
reduction
value
by
reduction
the appropriate
by the
design
appropriate
approach
design
and their
approach and their application, as
accordingly the support
accordingly
design
the
and their
support
evaluation.
design and their
So
evaluation.
this is a
So
brief
this is a
summary of
brief
these
summary
two
of these
examples. There
two
are a lot
examples.
more
There are a lot
we can
more
discuss
we
and
can
elaborate
discuss
on
and
this.
elaborate on this.
Next.
Next,
Design approach and rock support
design
systems.
approach and rock support
These were
systems.
basically displacement and rock cover
These were
curve.
basically
As
displacement
you
and
can
rock
see
cover
here,
curve. As you know, this is the
convergence.
convergence.
Unsupported rock support
Unsupported rock
with
support
these
with
level of
these level
convergence
of convergence
with different
with different
overburdens. On
overburdens.
the other
On the
side,
other side, the
we
supported,
have the
we
reduced
have the
value.
reduced value. So
Unsupported support
unsupported and
rock
supported rock
phenomena
support
that much
phenomena that much
effective
effective
and
and
useful for
useful for a safe
tunneling and
tunneling
their
and
application
their
with respect
application
to
with respect to
numerical modeling
numerical
and
modeling and
appropriate design
appropriate design
approach.
approach.
These are
So these are
graphical
graphical
representation of the
representation of the
supported and
supported and
unsupported tunnels
unsupported
and
tunnels and technically as per design need based support
Next.
system. Next,
This is the increased
this is the
pillar width.
increased pillar
There
width.
was two
There was
parallel
two
tunnels, so
parallel
there
tunnels,
was
so
a
there was a
technical rock
rock
mechanics
mechanics
mechanism
mechanism
behavior
behavior
problem
problem
that
that
when
when
they
they
found out after
found out after the
the
uh,
excavation and their
excavation and their
detailed
detailed
investigative
investigative
modeling,
numerical modeling,
the
that
width of
the
the
width
two
of the
parallel
two
tunnels were
parallel
not
tunnels
good
were
enough
not good enough
because the
shifting
shifting
of
of stresses
stresses
from
from
right
right
to
to
left
left
and
and
so
so
on.
on.
In general,
So
I
in
would
general, I would
summarize
summarize
it
it
in
in
a
a
simple
simple
way
way
that
that
by
by
increasing
increasing
the
the
pillar
pillar
width
width
from
from
33
33
meters
meters
to
to
55
55
meters,
meters,
their initial
their
rock
initial
pillar width
rock
when
pillar width
rock
when
burst
the rock
happened,
burst
their
happened,
revised
their
design recommendations, internal rock pillar width increased and decreasing rock busting phenomena.
Why droplet widths increased and decreasing rock busting phenomena? Because the tectonic stresses, their one side modeling approach, their stress distribution concentration over other. So these things, this was the one phenomena that was mitigated through improvising the new widths, that was deviation of tunnel and increased. Next. This is another graphical representation of what happened before and after that deviation. We can see that in the shield. Shield is the portion just behind the cutter head of the TBM. So most of the rock busting events happen in the shield before deviation. Later, after deviation, the rock busting was shifted from shield towards cutter head face. So stress is distribution back from the TBM right away in the face. Stress readjustment by the increasing pillar width. This is another implication of the proper design approach and their results oriented statics. Next. Okay. How much? Okay, rock busting prevention. These are some prevention measures. Their geological forecasting, their drilling, seismic tomography, the geophysical techniques being adopted, and they have some certain advancements over being performed properly after this event. Then microseismic monitoring system was also installed. Their results devised and the further mitigation, readjustment of existing support systems with increased overburden. As the burden increases, so the stresses and their impacts, these all things incorporated. And these are some specialized rock mechanics testings like overcoring and triaxial also done there. Next. I wish I would have time to discuss these all parameters and their impact. But right now, this is the real-time image of the TBM control room. Their cross sections, their mechanical. These are parameters that how they can control the excavation, their excavation impact on the weak rock or rock busting. Drilling parameters include cutter head thrust, torque, penetration rate, and speed. That how the cutter, the mechanical aspects of TBM cutter head, these effects can manage the rock busting when you are driving through some hard rock or soft rock accordingly. So this is another topic with detailed discussion. But these parameters were used for stable TBM tunneling over there. Next. These are conventional methods of rock bust prevention with respect to improved improvised design approach. These are the real picture of those TBM. Inside of that, this is the TBM control panel and that all support system, necessary support system required. Next. Another important slide, but have to discuss later in detail. These are some certain type of rock bolts used over there as per conditions or requirements. Swellix, expansion shell, and cement grouted on various locations based upon the severity of nature of the collapse. And shortcrete support system, later on ring beams and probe grouting was also incorporated for reducing effect of that cross-sectional tunneling. So these are systematic support design approach with multi-functional aspects and their needs according to geological forecasting and geological mapping. Next. Concluding remarks. The strength of the rock mass, in situ stresses, and structural distribution. These are the basic key factors for a incident or the phenomena of rock busting may occur in a deep underground TBM tunneling that were exposed and assessed in their project, and they were properly incorporated. Later on, the further mitigation measures were taken accordingly. The support system had to be strong enough to bear up to 150 MPa of stress to prevent damages. So first of all, we have to know the real-time rock mechanical properties to execute a project of such a large scale. So over there, some variations of rock 30 MPa to 150, right from mudstone, siltstone, and then sandstone. So their strength index parameters and their support system and mechanical behavior, all things have to be incorporated during and before the execution of such a large-scale project. Rock bust decreased from 74 to 13% after increased pillar width, as we discussed before. So this was one of the key factors, but needed the essential design recommendations and detailed investigation regarding numerical techniques was it has to be adopted that was not done previously that much. So this was a lesson learned during an execution. Next. Mandatory pillar width analysis in such kind of parallel tunnels. So just last slide. Understanding of high cumulative and tectonic stresses. This is the phenomena of tectonic stresses, potential or accumulated or active or dynamic. Specialized mechanical testing. This is related to rock mechanics for a pre-feasibility stage and then design approach accordingly. Statistical analysis, of rock bursts and induce accumulated stresses. Stability and then active deep in active techtonically active deep underground excavation, because the project was situated in the along the Muzaffarabad fault zone with the high impact factor of tectonic stresses in the overburden. So these specialized numerical modeling approach with the hybridization of mechanical testing was very much helpful and has to be compulsory in the such scale projects in our region. That was not incorporated, but incorporated later on after feasibility and final design stage of the project. Next. So these are the measures that we have to need to adopt in a large scale project with the design and accurate design approach with the feasibility and the execution accordingly. Thank you.
Dear participant, forgive me for not taking question for this presentation. Our esteemed presenter will be around and you can have all the discussion with him as all the Q&A session, and in fact the time for next presentation was sort of consumed in this one, but let's move on. We have another presentation from our previous session, a left floor presentation. Glass design will be presented by Mohsin. Mohsin. Thank you, sir.
In the name of Allah is the most merciful and the most beneficent. I'm Mohammad Mohsin Ashraf, currently working as a plastering engineer at the ME Flasher Dam. Is it not working? This is the just disclaimer. Next. Next. These are the objectives to highlight the major issues faced during the blast execution, to recommend suitable solutions for these issues to optimize the existing blast design. Next, please. So this is the overview and the background of the Amir Pasha Dam. The rock condition, left bank of the river is built by hard rock geology containing shear zone, jointed strata and fault plains. And the blasting material we are using there is amylite and ANFO at the dam side. And that are the existing blast hole parameters. That spacing is from 2 to 2.5 meters and burden is 2 meters, and for pre-split blasting it is 0.6 meters. Next, please. Next. So these are the topics of discussion, and major problems we are facing is boulders, fly rocks, and unoptimized blast design. Next, please. So what is boulder? Any fragmented material that is bigger than the bucket size of the excavator, we know it as a boulder. Next, please. So we have seen the boulders of many sizes. Like as you can see there, the boulder size is 2.5 meters here. Next, please. And this is from 4 meter. Next. And the reasons for boulder is unprepared surface for drilling. As you can see, there is unprepared surface in this picture, and there is a area where is this is like 7 to 8 meters that the boom of the crawler machine cannot approach. So that's why this is the main reason of the boulder. Next, please. As you can see clearly, this is also a unprepared surface that is not cleaned properly for blasting. So it is like difficult to drill here. Next. Uh, Next, please. This is the same as the previous one. Uh, this is this is the model we have designed for. Like as you can see, the darker side, as you can see, is the upper one, and this side is for the downside. Next, please. Can you play the video, please? We have designed this model on Opit Blast. This is due to, like you can say, uh, improper or unprepared surface for blasting. So this is the profile we can achieve from like drill holes. The profile is also unstable and uneven. So we have to drill properly to maintain and to achieve a clean surface and even surface. Next. So the main reason for this is we can say collapse holes. As you can see in the picture, there is a collapse hole. Next one. Next. Next please. Next. So this is what we have seen and what occurs due to the blast hole, collapsed blast hole. As you can see, we have designed the 2.5 meter spacing for the 2.5 meter burden for the blast hole. But due to collapse hole, the spacing and the burden becomes 5 meter. So that's why this is the reason for we encounter boulders. Next. So second thing is the fly rocks. Can you play the video, please? So this is the normal video. As you can see, video. Just play the video, please. So this video shows the fly rocks. As you can see, there are a lot of fly rocks in that blast. Next. So also the main reason for fly rocks is also the unprepared surface, as there is a lot of like you can say loose material on the blasting area. So that's why when the blast initiated, these rocks goes away very fast, and that is the main cause of fly rocks. Yes, next please. So here is the example of the clean blast area and well prepared blast area for drilling. Next. And the main also the reason, go back please. And the reason for this, like you can say, we can encounter boulders and fly rocks in the jointed strata, due to which there are a lot of energy dissipate from these joints and cracks and faults on from this. So our blast become unoptimized. Next. So third one is economically optimized blast design. Next. This was the existing blast design. The burden was 2 meters, spacing is 2.25 meters, and the powder factor is 0.54, and average fragment size was 0.2 to 0.24 meter. Next. This is the existing blast design boulder, and we recommend the blast design here is the make the burden is 2 meter and spacing 3 meters. Powder factor would be 0.40 meters, and the average fragment size is from 0.28 to 0.3 meters. And the calculations were done by the factor formula and then verified using the Kurzram fragmentation model. So we recommend the blast design as we have the area of width of 50 meters and length of 10-meter area. Next. According to burden and spacing, the burden is 2 meters, spacing is 3 meters, the area into 50 into 10, and the total number of drill holes we have to is 80, and the explosive amount will be 1150 kg. Next. That was the existing blast design, 2 meter and 2.5 meter burden spacing, and we have to drill 110 holes. And we recommended the blast design in which we have to only drill 80 holes, and we can also save our explosive amount. Next. So this is the comparison. We presented almost 28 to 30% economic blast design. Next. So these are the additional recommendations for, like, we have to properly supervise the magazine, and there should be training sessions for blasters and drill operators to properly drill. We have also test our recommendations. So we have done total trials of 7, and successful trials were 4. Next. So we have achieved in first step the leveling of the surface. As you can see, there is a clean and level surface for blasting. Next. And also, due to level surface, it is easy for the excavator to clean the site, and that is suitable for drilling. Next, please. Achievement of clean and drilling surface. Next. And in step 3, there is making marking of drilling points according to elevation difference on site and required burden spacing. Like if there is an uneven site, and some places on up and some places down, so we have to drill properly according to their elevation level. We do not have to drill like if we are drilling 80 holes, we do not have to drill 80 holes at 6 meter elevation. We have to reduce and increase the elevation to achieve the level surface. Next. There is just a marking, like you can see, we have achieved the 3 meter spacing here. Next. This is the fragmentation size or of our successful blast, and the fragment size was 26 centimeter. Next. That was from trial number 2, and that was unsuccessful trial. We got many boulders. Next. That was successful. Can you please play that video? Yes. Okay, sir. We are almost done. As you can see in that video, excavator is easily handling the material due to low in size of fragment size. We do not encounter any boulders. Next. That are the reasons for unsuccessful blast trial. One of the major reasons can be the propagation of major shear zones in between the blasting area, that we encounter a lot of shear zones there, and due to the jointed strata, and it causes the blast energy to disperse from weak zones before causing any fragmentation, and that results that we got boulders. Next. Another reason was being not able to achieve even surface before drilling. That if we do not achieve the even surface, it is difficult for us to drill holes properly and to maintain the level. The achievement of our desired results were 57% as per site. That's all from my side. Thank you.
Any question for Mohsin? Yeah, thank you very much. Okay, next we will be going for the another leftover presentation from the previous technical session. That's the 3D tunnel scanning, I think. That was it. 3D scanning and tunneling, right, Ali? Yeah, Ali Wajad. Yeah. Ali, could you please join us on the podium and finally, deliver your presentation? Yeah, thank you so much.
Hi and Assalamu alaikum. My name is Ali Wajad and I'm here from Sandhu Engineering and Trading Company. A short introduction of our company. We're dealing in topographical surveying materials and equipment since for the last 3 decades. And today I will be explaining you about 3D tunneling survey. Next. Okay, so the first step for 3D tunnel survey is to start a tunnel design. Next. Here we got a semicircle. That is a tunnel design, and we will design the tunnel by a total station and do the outer marking by the total station. And next. Here you can see this is an outer marking done by the total station. After that, we will make the blast points. And blast points is an option if you're drilling a boring. If you're using a boring machine, then you have to skip this part. But if you're not, then this is an option. After that, we'll do phase drilling, and then we will move towards blasting. After blasting, we'll scrape off the debris, and after scraping off the debris, we'll use the scanner for the 3D scanner for the as-built survey, as it is easier. With total station, you have to take data every 5 meters, but with the scanner, you can take it in one throughout continuous motion. Next. By next. Here you can see a finished tunnel. When you have a finished tunnel, you can easily go through the. You can easily take the measurements out of a total station. Next. When the tunnel is finished, you have possible regular profile and it is possible to capture. But when there is like overblast and underblast material, so you have to cut and fill them. Next. It creates an irregular profile. Which is quite impossible to capture. Next. As I explained you, from a total station, you have to capture the data every 5 meters, and you can also capture every 2 meters. But next, as you can see from the scanner, it has a continuous throughout motion, and it can be done with the range of 300 meters. Next. Next. Okay, so the presentation is on the Topcon GTL 1200. This is a scanner plus total station. It's a 2-in-1 machine. You can use it for both. Back. You'll get the layout, you'll get the control point, then the as-built, and then the scan. Next. Okay, so today I'll be explaining two machineries of Topcon that are laser scanner. This is a GLS 2200, which we have displayed on a stool down in the horseshoe in the tunnel. Okay, for the GLS 2200, you have to start with the construction, tunnel construction. Simple, just blast with the dynamite, scraping the debris, spraying the concrete, and repeat the process. As-built, for as-built, you have to the GLS 2200 to capture as-built to see the progress of the tunnel construction at the office. Process your scans in collage, office, college site. Basically, for this machine, you only have office software and in-house software, and that is the top scan CYR for tunnels. This will generate cross sections, compare as-built and tunnel design, calculating volume and report generations. Next. And the GTL 1200 is like it's a 2-in-1 machine, but for the GLS, you have to work with the total stations too, robotic total stations, like you can say for example, a Sokia FX200 series. And for the design by the total station, you have to work in the TCP tunnel CAD. and it will define the project and the template creation template assignments. For the stakeout cross section, stakeout drill points. For construction, tunneling, drill and blast, scraping the debris, spraying the concrete, repeating the process as built. As built, collect as-built cross section, deformation measurement, progress check QC, inspect the quality and tolerance as-built versus design, volume calculation as-built versus design, progress checking of volume concrete to spray. Next. Here is the GTL 1200. For GTL 1200, you'll use construction with the same methods like before with the GCF, sorry, GLS and the robotic drill stations. But in this, you would not design, you will not design the tunnel. You'll simply go to as-built and capture the as-built. You'll go to cross section in the TCP tunnel scan. In this machinery, we will be using two softwares. One is an on-field software that will be in the tablet of the machine, and one is an in-office software that will be used for designing the cross sections and making the design and making the transferring the data. It will be in point cloud of the software. Next. Okay. So here is an horizontal cross section alignment, and first we have shown you the horizontal cross section alignment. Next. Here is the vertical cross section alignment. This is the step one, which is project definition, and you can work with on any software with the XML format. And these templates are from Top Scan CIVAR, the software I told you about. Next. These are some features of the TopCon GTL 1200. Here you can see laser scanner measurement range is 70 meters at 90% and speed is 200 kilohertz. Surface accuracy is 5 millimeter. Camera is 5 megapixel. The total station, same. Its measurement range is up to 1000 meter non-prism. Rotation speed is 180 degree. Accuracy is equal 1 millimeter plus. Powered by magnet field software. Next. This is the interface of the on-field software uh, by TopCon. चलाते रहो. You can see they'll be explaining all the things on this. Here you can see the coordinates and measurements, control base. Here, next one. Here they have put a video of. Here you will select the point cloud. Here you will select the point cloud. Here you will select the point cloud measure station for front face point cloud extraction. Select drill hole pattern and take out calculated points. Next. This is a software TCP scan wire. TCP scan wire. Here they'll show you everything how it's done on the. Here they'll show you everything how it's done on the software. Okay, here are all the cross sections displayed on the software. It is AutoCAD. The moment. Okay, my last slide, we will Okay, my last slide, we will dig into your tunneling workflows with the productivity increase. Scanner can capture tunnel as built quickly because it's faster and highly productive, and it's a new machine. That's why data collection and layout with same instrument, cost saving and eliminate any coordination issue. Generate on-field cross sections. Cross sections can be generated and seen on the field based upon the point cloud data. The GTL has an on-field software and a non-office office software too, so it's easy quite to see the data when you're doing the work on field. Maintain an accurate deliverables, capturing information and generate cross sections at user-defined intervals. Thank you all.
It was really an interesting one. Do we have any question for Ali? Yep, sir.
You are actually generating the 2D profile. It's a 3D profile. It's a point cloud data. So in the point cloud data, the data capturing, is there any problem with the light issues? Because in the tunnel
No.
there are
No.
have you tested this system?
We have not tested this system in the tunnels, but we have in the
I would love to have test trial in one of our tunnels. Or you can coordinate with our training. That's really nice question coming up right from the tunneling guy to the vendor, and it was really nice. You know, it just got a
And
business.
it
Huh?
was
Yeah.
really
So
nice.
and by the way, they
You
displayed
know,
the
you
it's a
just
devices
got a
based
business
model. All of you can go
here.
to the agent
Yeah,
and there's
yeah.
really, really cool
That's
stuff.
all for that. And by the way, they
So thank you
are
so much, Eric.
displaying their technical gadgets and devices in the horseshoe model. All of you can go there and really, really cool stuff. That's the horseshoe model. Thank you so much, Ali. Yeah. Yeah, actually, this works on the LiDAR scanning model. So, we capture all data in real time system. You're working in them in collaboration, drawing. Like I've been part of your team, so it's quite an interesting thing when you do it. You take all the points and transform them into the point cloud, which is actually compatible with Revit. You transform all the data and you get all the files. They're geometric models, but before that, you have to pass them through some noise cancellation softwares to reduce the unwanted points that you have captured during the scanning. But anyway, another regime. We'll have some session about that some other day. So the next presentation we have is Aisha Kesar with us to talk about tunnel safety. We have Aisha, I think. Or is it Marish? Okay. Yeah, let's yeah, let's get a chance to Aisha to talk first. Aisha, could you please come up and join us at stage? Will you be playing your recorded presentation or will you give us a lab? Okay, so please go on the recorded presentation, and Aisha will be here to answer any question if there will be any. Thank you so much.
والصلاة والسلام على رسول الله وعلى آله وصحبه أجمعين أما بعد أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Respected members, I welcome all of you with an Islamic greeting. Assalamu alaikum wa rahmatullahi wa barakatuh. I am Aisha Kaisar, a civil engineer. I work in a structural design office where we are under strict orders to follow codes and standards, kind of like a chef following a recipe. Just as we can't skip steps in baking a cake, we can't ignore the codes in the tunnel construction also. Okay, let me give you one more example. Imagine you are on a construction site, deep underwater. The atmosphere is tense as workers hustle to meet deadlines. Suddenly, a minor crack appears in the wall. It seems small, but if unnoticed, it could lead to the catastrophic consequences. This is the reality of tunnel construction, where every small detail matters. So today, I am excited to introduce a solution that can help us to keep a construction project on track, a construction standard monitoring app. These are the table of contents, inshallah, I will be discussing. Okay, let me give you a brief introduction about our idea. The first step is about making buildings really smart, that they actually knows what's going inside them. And the second thing is the digital twin approach. The digital twin approach offers a smart mirror of the real world, enabling us to monitor, simulate, and optimize physical processes digitally. Okay, let me highlight some major issues. The first one, tunnel standards are tough to meet with manual monitoring. Small cracks, if missed, can lead to serious structural problems. The second thing, inspections are slow and often miss key factors like material quality and construction errors. So in Pakistan's struggling economy, these delays and financial pressure making quick solutions essential. So for developing country like Pakistan, adhering to construction standards is crucial for infrastructure development, but manual monitoring makes compliance challenging. To ensure sustainable and safe tunnel construction, there is a dire need to implement automated real-time monitoring systems to detect defects early, maintain quality, and reduce costs. The objectives of a presentation are to ensure compliance with the construction standards, to enable early detection of defects through real-time image recognition, and to contribute to economic growth by increasing the efficiency and reliability of infrastructure development. Our proposed solution involves two key components. First, an app equipped with real-time camera image recognition to ensure tunnel construction standards are upheld and to quickly identify defects. This allows the construction team to take immediate corrective steps, enhancing safety and efficiency. Second, implementing toll plazas and tunnels, which would provide a steady revenue stream, supporting economic growth through sustainable infrastructure funding. Our app has four core features. First, standards database, a built-in collection of tunnel construction rules to ensure compliance. Second, camera integration, real-time images to verify that materials meet required standards. Third, defect detection, advanced technology to detect and label cracks or other structural issues. The fourth, real-time alerts, immediate notifications for any issue or rule violations, enabling quick corrective actions. Together, these features ensure high quality, safe, and efficient tunnel construction oversight. Now that we have seen how the app ensures tunnel quality and safety in real time, let's look at the next part of the solution, implementing toll plazas. By placing toll booths for tunnels, we can further the upkeep and future improvements, making the infrastructure more sustainable and economically beneficial. In conclusion, our solution brings together better quality, improved safety, and economic growth. By combining real-time monitoring with sustainable fundings through tolls, we ensure that the tunnel infrastructure meets the highest standards, remains safe, and support long-term economic benefits. Here's a list of references that supported the information and data in this presentation. Thank you all for your attention and interest in this project. I'm happy to take any questions or hear your feedback. Jazakallah.
Thank you, sir.
We have any questions?
We have any questions?
Yeah.
Yeah. When is the beta version of this application will be available on the market?
Inshallah, sir, this is our goal. Inshallah.
You're making it soon, right?
Yes, inshallah.
I promise you will be your first buyer. Yeah. Do we have any other question? I mean, this is some serious stuff going on in our universities. We'll be wasting our time in the playgrounds, and they're making application to track down safety and economize the construction. Yes, Dr. Saab.
That's awesome. Yeah, that's a very lot of community engaged part, and the same is on our side too. So, number one is that for the testing trials, what you have done till now in the incubator beta,
Sir, this was our start. Just we just make an idea, and I just got the opportunity to present my idea here. So, inshallah, next step will be our trials and then so on. Thank you.
sure.
Thank you.
We need any support we are here for this kind of initiative.
Thank you, sir.
Thank you. Oh, yeah, it's really some cool stuff. And by the way, it was short, crisp, and precise by definition. Yeah. Thank you, Aisha, for this wonderful presentation. And now we have uh, Mohammed Marij with us to present another exciting presentation, tunnel support design software, and again mobile application. Wow, innovative support system for tunnel engineering. Guys, where have you been?
Assalamu alaikum. Uh, First of all, thanks to the management for organizing such an event. Uh, just next slide. Basically, basically, this is a software and design system. And first of all, myself, Mohammad Marik, founder of the software, and my fellow Mohammad Sufyan name, he's not here because he's hospitalized, and now he's in.
Introduction. First of all, the objective of the software is to provide comprehensive tools for assessing and designing tunnel support system. As we all know, building something on the ground and in the ground is totally different. Tunnel design is a complex system. We can't do totally different. Tunnel design is a complex system, and our target users are civil engineers and tunnel designers. Design challenges. Ensuring structural integrity in varying geological conditions, balancing safety and durability while controlling costs, addressing groundwater impact, and selecting appropriate waterproofing solutions. Purpose of the purpose of this software is basically to enable quick calculations of tunnel support requirements, provide accurate waterproofing recommendations based on geological factors. If you are constructing, you don't know what if after removing some rocks, what kind of rocks we are going to face in tunnel. So for design, for the solution of that kind of situation, we have designed this mobile app for the use of the tunnel. Next slide. Key features of this software is the RMR rock construction system consider rock quality, spacing, and conditions. RSR rock structure rating rates geological and groundwater conditions. Q method evaluate multiple parameters including joint roughness, joint alteration method, joint water injection method, and stress frequency method. Waterproofing recommendations integrated based on groundwater conditions, recommendations for protective techniques like membrane systems, concrete additives, etc. Mobile app overview. Purpose bring up strange functionality in mobile app for an on-site calculation. Basically, this is a software and mobile software. Mobile app. If you are using and designing the tunnel support system in our offices, the same app version is in the mobile phone for if we all know that tunnel construction is far from the city, so we don't have any internet. If we are short of internet connection, we can do it on offline software. As features drop-down options for inputting values based on parameter rating. All parameters are already listed in the software. We just click on the drop-down and we will have the all rating system in the drop-down menu, and we will just select the value of our system according to the rock conditions, cross platform and offline capabilities. Desktop software, basically the programming language we have used in is Python with the language of Enter and Below, and the mobile app I have created it on Android Studio, use Java programming language, and in the future we have decided to give a backup in the backup option, so we can store our data in the backup. These are the user interface snapshot. First of all, we start from the click on just click on the button of start. Then we will select the method, new method, RMR, and whatever we are using for our tunnel. This is the software version of the desktop software version of the tunnel software. Benefits to engineers and project managers: enhanced efficiency, save time on manual calculation, improved accuracy, data-driven recommendation, minimizing human
errors, increase mobility, mobile app enables on-site evaluation, cost-effective optimizes sport recommendations based on geological assessment, potentially reducing material costs. For future enhancements, potassium upgrade we have an idea of it in our mind. Cloud storage for sharing assessment and sharing results. Expanded to the iOS platform for broader access. Integration with CAD tools for design visualization, and also a feedback from an experienced person. The person who are going to tell us that these are the shortcomings of the software, and we are going to work on the software and we will make it more and conclusion. Comprehensive solution for tunnel stability and sport design integrates RMRQ and RSM methodologies for accurate analysis and provides tailored waterproofing recommendations for various groundwater conditions, user-friendly interface for engineers and students in both software and mobile apps, enhance efficiency and safety in tunnel construction and geotechnical assessments, promote sustainable and modern approaches in the tunneling industry.
Here's a question from Sahil, you take your question from after that, slide empty in this software, you can implement to the mapping and other work by engineers. It will be what take care of the show. Alternate for
सबसे वाली ओपन कर सकते हैं आप यूएस में कॉपी कर लें यहाँ ये यूएस में कॉपी
for all this, just we will go to the data which we have collected from the site in the software, and it will tell us the support system we are going to use in the software. The point we are talking about is the future plan of us. We are going to use in the CAD. We are going to use the CAD software for that archaeological map.
To bring some software to the market as a tester, get some review from the users, and we'll keep on improving that. Well, I am surprised to see that we are now into the software and mobile phone applications development process, even for television projects. That's really something exciting. Yes, the mobile phone application based software you're talking about, why is it particularly on the other hand we have one software that is used in the system with respect to line change or tunnel project or whatsoever. Why specifically you are focusing on mobile app based designing solutions as well? So yes, I was also mentioning the presence of all the existing software, right? Why do we need mobile application?
There are many software that exist and not software, but this software I know if it's possible for on-site calculation. If we are on-site calculation. So they are basically parameters you are just going and scanning the data part without internet. Without internet, I have the software in my mobile phone. If you want to use it, okay.
Thank you so much. Again for knowledge. Guys, you are doing some wonderful work. That was fantastic. Okay. Next, we have, I heard that, do we have Manas with us? Awesome. Can you confirm, do we have Manas with us? Manas is listening. That was really fantastic presentation. Artificial intelligence and machine learning, internal design and construction. Wish we could have that. But anyway, Anas, if you are around, please just drop a text and we know we'll take you on board. And we have Fatma Ijaz, and I heard similar news about Fatma that she is also having some technical difficulties.
Recorded it? Yeah, recorded it.
Oh,
Recorded
that's
it?
me after that. But I did that presentation with my
सर
friend
बात
from
recorded.
very long distance who has come to attend this presentation. Salman Rai. So topic of presentation is numerical evaluation of rock dust encountered in deep tunnels. He has come here all the way from Beagle University, Balochistan. Yeah, that's something fantastic. People
इसकी
coming
presentation
to
कहाँ है?
this center of
उनकी
the country
presentation अभी
from
please
farthest point to attend, such events. For me, I mean, this is the achievement. Like having people from the farthest corner of the country here to present their presentation physically. So go on. Then. How much long will you take for this? So, as it's a graveyard session, yeah, we are having another technical glitch with the presentation uploading of Salman. Salman, you will join after me. Don't worry, you are with us. So, ladies and gentlemen, bear with me as the most boring presentation of the event is here.
सर की उधर से केबल लगा है सर की वहाँ से केबल लगा
So, just a quick background, which I think is not that much important. I've been working in the industry since early 2014. I started my career specialist and then I joined Federal Organization on the Karachi Power Motor Reliability project. And then moved to Sawat Motor and our project. And then being the project manager of this facility, constructed as a project manager. And then I was promoted to the Yamir Basha Dam project as the manager plan and cost control. Beside that, I am the executive secretary of Pakistan Building Trenchless Society as well, and member of the International Talent Association Quality Equipment Committee, who deals with the contractual practices and project delivery methods at time. And as a hobby, I promote a lead for sustainable development. Okay, so the topic of my presentation is trenchless technologies and learning. Okay, now imagine two mice, one big, one small. They are making tunnels underneath the surface for their sizes. And they're trying to make the world look beautiful in their own sort of ways. In the trenchless technologies, our tools and equipment works the same. Based on our requirement, we need, at some point, we need small diagrams, at some point, we need some medium diagram based on our requirements. So it's just like, small mice and the big mice game. We play the same rule for developing our underground sustainable infrastructure. I would like to dedicate this presentation to Dr. Isley, who is globally known as the father of trenchless technologies. Professor, if at some point in your life you pause this for him for not going through all your credentials, that run short of time. So I'll be quickly coming to the go on, go next. Yeah. Trenchless technology methods. So will be there are like two more methods, but I will cover these four methods: utility tunnels, pipe jacking, horizontal direction drilling, and horizontal auger boring. The most simplest way possible for me to bring it to the students and then to have young tunnels or aspiring tunnels. Next, please. And of course, we'll be talking about micro tunneling to solve out the go on. Imagine having different utilities placed in the different location of the taking a humble jumble around and placing them in a combined tunnel, placing them in a way that will be approached anytime for appropriate maintenance, all together having in a common space. Come on, next please. Okay, so starting with the utility tunnels, Utility tunnels are done in two steps. First is a single robotic tunnel with a 15-volt machine, small in size. It's mixed ground. Then we provide the primary rock support system.
And finally, uh, thank you. And
Finally,
finally,
we
we
provide the
provide the
secondary
secondary
liner,
liner,
and within
and
that
within that
liner,
liner,
we
we
install our
install our
production
production
pipes.
pipes. It's more or less like micro tunnel.
Then comes
Then
the
comes the
pipe jacking
pipe
method.
jacking method.
It's one of
It's
the
one of the
old methods.
old
Pipe jacking
methods.
was
Pipe
first
jacking was
used
first
around
used around
1900.
1900.
First used as
First
a
used
person
as a
entry and
person
hand
entry and
excavation
hand
method.
excavation method.
Initially, it was
Initially,
done
it
like
was
that.
done like that.
We can achieve
We can achieve
larger
larger
diameter
diameter
with
with
that,
that.
suitable for
Suitable
soil
for
and
soil
mixed
and
ground.
mixed ground. Uh, various level of phase support can be achieved through this method. Long distance tunneling can be done with this method. Suitable only for above the water table because you cannot control the groundwater with that method. And of course, it is stable. You can have different sort of curvature and turning in your design, and they can be managed with this method. So here are some pipe jacking materials. They can be made of steel, GRP, HDPE, based on their purpose requirement. These are some equipment that are available in the market. Next, please. For this method, a very simple one is with like the front end excavator. Then we have this road header boom with the one, and then we have a cutter head for soft soil. The bottom two are for mixed ground, the ground where we have gravels in it. They are suitable for such grounds. As you can see that we have a couple of no, please, yeah, we have you know, a screw in one of them, just like a gripper TBM. So they are suitable for mixed grounds. Next, please. And there comes the horizontal directional drilling method. Uh,
I was studying a
I was
document
studying a
that in
document
US
that in
they have
US
achieved
they have
over
achieved over
2,000 meters
2,000
of
meters of
distance
distance
with this
with
machine.
this
And
particular
this is
method.
one
And
of
this
the
is one of the
fantastic.
fantastic one.
I will be
I
showing
will
you
be
an
showing you an
animation
animation
which
which
will
will
be
be
covering
covering
all
all
the
the
steps
detailed
of how it
aspects
is
of how
done
it is done in a
swift
very
manner.
swift manner.
You
But
can
you can
achieve
achieve
from
from
2
2
inch
inch
to
to
48 inch
48 inch
diameters with this
diameter with
method.
this method.
It is applicable
It is
for
applicable
utility
for
conduits,
utility
pipelines,
conduits,
gravity
pipelines,
sewer
gravity
lines,
sewer lines,
and
and
of
of
course
course
for
for
geotechnical
geotechnical
investigation.
investigation.
Please
Please
move
move
to
to
the
the
next
next
slide
slide
and
and
help
help
me
me
play
play
the
the
video.
video. Yeah.
We
So
have,
we have,
let's
let's
say
say for
for example,
example,
a
a railroad
railroad
or a
or a highway
highway
or
or
a
a
river,
river,
and
and
we
we
need
need
to
to
pass
pass
our
our
utility
utility
lines,
lines,
meaning
meaning
that
that
we
we
have
have
an
an
entry
entry
point.
point.
From
From
there,
there,
we
we
place
place
our
our
equipment,
equipment,
the
the
horizontal
horizontal
directional
direction
drilling
drilling
equipment.
equipment.
It
It
passes all
passes
the
all the
obstruction
the
that we need to
obstruction that
pass,
we need
and
to
at
pass,
the
and at
farthest end,
the
we
farthest end,
receive
we
the
receive
pilot board,
the pilot
we
board.
attach the
We
reamer
attach
with
the
it,
reamer with it,
and
and
along with that,
along with
we
that,
pull
we
the
pull the
production pipe
production
along with that
pipe
reamer as well,
along with
and
that reamer
receive
as
it
well,
at the
and receive it
entry
at
end.
the
So this is
entry end.
how
So this
now
is how
you go with the
you go with
pilot
the
board
pilot board
at the
at the
target end,
target end,
attach the reamer
attach the
with
reamer
the
with the
board,
board,
and we
and you
pull back the
pull back the
reamer
reamer
while it is
while it is
operating its
operating its
rotational motion and
rotational motion and
excavating the ground like
excavating the ground like
slightly
slightly
20% more than
20%
the
more than the
production pipe.
production pipe.
But
But
very important
very
thing
important
we
thing
must
we
not
must not
miss here,
miss here,
the
the
use of
use of
bentonite slurry
bentonite slurry
to provide
to
the
provide the
lubrication effect
lubrication effect
as well
as
as
well as
maintaining the
maintaining the
surrounding ground
surrounding ground
intact.
intact. Okay,
Let's go
let's go
a little bit
a
more
little bit
ahead.
more ahead.
Then comes the
Then comes the
overboard
auger boring
process.
process.
Let's just skip
Let's
it
just
and go
skip
to
it
the
and go to the
animation.
animation.
It's
It is
similar to
similar
the
to the
next slide,
next
please.
slide, please.
Sort of
Sort
similar
of
to
similar to the
the
play the video, please.
similar to the
Similar to the
HDD, but
HDD,
here
but
the
here
nature of the
the nature
equipment
of
is
the
a little
equipment is a
different,
little
and we
different,
need a
and
little
we
more
need a little
space.
more space.
So we
Okay, so
provide
we
some
provide
sheet
some
piling
sheet
to
piling
protect
to
the
protect the
ground. We make
ground. We
a
make a
ditch to
ditch
place
to
our
place our
HDD
HDD
auger
auger
boring
boring
machine.
machine.
Auger boring
Auger
is
boring
just
is
like
nothing.
the
It's just
pile
like
boring
the
machine, but
pile boring
it's running
machine,
in the
but
horizontal
it's
direction.
running in the
So
horizontal direction.
you make a
So
platform for
you
that,
make
place
a
a rail
platform
there,
for that, place a rail
so
for
that
it,
it can be operated there. You attach a sputter to it, and all those
so that it can be operated there. You
casings,
attach it and
and it keep
uh,
propagating in the
casings,
ground
and it keep
from the entry
propagating in
point
the ground
to
from the
the
entry point to the receiving shaft or recovery shaft. So this is how it is cutting the ground, taking out the slurry. Piece by piece, we are connecting the pipes and making our way uh, underneath the existing infrastructure facility, whether it be a railway road or a highway road. And once we are done with placing the casing, we remove the cutter, the reamer, and we have this enough or sufficient space for providing our production pipe. Production pipe is the one that we're actually making this conduit for. It can be a water supply pipe, a gas line pipe, or any other one. Yep. Here comes the production pipes. Come on. Oh, there they are. So we covered a bit of, next slide, please. Next slide, please. We covered a little bit about trenchless technologies, but let's ask the question, why trenchless approach? I mean, it enables us to disrupt the surface at the minimal. It avoid utility conflict. We'll be seeing that. One of the good thing that it is almost most of the time it is laser guided, so it's highly accurate. Suitable for most type of the soil. Can be controlled remotely. And one of the system that we even discussed with the point cloud based data system, we can control it with the laser guided system. Uh, Good for counterbalance pressure, to maintain the ground stability with these methods, and excavate earth and install pipes simultaneously. Like, you can do things together. You are excavating and you are placing the pipe all together, like we saw in the pipe jacking method. But it comes with a lot of cost. Yeah, next slide, please. These are some, I will not taking so much time on these because you will be having these proceeding. Open cut has its own advantages and micro tunneling has its own advantages, but micro tunneling comes with more capital costs. It requires special workers, it requires special equipment, it requires more operation and maintenance costs rather than open cut where we can use some unskilled labor. There is abundance of the equipment that are used in those methods. But of course, they have challenges with that. But if we look into those aspects that we just discussed, you go next slide. The micro tunneling approach becomes more expensive as compared to open cut. Go next, please. Next, please. Yeah. No. These are some factors, if we take it into account, they make the open excavation or open cut excavation a little bit uneconomical and difficult as well. As you can see, this picture is from some developed country, not from Pakistan, India, or Bangladesh. But still, you see this cluster of those utility lines, how they are being disturbed with the open excavation. And again, we have problem for unstable soil. There can be challenges of dewatering that we have to face. Go on to the next slide, please. Again, we have to provide sheet piles to protect the slope. The open trenches cannot be maintained for longer time period. And ultimately, it will increase the construction cost. So next, considering those points that we just discussed, they make the open cut more expensive as compared to micro tunneling. Even the only last point, that is social cost. Especially we talk about urban infrastructure, we make open trenches on main roads or besides them. We have observed them, or we have experienced them, how terribly they disturb our routine life. I mean, we lose a lot of time, our commercial hubs are disturbed, and we are facing a lot of difficulties in mobility around those areas. So it is disturbing the socio-economical activities of that region where the open trenches are. Even that thing only is making the open cut method expensive. So it was about the cost. Just, let us be settled down on that micro tunneling is even more economical than open cut. So I'll be giving a quick overview about micro tunneling, mega tunneling, just to make the amalgamation of how small tunnel can, become large tunnel, from smaller to larger. I will take the liberty to give an example of the one of the member nation of International Tunneling Association, Singapore. They have planned their deep tunnel sewer system. All the statistic of the project is on the slide. You can review them later. Next, please. Again, their underground electric cable network, one of another wonderful, fantastic project. As you can see, they have this tunnel you can see it on the bottom right of the slide. They have multiple conduits within a single tunnel to accommodate various type of electric cables. So, like smart use of underground space. Next, please. And then there is multiple layers of tunnel for rail, road, utilities, and multi-purpose tunnels that are being placed at different level. It's like one of the fantastic ideas that a nation can come up with. Next, please. Okay. Finally, multi-purpose utility corridors. The recent stream of underground space association is more converged towards the multi-purpose utilization of underground space, converging all the infrastructure utilities within a single conduit, accessible for maintenance all the time, under surveillance, under the monitoring of various sensors, making it more easier to use lesser space for more utilities. And they are calling it a holistic approach for sustainable urban infrastructure development. So I would like to invite you guys to see those pictures, broaden your horizon, and you guys can work on that field as well. How to come up with the ideas to give some better solution, how to make this world even more beautiful by leveraging underground space used for sustainable urban infrastructure development. And with that, I would say thank you. And if you have any questions, please. Yeah.
So initial slide you asked told about beamer and bentonite clay. That in my view is not that much enough surrounding process for that particular hydrodynamic. As well as if you have the caving and some other, is there some retrieving mechanism also within the trenches technology available? It's another story which becomes get stuck and you have apply another PPM, another trench technology to increase cost of the project.
Your question is actually particularly about the horizontal directional drilling method, right? So it's controlled alignment through laser guided system. And if you are stuck, I mean, first of all, you have this wonderful geotechnical baseline report that tells you about the ground condition, which path to follow, where not to follow. But in case if something goes south, of course, if you talk about micro tunnelings, you can always go for a rescue shaft. But in such cases, of course, you have to retrieve and choose another alignment. But you know, in
there is no plan B to check stuff harder.
but no, for that you need to have a very good geotechnical investigation to have about. I mean, you can let's say, for example, let's talk about stratigraphy. You have some suitable strata. By the way, that is good for soil and mixed ground, not for rock. We're talking about shallow conduits. So I mean, bentonite is fair enough to give the lubrication and stability to the surrounding cave. Yeah, this is in practice. I mean, it's actually happening around. Soil and mix. Nah, yeah, exactly. Yeah, yeah, yeah. Any other question? Can I ask a question from the house after this presentation, if I'm allowed? Yeah. After listening to this trenchless technology and open cut, we had this small comparison. Please spare a moment today and think about it. Like, should we use in Pakistan perspective, should we use or keep on using the open cut method, or should we opt for the trenchless technologies? And let's share our thoughts someday. Yeah. Thank you so much, gentlemen. Okay, so are we done with the presentation of Salman? Is it uploaded? Okay, Salman, will you please come up on the podium and okay, please make it quick. We are ready.
I will introduce myself. It's Salman Laik from GTM University. I am the regular student of 7th semester. Uh, it's not my project, but I work little bit for such sessions. I want to join such opportunities. Yeah, I am glad to be here. to give me such opportunities. Second, I am basically from South Waziristan. I am the only geological engineers from entire my village. My village consists of minimum 300 houses. Uh, Waziristan people are mostly go from IT side to IT side and BBA, MBA from that. But I am the only one. When I take admission in Bhutan University, a lot of people are telling me that this department is useless. I tell them if I am the only one in my class, only I am in the class, I will take admission in Balochistan. I will complete this department at this geological engineering. It's my choice. It's not by chance.
Let's move to the presentation wherein Hossein, can you move to the presentation? Sir.
So it's Salman Like, and my colleague is Mr. Yusuf. I am geological engineer, 7th semester BTM. Please, next. Introduction. Rock bursting defined as the damage to excavate in the sudden. See, what is rock bursting? The sudden, the sudden, the sudden manner of sudden frequently manner of any rock which affect our tunnel is called bursting. Bursting is a problem during the deep tunneling and mining of the tunnel in in many countries, leading in engineering fatalities, facility damage. So if the rock bursting is occur with us, injuries will be occur with us, fatalities. The entire tunnel will be damaged. And move on. Cause of rock bursting in situ stresses. What is in situ stresses? Those stresses which are inside, those stresses which are under the rock. For example, horizontal stresses, vertical stresses, or in situ stresses. The If the rock is brittle, then it is have a more chances to a rock for a rock bursting, sudden fracturing. If we are construction any if construction the tunnel, if we facing the sudden fracturing, it will be a cause of rock bursting. See, structural plan. These are the two plan. These are two plan structural plan of surrounding in a tunnel. This is one. So this structural plan will be cause the rock bursting. Move on. Rock bursting. I already defined to you people. Let's see. This is the Jinping 2 hydro power station. This is the structural plan. Jinping hydro power station 2 also face the rock bursting problem. Uh, and this let's see this is the structural plan. This zone will be collapsed if there are the accumulation of stresses. The high accumulation of stresses, this portion will be uh, burst. Move on. Let's see which factor affecting the rock bursting. Seismic events, geology, geotechnical, mining. These are the main four factors which affect the rock bursting. Seismic, if we are doing any seismic activities, for example, if we are doing a construction of tunneling, uh, if there is occur earthquake, it will be affect our construction and numerical modeling of rock bursting. Let's see. These are the two models. This model is elastic plastic model. This is the elastic brittle model. the rock will the rock always behave elastic brittle behavior. So this is for those things which have elasticity and plasticity. Rock haven't any plasticity. Rock will behave like a elastic brittle behavior. More. I made a model on phase 2 software. This is a model and have a structure plan. Move on. Let in initial I give the sigma 1 approximately to 60 megapascal, but if you see that the complete stresses is accumulate around the tunnel. See that the stresses reach to 161. So if the initial stresses are 60 to 80 megapascal, after the excavation and the effect of structure plan, it reached to 161. It's minimum to it's the double of the initial stresses. So I am telling about that this phenomena will occur rock bursting. Mon, excuse me. See that it's the sigma 3. uh, it's the it's the same. I told it already. Told about the told about the sigma 1, 2, and z. So move on. It's the same phenomena. Now vertical displacement. This area is displaced by that structure plane. So if the plane was not there, this area will not be displaced. If this area displaced toward the excavated part, it will create more. The stresses will be accumulate here, and it will the main cause of rock bursting. Move on. If you see the last slide, the stresses was 161. If I excavate another tunnel in the same rock, the stresses reduced to 130 or 140. Why? This is the main. If we excavate two or more tunnel in a single rock, the total stresses reduced to will be reduced. So that was the same. If I excavate another tunnel here, the sigma 1 reduced to 136. I mean that if core a rock more than one excavation, the strength of the rock will be reduced. I compare my model with the Nilam Jalam project, which is I take from Abdul Muttaqim Naji, which is my teacher, Dr. Abdul Muttaqim Naji Sahab. This is the 3D model. It's a 2D model. Where I talking about displacement, vertical displacement. Here is the vertical displacement. See that the tunnel is squeezed here. The tunnel becomes squeezed here. It means that there is a vertical displacement, and this the and this is the it's the accumulation of stresses. More conclusion. What should we? How can we reduce the rock bursting? First, in underground environments are accumulate near a structure plane like joint. Mainly the stresses are accumulated in joints, shear zone, and faults. Such a localized strain accumulate can be cause release of stored strain energy in the form of rock bursting. If the stored strain energy released, it will cause rock bursting. Extra precautionary measure should be taken while excavation. Third, this we should take precautionary measurement to avoid rock bursting. Mohan, if you have any question. Thank you.
Caller. Fatma is just online.
Good afternoon and good evening to everyone. I am Shahid Ijaz and I am young member chair of Pakistan Turning and Trenchless Society and also co-chair of SIDA 2024. Now I would like to invite Miss Fatma Ijaz for her presentation. She will join us online. Over to you, Fatma. Fatma, can you hear us? Fatma?
Yes,
Yes,
yes.
yes. Okay, over to you.
Am I audible?
Yes, we can hear you.
Okay.
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 So,
So,
my name is
my name is
Fatima
Fatima
Ijaz.
Ijaz.
I'm
I'm
currently doing
currently doing
my
my
master's in
master's in
geological
geological
engineering,
engineering,
and today
and
I
today I
present the
present the
topic
topic
effect of
effect of
thermal
thermal
treatment and
treatment and
LVD
LVD
confinement on
confinement on
abrasivity,
abrasivity,
buildability,
buildability,
static and
static
dynamic
and
properties
dynamic
of
properties of
Kapristan
Pakistan
Pluton granitic rock.
granitic rock.
So,
So,
first we
first we
start with
start
a
with a
simple
simple
question
question
on how
on
can we
how can we
meet the
meet
world
the
growing
world growing
energy
energy
demand.
demand.
Right now,
Right now,
our
our
energy need
energy
are
needs
higher
are
than
higher
ever.
than ever.
They kept
They kept
rising
rising
and keep
and
up.
keep up.
We are
We
turning
are
to
turning
new
to
forces within the
forces
earth,
within the earth,
tapping
tapping
into
into
sources like
sources
oil,
like
gas, and
oil, gas, and
geothermal
geothermal
energy
energy
from rock.
from rock.
But here's the
But here's the
challenge:
challenge:
reaching these
reaching
deep
these deep
resources isn't
resources
easy.
isn't easy.
Drilling deep
Drilling deep
underground is
underground
extremely
is
costly and
extremely
complicated,
costly and
especially
complicated,
when we are
especially
drilling
when we
through
are
hard
drilling through
crystalline
hard
rocks
crystalline
like
rocks
granite.
like granite.
As we drill
As we
deeper,
drill deeper, the
costs go up
costs go
fast,
up fast,
and a
and
large portion
a
of
large
these
portion of
costs
these
come from
costs come from
drilling itself.
drilling itself.
So
So
let
let
me uh,
me
let me explain
let
why
me
this is
explain
such a
why
big
this is such a
challenge.
big challenge.
When we use
When we
traditional
use
drilling
traditional
method in
drilling
hard
method
rock
in
like
hard rock
rotary
like
drilling,
rotary drilling,
the drill bit
the
wear
drill
out
bit
quickly.
wear out quickly.
The progress
The
slow down,
progress slow
and
down,
we end
and
up
we end
wasting
up wasting
time and
time
placing
and placing
costly
costly
equipments.
equipments.
All of this
All of
add
this
up
add up
to big
to big
expenses, which make
expenses, which
drilling
make drilling
projects
projects
a major
a
financial
major financial
commitment.
commitment.
So,
So,
how we do
how we
bring
do
these
bring
costs
these
down
costs
and
down
make
and
drilling more
make drilling more
efficient?
efficient?
Well, there
Well,
are
there are
many
many
approaches the
approaches the
researcher
researcher
proposed,
proposed,
and the
and the
one is
one is
thermospallation.
thermospallation.
So,
So,
in this
in this
technology,
technology,
it
it
simply heat
simply
the
heat
rock
the rock
that
that
weaken and
weaken
break
and
rock
break
apart,
rock
making it
apart, making
easier
it
to
easier
drill.
to drill.
It's
It's
especially more
especially more
promising
promising
in hard
in
rock
hard
like
rock like
granite,
granite,
where
where
traditional drilling
traditional drilling
struggles.
struggles.
It's not the
It's not
only
the only
method. There are
method.
other
There are other
techniques like
techniques like
hammering,
hammering,
hydraulic
hydraulic
jetting,
jetting,
but
but
they don't
they don't
perform well
perform
in
well
hard
in
rock.
hard rock.
This
This process
this
also,
technique
this
also has
technique
its
also
own
has its own
limitation, like
limitation, like
it's not
it's
work in
not work
soft
in soft
ground
ground
and the rock
and the
having
rock having
cracks.
cracks.
So
So
in my
in my
study,
study,
we look
we look
closely at
closely
how
on
thermal
how
spallation can
thermospallation can
improve deep
improve
drilling in
deep
hard
drilling in
rock
hard rock
by
by
improving different
improving
temperature
different
and
temperature and
pressure.
pressure.
We are
We are
testing the
testing
effect
the
of
effect
heat
of
on
heat on
granite to
granite to
see how
see
we can
how we
make
can
the
make the
drilling
drilling
process
process
faster, more
faster, more
efficient, and
efficient, and
ultimately more
ultimately more
economical.
economical.
Now
Now
let's
let's
okay
okay.
this one.
That's one.
Okay, so
Okay, so
how
how
when
when
we heat
we
the
heat the
granite,
granite,
The interesting process is how granite cools after being heated to high temperature. When rock like granite heat up and then cool down, their property changes. The cooling process can cause crack, release energy, and even alter rock strength. So, as we look in the cooling curve of granite after it heat to a temperature like 125 to 600, um, we can break. So we can break the cooling curve into like three phases. The first, this one. The first is the rapid cooling phase. The second one is the gradual cooling phase, and the third one is the stable cooling phase. So the first phase, when the granite release most of its energy very quickly, this is a cool down sprint. It's fast and intense. During this phase, uh, it lasts about almost 50 minutes. The granite drop, the temperature drops sharply, and here's the interesting part: the higher the starting temperature, the faster the cooling happen. And this rapid cooling leads to a lot of intense crack in the rock content. That stress cause crack to form, release stored energy, and in a way, this phase is when the rock undergoes most dramatic changes. So the second step, that is after 15 minutes, we enter a gradual cooling phase. The cooling phase slow down and become more predictable. The temperature drop is more steady in this case, and the rock is still releasing some energy, but this phase is much gentler compared to the rapid cooling phase. Cracking and energy release are minimum. The cooling curve start to flatten down, and this phase is like the rock catching its breath after intense cooling. And the third part is stable cooling phase. So this one, in this phase, rock temperature has nearly aligned with the surrounding environment. It's at the stable, balanced state. This is the cool down finish line. The rock has released most of its energy, and there is minimal changes in its structure. Any remaining change are tiny and don't contribute much to the cracking of energy. Impact of cooling phase. So this one. Now we study the impact of cooling phase on granite properties. So why does this cooling phase matter? From this research, we see that the rapid cooling phase is the most critical for rock properties. This is when the major cracking happen. So in this picture, we see as the temperature increases, the fracture width also increase. Next, how physical appearance of rock changes with temperature. At room temperature, granite is typically an off-white, and its structure is much more stronger and stable. But when the temperature rises, it turns from yellow to slightly reddish. This is because of the oxidation of iron. And then after temperature 500, we see a small minor cracks on the surface. So what happened on the inside of rock and outside of rock? So up until around 500 degrees C, the granite stays smooth without any noticeable crack. But as we go beyond 600, crack begin to appear on the surface and also inside the rock core. And this and at 700 or above, the rock starts to crumble with its own weight. And as the temperature rises and as the continue heating, these small cracks get bigger and start connecting with each other. Also, at 500 degrees centigrade, some minerals go through changes that make these cracks spread even faster. For example, at around 560 degrees centigrade, quartz goes through a phase shift that causes it to swell up around 8%, putting extra pressure on surrounding mineral, and this adds stress, lead to more crack through the rock. Okay. The internal changes can also be heard, but like when we tap pieces of granite that have been heated below 500, we get a solid sound, a good sound that the rock is still intact. But after heating granite above 600, that tapping sound change. It become more muted and dull, showing that rock internal structure has broken down and isn't as solid as it is was. And next we go to resonance frequency. So sound wave help us to understand the change in rock properties as well, especially when we are looking at what happened to the rock when temperature and pressure changes and how this affects something like resonance frequency. So the resonance frequency are a key indicator of rock properties such as strength and stability. When we look at resonance frequency and these wave speeds, we get clue about the rock internal structure. Higher frequency means the rock is dense, stronger, while the lower frequency may indicate a weaker and more damaging rock. So in our finding, we observe that when the temperature rises from the room temperature up to 200 degrees centigrade, the resonance frequency gradually drop by about 5%. But when we heat further between 200 to around 500 degrees centigrade, so the frequency dropped rapidly by over 30%. And why this happened, the higher temperature are causing the rock to expand unevenly, creating more and more micro cracks. And these cracks disrupt the rock internal structure, making it less dense and lowering the frequency. This pattern also shown in other measurements like quality factor, which indicate how well it can sustain wave energy. Also drop as the temperature rose. Above 600, the quality factor falls sharply, suggested that rock structure was severely damaged by the heat. Next, abrasivity and drillability. So abrasivity tells us how quickly a rock wear, and drillability refers to how easily a rock can be drilled. Now, let's look at how temperature impact abrasivity as we raise the temperature of granite. From 25 to 200, we see an increase in CI value. This is because micro cracks form due to thermal expansion of minerals, especially quartz and feldspar. These micro cracks make the rock surface rougher, increase abrasivity slightly. But as we go from 200 to 500, the abrasivity value actually start to decline. Why? Well, most thermal expansion, the microcrack growth, the interconnection of microcracks create more space and reducing rock overall resistance. Especially the rock is getting a bit softer as crack weak its structure. Then an interesting shift happen above 500 when when we see a sharp jump in CI value. This sharp increase is due to a phase transition in quartz, that is alpha phase to beta phase. This transition makes quartz significantly more abrasive, rising the CI value, making the rock much harder on drilling tools. So if we look at the graph of CI value, we see the step rising at these high temperatures, showing the rock abrasivity is highly influenced by this phase change. Second, the effect of temperature on drillability. So this is the penetration rate and this is the specific energy, and both are derived from same test. Uh, Temperature doesn't just affect abrasivity; it has also impact on drillability. As temperature rises, the penetration rate goes up, while specific energy goes down, particularly between 300 to 600. So this one for 3 to 6. As the temperature increases, these same microcracks we mentioned earlier kept growing and connecting. These cracks weaken the rock structure, making it less dense and easier to penetrate. At higher temperature, more cracks form, more micro cracks expand, which increase porosity. Uh, like in this case, this cause a dramatic increase in the porosity, uh, effectively reduce the strength, like you see in UCS and BTS. There is an sharp decrease in the strength, and as well as the drilling through the rock become faster and required less energy. So the penetration rate increases. If we will visualize this on plot of penetration rate, we will see the curve rise sharply between 3 to 6, highlighting much more easier it became to drill at these higher temperatures. So now let's take another layer, that is confining pressure. So when we apply pressure around the rock, it change. So how the rock react to drilling? Higher pressure, for example, at level 10 to 20, compresses the microcrack and make the rock more compact. So temperature expand crack, and confinement shrink the crack or compact the rock. The compression help stabilize the rock, reducing its tendency to fracture, and make it less abrasive, which reflect in low CI value. So this one is at I think this one. This one is the 0, and this is 20 degrees. So the CA value increases as the confinement increases. Also, in this case, the as the penetration rate decreases as the confinement increases. Uh, so if we look at the penetration, so this is what it happens, and then last is a conclusion. Uh, so the effect of temperature and pressure on granitic reveal most insights about the abrasivity and strength and reliability. As temperature increases, thermal induced cracks form within the granite, reduce the wear and tear, improve rock removal performance, and lowering the specific energy required for drilling. So this thermal cracking also weakened the rock, leading to decrease in the compressive strength, resilient tensile strength, dynamic modulus, while increasing in cause a dramatic increase in porosity. So this is all for today. If you have any question, please let me know.
Thank you very much, Fatma, for wonderful presentation and insightful research on properties of Kapristan Pluton rock. Uh, if anyone has a question, she is available for answer. No question. Thank you, Fatma, for joining us.
Thank you so much.
Have a nice time. Now I would like to call our young presenter, Mr. Haider Ali. Please come on the stage and present your stability analysis of tunnel nearby faulted strata using numerical modeling. This topic is always close to my heart. I always love to explore the thing which are in shared zone. So it will be a great presentation from you.
जस्ट बस मुझे इसको
Greeting, greetings all of the tenants. Unfortunately, I can't hope you are doing well because you are sitting here all the day long, and please bear me. So I'm presenting my recent publication in American Rock Mechanics Association, stability analysis of a tunnel nearby folded strata using numerical modeling. So we have collected some data from some case studies that in these case studies, some of the tunnels collapsed due to the presence of folded strata nearby. So one of the major examples is Neelam Jhelum project, as Mr. Tayyib Zubair presented. So there was a convergence zone, a stress zone. So that happened due to a folded strata nearby. So introduction, as I have said, it is a stability analysis of a tunnel nearby a folded zone. So I'll be presenting without any further ado. So why I'm doing this research? There was a research gap. There was a study on folded strata. There was a study on the tunnels, but there was no study on the tunnels nearby or inside a folded strata. And specifically, the novelty is the study of this strata in numerical modeling or using a software. This is the flow chart I'm using. We did a literature review, then we collected some data, and then we built some models in our software, Flat 2D, and then we ran some analysis, and then we suggested a solution for such a problem. As I've mentioned, we have studied some of the material, and one of the major example is Neelam Jhelum hydropower project. We used hypothetical data, but very similar to the Neelam Jhelum project. We used siltstone, sandstone, mudstone as to create a model of a folded region, and then we placed a tunnel inside it. This was our model. So you can see here is a section of a tunnel. All of us knows that if this, however, this section will behave, every side of the tunnel will behave similar to that. So we have run some analysis on a section of tunnel, and we will predict similar from other sections of the tunnel, and we have placed in a tunnel in the center of this folded region. This is the center, and we are calling this region as a limb of folded region. As you can see, this wall looks similar to the folded strata. So if we say we present a tunnel right here, that will be in the center of the fold, and if we place at this side of the folded region, that will be at the limb of the folded strata. Here we have a tunnel in the limb of the strata. So we have done some analysis on this on a tunnel in the center of the folded strata and on the limb of the folded strata. So when we ran some analysis on the tunnel at the center of the folded region, uh, we calculated our factor of safety as 7. We do not have the actual data of from Neelam Jhelum project. If we had that, we could have ran some analysis, and we could have get a failed zone. But when we move this tunnel from center to the limb, we can increase our factor of safety, like from 7 to 30. That is much more. So if we have a failed tunnel in the center of the strata, folded strata, and we can change our design line a little bit and move it to the limb of the folded strata, we can increase its factor of safety.
Here are some analysis at flag theory. Results of those shows that the factor of safety is 7.71 in the center and 30.76 in the limb of the folded region. So that's all of about my presentation, and these are the contributors in the publication. Any questions, any queries? I'm here. Any questions? Thank you very much.
Thank you, Heather, for this wonderful presentation about stability analysis of a tunnel in a shear zone. Now, I would like to, we have one all recorded video presentation of Mr. Du Jiang. So, Mr. Mohsin, can you please play the recorded presentation of Mr. Du Jiang? First. This is a recorded presentation.
Sir, video. Video.
I'm Du Jiang from Chinese company Archer. Today, I'm very happy to present my subject in the fourth symposium of young toners of Asia. My subject is the recurrent method of tonal fault collapse. This is a real event happened in my current project. My presentation contains three parts. First, the condition and geology. Second, the collapse. Third, the recovery method for the collapse. Let's go to the first, the condition and geology. This slide shows the normal condition. The above photo shows the direction corner in the project, which contains three parts. Inlet structure including transition section, standard section with a forceful shape, and its line section is 16 meter by 16.7 meter. Outlet structure, including reinforced section. This event happened in the inlet port, and the inlet transition section is designed as gate shape, which is slowly changed to horseshoe shape. And the underground illustration shows to the 80 part of common face and challenge 50.5. It was observed that the geologic condition was parameter and shared. Hence, the contractor stopped the exploration activity and arranged probable holes to pre-understand the upstream geologic condition and further guide the construction activity. And the firm wise of intake, open excavation, and elevation 996 is 21 meter. In total, three gravel holes or orange. Two are located on the axis of the tunnel. Other one is located on the right side of the tunnel. The proper force number 2 and 3 show the full length of tunnel encountered with shared and fractured condition. And number 1 shows the upstream 9.5 meter direct condition is better. After the proper force, but the initial geologic mapping. Additional three geological exploitation hosts are arranged and the hosts are located on the open situation board and elevation 996, those 344. And those 344 directly cross the shear zone area. The core sample also shows that there is a big shear zone and the depths 25 to 40 meters, which is almost matches the unexpected geologic condition. And the depths of 20 to 40 meters, we cannot get the core sample. It shows that there is a not interlayer. After geological exploration holes construction, the design engineer changed the drawing of the eliminated area. Compared with the two papers, we can see the common border further moved towards to downstream 50 to 44 meters award. The details are located on the shear zone, which let the shear zone cross outward. And the current rise of open situation and elevation 996 is changed to 5-meter rise from 21-meter rise. Then, we continuously commit the action of underground exploration. And at the same time, the support force demanded by the designer was obliged to the workplace and stopped at challenge 50.5 meters. It's planned to complete the open exploration first. Then, the remaining tunnel under exploration will be carried out. The left side photo shows the original exposed surface and challenge 50.5. The right side top photo shows the status of the tunnel test after 1 month. A lot of stone material falling down. And then the material is removed and the shutter is applied to surface space. After shaft bridge, the survey is arranged to verify the cavern area, which shows in the sketch. The collapse area is almost reached to the top area. Fortunately, the cover is the section later of the portion shows that the surrounding rock is stable, which decorates the roof of the tunnel. And we also cut off the axis to the portion to provide the person in the cabin area. The second is the collapse. And the first field and the non-collapsing of the take open explosion process, the collapse happen. The first field force are crossed to the canting area, which is not found by before blasting. The left side photo shows the camping area viewed from the home, and the right side photo shows the view from the open area. Number three, the recovery method for the collapse. After survey and a long time study the destination, the following method is performed. One coordinator is set up in front of the phone for preventing gas from going out to the phone, maybe get some damage of the phone. And then backfill the camping area from the top to hold the camping on a port. Excavate the open area 3 meter area and the slope support works will be carried out after each layer is exposed. The contour NIC is also declared the velocity to avoid further impacting the tonal port. Also, additional pendants are arranged to reinforce the port slope. And then the spinning rock boat is constructed to protect the terminal from when reach the exploration design elevation and line 37. Also, it is converting the monitoring workers to guide the construction. Fortunately, and the expose the tunnel for open explosion process. There is no further collapse happening. The left side photo is after failing the collapse, and the right photo shows the growth of the tunnel portal. And the spinning rock holes construction. This photo is posted to the middle half of the tunnel. This event educated us that telecommunication is very important argument for tunnel construction. And the designer can easily change the design drawing to avoid zero responsibility in a short time, but the construction will be long and maybe encounter big risk. And the construction period, good plan is the key to avoid negative risk. Thanks for your attention.
Thank you very much, Dujan, for your wonderful presentation about recovery of a tunnel portal after collapse. Now, I would like to request Mr. Kashif Saab for a very short and brief presentation on a role of a geologist in tunneling. Mr. Kashif, please join us on stage. Over to you. Thank you.
Assalamu alaikum. My name is Kashif Adil. I'm a geologist in Training Institute of Pakistan. I will not take much time. I would just I would like to
Thank you to the management of University of Malakand who gave along with about 30 of the geologists. My topic is basically the role of geologists in tunneling. But due to the shortage of time, I would like to just inform you that from the platform of Tunneling Institute and Trenchless Society, we are doing a lot of efforts. Our outreach is increasing. We are inspiring the geologists and engineers for the tunneling industry. And my last and the shortest message for the audience is keep tunneling. Thank you very much.
Thank you very much, Mr. Kashif, for this short and brief presentation. Now, I would like to call Mr. Ashraf Hussain, our chair of today's event, CIDA 2024, for his closing remarks. He is very tired and
Indeed, I am. Couldn't sleep for the last couple of days and nights. In fact, you were with me. You've also not been sleeping. But anyway, uh, I would like to pay my sincerest gratitude again to the founding members of SITA for making this wonderful platform and enabling us to collaborate on regional level and even beyond that. I am thankful to all the online participants who joined from different part of the world through the air, and I'm grateful to all the physical participants, especially those who presented their technical knowledge here and those who traveled from far, far away. I'm really grateful that with your presence and your participation, you just paid for all our efforts that we've been doing for last 1 month. Uh, I would also like to extend my gratitude to the Vice President and one of the founding member of Pakistan Tunneling and Trenchless Society for his uh, never-ending support and encouraging us to go for making these dreams come into reality when we call for hosting this CITA back in WTC 2023 in Athens. And in that particular year, we were in fact awarded as the official member nation of ITA, 79th member nation. And we were really excited. And out of that excitement, we gave a call for hosting the CITA 2024. And today, I believe we conducted a successful event with technical presentation, keynote speakers, and some notable speakers with some great messages from different aspects and different parts of the International Tunneling Association and different tunneling societies and association around the globe. I'm thankful to all the exhibitors who in no time say yes to our call, and they brought all their stuff to set up the ground floor of Tunneling Institute of Pakistan as an exhibition center. And with that, I will not take much more time before saying thank you to my co-organizing member of the committee, all the physical and online participant who has joined us. Please do not worry about your participation certificates. The presenting participant will be provided with the certificates of invited lecturers, and the rest of those who participated as the participant, they will be receiving their certificates as well. And for the Pakistani engineers having the Pakistan Engineering Council registration number, they will be also able to use those certificates for the record keeping of or record reconciliation of Pakistan Engineering Council for marking their CPD points. With that, I am really tired. We had a wonderful day. I hope we had a blast. You guys enjoyed it. And with this event, I think we were able to give you an idea what actually Symposium of Young Tunnels of Engineer is. and how every year it is hosted by the Asian member nation of International Tunneling Association. We hope that we will be having some calls in the WTC from some member nation, and when it is on air, I would request all, especially these people who are still with us, whether on air or physically here, the students and the practitioner working in the industry, to please participate either as a participant or as a presenter even better. With the minimal knowledge, just let the world know what you are doing in the field of tunneling and underground space utilization. Thank you so much. Have a great evening and see you at some other technical event of Pakistan Tunneling and Trenchless Society. Let's adjourn the session and roam around the facility and move towards our destination.
मुझे नहीं पता मुझे ये जीव में फोड़ रहा था नहीं मैंने ऐसे बंदे चेक किया नहीं वाकई कसम से नहीं आता फोल्डर कर रहा इसने बहुत सारे लोगों को मिस किया ये भी जो मोटी करते थे वो करते याद करने के लिए कंबाइन फास्ट जो बाकी चीज है ताकि वो भी जिसमें प्रेजेंटेशन है वो कंबाइन इसीलिए और इनकी ना वीडियोस देखने अंदर तो आ रही थी उधर आ रही थी स्ट्रीम में
दोस्तों अगर जो कोई ऑफिशियली पाकिस्तान टैलेंट नेशनल सोसाइटी के मेंबर्स बनना चाहते हैं तो अजमत से रब्ता करें और डीजे हेल्प डेस्क पे भी आ सकते हैं आप फॉर्म ले सकते हैं और उनको ऑफिशियली जो है ना सोसाइटी के मेंबर बना सकते हैं तो हमारे एक्साइटिंग इवेंट्स होते रहते हैं टेक्निकल समटाइम्स नॉन टेक्निकल फॉर द फ्यूचर वी हैव प्लान्ड वन मेगा इवेंट इन फरवरी बट उससे पहले हम सोच रहे हैं कि कोई नॉन टेक्निकल इवेंट भी करें we sit together, we come across through YouTube or maybe Zoom or Meet और हम एक दूसरे को बताएं कि यार मैं काम करूँ मैं क्या कर रहा हूँ आया मैं कोई रिसर्च का काम कर रहा हूँ मैं किसी प्रोजेक्ट पर काम कर रहा हूँ मैं टनल पर काम कर रहा हूँ मैं ओपन एक्सहिबिशन पर काम कर रहा हूँ जस्ट टू हैव फन फॉर मेबी लाइक 1 आवर लोग एक मिनट की बात कर लेंगे यार मैं कहाँ से बात कर रहा हूँ मैं कौन और मैं टनलिंग के लिए क्या कर रहा हूँ लेट्स स्टार्ट समथिंग लाइक दैट एज वेल ये भी चलता है Let's march to success. Let's march to freedom. Let's march across Islam to the future leaders of Pakistan. Together we will. Can become the next certified PM. Register now and we'll make sure in next 6 weeks you become PM. You see, we have had 1,600 plus students on customized roadmap, daily follow-up, coaching for stress in the market. The most important, I work with them to become PM. So this can be something very important if you join right now. Get the free training in most important education and no one will have to read books. Register now and let me help you become clear in the minimum possible time. 99% success record. 150 POV only in 2024 and 1500 plus students last 4 years.
क्या जनाब मैं लैपटॉप क्लोज
ये ऑन करो, ये ऑन कर सुना। नहीं ऑन नहीं करना, जस्ट 1 मिनट वैसे ही सब दोस्तों बस प्रेस करो, करने हैं ना सेट मौसम भाई थोड़ा सा करिए, 5-10 मिनट से रेस्ट करो। काट में ये ना करना ऑनलाइन चल रहा है।
साड़ियाँ काफियाँ नहीं होतियाँ, साड़ियाँ काफियाँ नहीं होतियाँ।
सर मैं गलती जान के नहीं किया, सही बात गलती से हो गया। नहीं वो आई लाइट चल
यार जिस चीज़ का ना पता हो उसे नहीं
यार, मैं
करना।
कसम से उठा कर कह रहा हूँ, मेरे जान से जान के नहीं
मेरे लाइफ का ये काम है, ये मैं भागा और मैं आप ही कहते थे होने में आप ही करना।
यस यस यू आर राइट।
ये बात ठीक है, लेकिन हम कम से कम आप सुबह में 5:45 पहुंचा हुआ था, रात को मैं कितने बजे गया था?
2 बजे हम गए थे।
बस यार ऑल अच्छा नहीं हुआ, मतलब जो एक्सपेक्टेड था। बाय द वे मौसम भाई, अगर थोड़े से हालात स्टेबल होते हैं ना, तो आप जानते हैं कि सॉरी फॉर हालात।
मौसम नहीं रात पीछा करेगा रिबन चाहिए था कार्ड जो एक्सपेक्टेड था ना, जितनी मेहनत की थी उसका बस अच्छा नहीं हुआ। कुछ टेक्निकल मतलब वो हमारे हाथ में नहीं थी चीज़ें, तो टेक्निकल प्रॉब्लम ऐसी आ गई, अनएक्सपेक्टेड प्रॉब्लम। ये लैपटॉप हैंग हो गया था। हाँ वो तो अशर साहब का भी बंद हो गया, अशर साहब का लैपटॉप बंद हो गया, ये हैंग हो गया एकदम इकट्ठे इनको कभी दौरा जाने वाली मसला भाई। ओके ब्रो, इसका चार्जर कौन सा? रेस्ट नहीं करनी, आप जानते हैं मैं आई एम द ओनली वन के मैं रेस्ट नहीं कर सकता। आई एम गोइंग, फिर मिलते हैं। ठीक है बढ़िया, कब आएंगे इंशाल्लाह? देखेंगे यार, हमने ना एक और काम नहीं किया लॉन्ग टाइम। करना मैं लेके जाऊँगा यहाँ पे हटी तो कर लेंगे यार। भाई आपका बहुत बहुत शुक्रिया, आपने
थैंक यू सो मच फॉर ऑल।
आपका भी भाई शुक्रिया, आपने गौर ही नहीं किया। मौसम भाई शुक्रिया ऐसे किया कर। हाँ
कौन है भाई? खूबी है, मैं उसके ऊपर कभी रहना नहीं चाहता कसम से। आप ऑफिस नहीं दिखाऊंगा ऐसे इंज नहीं सही है देख ले नो प्रॉब्लम मुबारक होता सबसे ज्यादा मुबारक है मुस्तकाम कामयाब है जुबैर भाई यार थैंक यू वेरी मच। अच्छा अब ये दो चार्जर एक जैसे है ना दिखाएं कौन कौन से हैं। एक ये वाला है ये तुम्हारा और एक ये वाला नहीं वो मेरा है वो टूटा हुआ है वो नहीं है मेरा मेरा ये चार्जर का पता ये मेरा लग रहा है ये कौन सा है पता नहीं ये मेरा इसके साथ वो लैपटॉप वाले दुकान में होती है वो ये जो इधर वाला है मेरा है ये तो उस भाई का वो वाला मेरे लैपटॉप हाँ ये मेरे वो जो आपके हाथ में है ये मेरे लैपटॉप है अच्छा ये वाला ये वो न्यू ये आपको निकाल देंगे आपको ये निकाल देंगे लेकिन ये क्या इसमें तार नहीं लगी ये आपका नहीं है हाँ ये मेरा नहीं है लेकिन इस तरह का मेरा फिर ये है काम रहता है अपन का हाँ ये वाला हाँ ठीक है हाँ ये आप इधर लगाओ वो भाई थैंक्स बड़ी ठीक है वो बाद में फिर जब वो भाई आपका कौन सा ये वाला बस ये तकरीबन 15-20 मिनट और वीडियो चलनी है फिर ये बल्कि ये दे जाएंगे ठीक है वो मंजर ये क्या ऑनलाइन का सिर्फ ये चार्जर ये वाला है हां चार्जर यही वाला है ये इसका जिम्मे ये कर लेगा अस्सी की मसलियां दे हैं नहीं अस्सी की मसलियां दे कोड पा के होना तू टाई ते कोड ते मैं ले हां एंड नहीं हां इधर है मैं भी मंडी बात नहीं था गुस्सा आज बोलो ये वीडियो वीडियो ना इंग्लिश बोलो दो चार हम याद कर लो नहीं वो क्लियर है वही है वो बोलने शुरू कर रहे हैं अच्छा सारा दिन सोच कर ही याद होंगे क्या बाकी आसानी आसानी नहीं वैसे आसानी है तो मोटरवे बंद से जड़े तेरी पढ़ाई नहीं मोटरवे जड़े ने उन्हें याद करेगा तो नाम जाएगी ऐसा बर्बाद होगा लाइट नहीं आती
ओए वैसे तेरे ही तो पैंट कोट दे ते ओ एलसीडी दे रंग कोई फर्क नहीं नजर आ रहा कितने यहां भाई जी बस करो ना ਤੁਹਾਡਾ ਮੋਬਾਈਲ ਸਾਰੀ ਤੁਸੀਂ ਹੀ ਬਣਾਉਣੀ ਹੈ ਨਾ ਤੇ ਤੁਸੀਂ 800 ਨਾ ਤੇ ਅਸੀਂ ਬਹਿ ਕੇ ਬਣਵਾਉਣੀ ਹੋ ਸਨ ਕੇ ਪਤਾ ਸੀ ਨਾ ਕਦੋਂ ਬਣਵਾਉਣੀ ਹੋ ਸਨ ਇੱਕ ਸ਼ਰਤਾਂ ਤੇਰੀਆਂ ਫਿਰ ਸਿਰਫ ਤੇਰੀਆਂ ਬਸ वजह का इस बार में दसना सब जमीन और आगे तू तस्वीर बनवाने वाले पास आ भी बात यार ना मुक्सा तुझे मेहरबानी करो फोन ਤੁਹਾਡਾ ਤੇ ਵਾ ਤਸਵੀਰਾਂ ਤੁਸੀਂ ਬਣਾਉਣੀਆਂ ਨਾ कोड नहीं आ रहा फौरन ला यार ये नहीं है मैं आप तस्वीरें बनवानी मैं दो मैं बड़ी कुर्सी दो तस्वीरें एक तस्वीर या दो तस्वीरें एक वीडियो बस ज्यादा नहीं मैं हर यार को नहीं करना तू ही बनवाना उड़ता तावी बनाना देखता तावी कोई और इसने दो दिन बनाई गया ना तो जरा इसके ना क्लियर कर बात इधर से अपलोड स्टार्ट करें वो तो नहीं करेगा बड़ी वो तस्वीर हमें है और मोबाइल लगा मैं बकाने से बोल पता चल सी तू मतलब है ना ध्यान रखना है प्रेजेंटेशन मैं बोल ध्यान लगे प्रेजेंटेशन तो लगे का ध्यान लगे तू ना पता चल तू प्रेजेंट कर रहा है यार तो एक तस्वीर का बड़ा है पूरी याद है पूरी थोड़ा और पता लगे आप ये सारा आइए अच्छा है ओ और मोबाइल होल्डर का काम है यार अट्रैक्टिव तस्वीर सीधा मोबाइल अट्रैक्टिव का मतलब वो नहीं होता सीधा सीधी सॉरी और तो ये थी वीडियो ठीक है अल्लाह जितना नहीं तो कैसे मैं टिश्यू की दुकान दसना है और टिश्यू यार तो तू ले ले आई मोबाइल तो ले ले ऐसे तेज करना बाकी को अगर पसंद आए चीज तो आप यार और आगे कैमरे सिर्फ तेरे पास लोग हैं बस तू सुबह बैठे आई दिन अपना एक है तो लैपटॉप में है अच्छा ये क्या करने खाने में क्या सोच रहा है ऐसे सेम ठीक है तुम्हारी गैस है ना मतलब ये ठीक है तो लैपटॉप तो नहीं है कोई है जापान से और तू 10 सेकंड की बनानी है ना तू 10 सेकंड से यार मेरे तो 10 सेकंड रोक एक 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 आपकी आ जाओ भाई यार कौन सा बंदा सिलाई सही करता है यहाँ पे क्या क्या कटी है ये सी कटी है ये क्या एक तो सुबह ने चिकेस बने यानी ये सुबह ने चिकेस बने बस करना तो क्या नाम न्यूज़ चैनल है मैं उधर बैठना तो बैठ वो बड़ा चंदा नहीं ओ ठीक है 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 नहीं ये ये नेक्स्ट है नहीं उधर नहीं बॉस भाई मैं लेके जा रहा
किसके साथ ये किसके साथ है
तू मौसम में समझा ये सरकार है तो ना ये समझाना मौसम की इशारा कर ये जो बोल सीरियस खड़े हो एक यार अब तो फोकस ऐसा बोलिए मैं प्यार हो गया पहले ये आवाज में सोनी कुड़ी यूज कर रहा है और दिखो भी ऊपर ठंडा क्या हो रहा एक मिनट तू नहीं हंसी सकना फोटो लाने नहीं लाने मोहसिन सर तुझे भी जितने से मारते थी होती अब तू दिल कोई और चीज समझ रहा है यार ये नहीं हो गया अल कर्नल दा खबा तू सजा हाथ तू टकला तू तीसरा तू सेंटर वाला भाषा मां मां जेड़ा वजदा जाके ना ना वीडियो वाली वो बस करो ये दियो साहब हो गया खुसरे का मुंडा होया मैं चौक चौक मार दिया कोई भी मैं तुझे सीधा के क्यों मारा मुंडा क्यों मारा मुंडा तुझे कुछ नहीं बदतमीजी करना है अब बट तू सर हमारी नहीं हेलो ऐसे हाथ बना इतने लाया तो तेरी काम जो है गॉडी हर पास से आता नहीं यार मौसम सारा बैग नहीं हटाया पे आया
ठीक है ठीक है
एक बार अगर अच्छा रिस्पांस होगा कॉल करना देखो पैरा भी होता है
चल अपने लैपटॉप मैंने अपने लैपटॉप
एक दो ये मैं बंद करेंगे वो अगर
नहीं नहीं वो सर ने कहा ये चलती रहेगी
कब तक
बस चलती रहेगी
अच्छा बाकी जो कुर्सियां ला छड़ियां ने बाकी यार अरे दादी भी गाँव ना और रेडिंग को रेडिंग फोटो बनाए सिनेमैटिक की वीडियो 3 है सिनेमैटिक को सब और सिनेमैटिक जो मैं भी हो बार बनवाना सीन बनवाना लटक ना सिनेमैटिक की वीडियो है ना वीडियो लगा है पर वो नाल तो सीन एक यार एक और लाल की है नहीं मतलब यार यार और वो मतलब यार इधर
एंगल नहीं ठीक तो इस मैं भी प्रॉब्लम को आ रही गलत एंगल से मैं ये यार वो मेरे बहुत खराब हो रही है मेरी तो उंगली में हट कर करके साथी दे रहे हैं अल्लाह का देती
2x पे बनाना थोड़ी
सब्र करना डिजाइन भी मेरा स्टाइल भी मेरा काम भी मेरा याद रहेगा मुझे ये तेरा भाई ने डिजाइन जबरदस्त ਤੁਸੀਂ ਤੇ ਸਾਰਾ ਹੀ ਮੈਂ ਕਹਿੰਦਾ ਲਾਹੌਰ ਕਰਾਚੀ ਪਿਸ਼ਾਵਰ ਸਾਰਾ ਕੁਝ ਹੀ ਮਿਕਸ ਕਰ ਛੱਡਿਆ ਦਿਮਾਗ ਉਹ ਬੜਾ ਚੱਲਦਾ ਮੈਂ
ਇਹਨੂੰ ਜਾਓ ਬਹੁਤ ਪੜੀ ਫੋਟੋ ਬਣਾਣੀ ਆ ਸਾਰੇ ਫੋਟੋ ਬਣਾਣੀ ਜਿਹੜੇ ਫੋਟੋ ਐਡਿਟ ਨਹੀਂ ਬਣਾਣੀ ਫੋਟੋ ਐਡਿਟ ਦੀ ਫੋਟੋ ਬਣਨੀ ਉਸ ਭਾਈ ਫੋਟੋ ਦੀ ਫੋਟੋ ਬਣਾਣੀ ਬਟ ਇੱਕ ਵਾਲੀ ਬਣਾ ਕਰ
बहुत प्यारे आ रहे हैं तीनों बहुत प्यारे आ रहे हैं बालाजी को देखो
काटी इस्लाम में ना पटिए
बहुत प्यारे फोटो वाले ऊपर देखो बंगा जी ऊपर देखो इधर देखो
अरे देख लो ना टिश्यू भी आउट देता है
यार ताकत मुंडा वो ले हुए एक्शन मान मान
मैं चेक कर रहा हूं
यार ये एंड बाजू करना है इनका
तो लैपटॉप सामने और ताओ सीधी नक पता होना ना मेरा करा और एक प्रेजेंटेशन दे रहा है फोकस दूर हो रहा है अच्छे कितनी बैठ ना ना चलने बहुत पटी इसने कोटा में वो मेरे कहने के साथ खड़ा हो
बड़ी तरह नजर है
ओके
इधर तो क्या
उसका बाकी कोड ना एक मिनट ना ना लैपटॉप वाले वीडियो ना जस्ट वीडियो हां नहीं
तो नहीं थल्ले मारना तेरी वीडियो इतनी जबरदस्त
बनी में
रनिंग में कौन है आज ये
पटी और बट्टी यार और मैं साइनराइड की वीडियो
वो मौलवी साहब आ गए
मैंने जब मांगा रनिंग
मैंने कब मना किया था मैं ये नहीं कह रहा नहीं मैंने वो नीचे से वो उठाई जरा वो यूएसबी गिर हाँ बहुत प्यारी फोटो थोड़ा सा लैपटॉप इधर
यार वैसे इधर आको भाई चल तू चले जाओ यार चले मैंने यार
जल्दी थोड़ा सा लैपटॉप इधर
नहीं स्माइल
स्माइल ही है ना यार और कैसे स्माइल करूं वालेकुम सलाम
ये आप मेरे सर है सर आप इस
मौलाना साहब ਤੁਹਾਨੂੰ ਬੰਦੇ ਤੇ ਨਜ਼ਰ ਹੀ ਨਹੀਂ ਆਉਂਦੇ ਨਾ ਫਿਰ ਵੀ ਆ ਗਏ
और सारे एक्सेल में लैपटॉप एक ही यार सारे
गोली लाइट बंद करो। ओ सुना ना, ये रहा वो बड़ी लाइट नहीं है, वो यहाँ पे लगाई, यहाँ का लाइट बंद करो। नहीं ठीक है, तो फिर नल
तो एक्सेल का मोबाइल भी एक ही यार लैपटॉप
खैर है। लैपटॉप की जरूरत
और ये सीवी पे लाई है, सीवी खाली नहीं स्पेन लाई उससे लाई सीवी
है। स्पेन को थे आप
स्पेन
ये
को
हो
हाँ
गया का जाने की आ जाते तेरे साड़ी कौन यहाँ पे खाली
तो यार भट्टी बाहर एक वीडियो बना हुआ था बड़ा
कोई पटी यार, कोई पटी लैपटॉप बंद करी कर तुम साहब ओए ये
यार ना बाहर ये लैंटर एक बड़ा हुआ वाला बड़ा यार
बात ही जाना तो
नहीं सीरियस बात कर
कौन सबर कर मेरे बच्चे सुन प्यारी है ये लाइटिंग सही आ रही आ जाओ किधर किधर कर रहा है बस भाई के सारा लोग
यार बॉस भाई और तो यार ले लेगा
क्या क्लोज है क्या ना करी फिलहाल वीडियो सेव हो गई सारी चले इसमें हर चीज डाटा ओके प्लीज भाई थैंक यू वेरी मच फॉर टाइम कीप कैप्टनिंग कीप ड्रॉपिंग ये हो गया ना तो पैसा नॉमिनल कर रहे हैं कुछ भी नहीं मालूम कितने का हो सकते हैं कौन से बेटे आईटी कौन सा आईटी वो वाले ना पास पीछे साजे जनता सारी वीडियो बात मारी ये तो प्लीज भाई जी कौन कर रहा है
बताइए देखिए लोग भी काम कर जाएंगे लोगों को पता है और साथ नहीं मान भेजे जी ये नाम का इसको दूसरा ये लोग और मामा वो आप रखे पे मैसेज आ आसान सी वजह कुछ भेजो ये आज बड़ी दो तारीख को भेज सकते कौन जाती कौन जाएगा पूरा ये भाई जैसे ऐसी काम करने पे भाई ये ऐसी काम करने बड़ा काम है मेहरबानी सारे टेबल दिखा दो ना क्यों मामला वो घरे रख देने
ये जो सीप का है, सीप नहीं है, प्रेस। मौसम भाई को जस्ट नहीं आई वैसे, है ना? जितना हमने भाग दौड़ की है और जितना वो क्रेज था ना, तो पता है इस इवेंट का, इस लेवल के इवेंट का, इन चीज़ों का फर्स्ट एक्सपीरियंस था। नहीं नहीं, उस चीज़ की मैं कह रहा हूँ, हाँ वो हमें चीज़ें पता चल गई हैं। नेक्स्ट जो मतलब कि क्यूरीज आई हैं वो नहीं आएंगी, बस है बंद करने आ गए। समझ रहे हो, ये काम करती हैं बड़ी बड़ी कंपनीज। यार मैं आता हूँ जरा बाहर से डिस्कशन करके उसी मामले में।
किस मामले में? कौन सा मामला?
कहते हैं उसका मज़ा आया नहीं।
कौन कह रहा है मजा?
ये बिलाल ना, को प्रोफेशनल बहुत बड़ी कंपनी थी
यार मैं
इतने
कहता
बड़े
हूँ
इवेंट
जितना हमने ऑर्गेनाइज किया है ना,
और फर्स्ट चार चार जगह ऑनलाइन चल रहा था हमारा सब। और रोटी खा लेना यार, एक बस मैं चीज़ें क्लोज कर लूँगा, ठंडी हो जाएगी, पता है लोग अगर रोटी शुरू कर
क्या है? ये भी ऑफ कर दी।
अभी ना करिए ना, देखना मैं घर के आइडिया लोगों ने तोड़ दी थी गिनती मतलब जो मेरा लेवल था ना, सबूत बढ़ के बहुत ज़्यादा बढ़ के। फर्स्ट एक्सपीरियंस ये जो जितने इंटरनेशनल इनके इवेंट्स होते हैं मौसम की पता है ओई दसा कमरे दसा ये मंजर की मैं इसने बैग किथे है नहीं नहीं ये मेरे उसना है ये उठे पे सर्वर रूम में